Lori ma'am. Lori ma'am. Good morning, sir.
Hello.
Morning.
Has sir joined?
Yes, I'm here,
Hello?
ma'am.
Yes, ma'am. Yes, ma'am. Sir has joined.
Okay, I have. Okay, thank you. Good morning, sir. Hello.
Good morning, ma'am.
Good morning, sir. Shall we start our program, sir?
Sure. Yes, I'm ready.
Okay. Jenny?
Yes,
Hello,
ma'am.
Jenny. Shall
Yes,
we
ma'am.
start our program?
Shall we, ma'am? We have 5 more minutes, but shall we start?
Doesn't matter if everybody has joined, no problem. We will start early.
Okay, ma'am. Then we shall start.
Okay. Diana has come.
Yes, ma'am. Diana ma'am is here.
Then we will start. Let them join. Okay, others let's join.
Okay, ma'am.
Sir is ready, no?
Yes, ma'am. We shall start. Good morning, everyone. Welcome back for the second day International E-Conference on Recent Trends in Science and Technology, organized by the Marian Star Center, Department of Botany, St. Mary's College, sponsored by the DBT Star College program. Let us start today's program by invoking the God's blessings.
Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. Our Father,
Let us start our session 4 today by introducing the resource person, Professor Anand Narayanan from Trivandrum. May I now invite Dr. Diana Lobo, Assistant Professor of Botany, to introduce the resource person.
Jenny, I am audible?
Yes,
Jenny?
ma'am, you are. Yes, ma'am.
Yes,
It's audible.
Yes. A very warm good morning to everyone connected here on his virtual platform. It gives me immense pleasure in introducing such an erudite personality to this august gathering. Dr. Anand Narayanan is an efficient person currently a professor working in Indian Institute of Space Science and Technology. He has also worked as an assistant scientist in the Department of Astronomy, University of Wisconsin. He was a graduate researcher in the Department of Astronomy and Astrophysics in Pennsylvania State University. He completed his PhD in Astronomy and Astrophysics from Pennsylvania State University in the year 2008. He qualified his MSc in Astronomy and Astrophysics from Pennsylvania State University in the year 2004. He graduated in Technology in Electrical and Electronics from College of Engineering, Thiruvananthapuram in the year 2001. During his long teaching career, he has almost offered more than 25 courses, such as Astrophysical Concept, Galaxy Structure, Dynamics and Evolution, Introduction to Astronomy and Astrophysics, Cosmology, Research Methodology, Planetary Sciences, Basis of Astrobiology, Universe in a Nutshell, Data Analysis, Astronomy Night Sky Lab, etc. And many more to the students' community to enrich their learning experience. His research over the years has involved studying the physical properties of gas outside of galaxies in the circumgalactic medium and intergalactic space from the distant universe to present. He has published 29 research papers in reputed internationally acclaimed journals. On behalf of PG and Research Department of Botany, Stars College Scheme, Management, staff and students, I wholeheartedly welcome, sir. It is my great privilege to welcome our Secretary, Reverend Sister Flora Mary, Principal, Reverend Dr. Sister A.S.A. Lucia Rose, Deputy Principal, Reverend Dr. Sister Shivana, Director of Self-Supporting Courses, Reverend Dr. Sister Mary Joyce Baby, Controller of Examination, Dr. Oroke Mary, Deans and Heads of various departments. I also welcome Dr. Glory, our Department HOD, Dr. or Sister Oroke Denisius Alphonse, Overall Coordinator, Member Secretary, Deputy Star College Scheme. I welcome all the eminent professors, research scholars, students from our and other colleges. Now, I welcome Dr. Anand Narayanan to address the audience on the topic Research for Planet Beyond the Solar System. Welcome, sir.
Thank you. Good morning, everyone.
Good morning, sir. Good morning, sir.
Good morning, yes. So let me say that it's a great honor and an absolute pleasure for me to be a part of this e-conference on trends in science and technology, recent trends in science and technology. I would like to thank the Department of Botany and Dr. Glory for extending invitation for me to be a part of this. So I see from the program brochure that the e-conference is covering a wide range of topics from renewable energy to liquid crystals to RNA analysis. So my presentation is going to be on astrophysics, and I teach and I do research in astrophysics at the Indian Institute of Space Science and Technology, which is a deemed university under the Department of Space, Government of India, and it is located in Thiruvananthapuram. So I hope if all the students are going to be students of biology or botany, then some aspects of this presentation may not be easily accessible to you, but I will try to make it as simple as I can. And I believe I have 1 hour for the presentation, right? So I can go on till 10:30
Yes,
or yeah, right. Okay, thank you.
Yes.
So I'll start sharing my screen. Okay, is the screen visible?
Yes, sir.
Thank you. Yeah. So what I'm going to talk today is one of the most fascinating adventures that has been unfolding in the field of astrophysics for the past 25 years or so, which is the discovery of planets beyond the solar system. So these are planets that are orbiting other stars, and these planets orbiting other stars, they are collectively termed as extrasolar planets or exoplanets for short. And so this is a relatively recent field of exploration or research in astrophysics. And this, the discoveries that has been happening in it has been getting a lot of press and public attention, and rightly so, because finding planets around other stars directly feeds into one of the most profound questions that has occupied the human mind for hundreds of thousands of years, which is the question of whether we are alone in this universe. As far as we know, life, the phenomenon of life that we know is only present on Earth. We are not absolutely sure whether there could be the phenomenon is solely confined to Earth, or whether it could be present in some distant corner of the universe, on a planet that is similar to Earth. So this is one of the questions that astronomers have been trying to answer, that whether we are alone in this universe, or could there be a planet somewhere else in the universe orbiting a star like the sun, where conditions are favorable for life to arise and survive. Okay. I think somebody's microphone is on other than mine. Just mute it. There's some cross voice that's coming over. Yeah. Okay. So, so this is why the discovery of planets around other stars has been is of tremendous importance, because if at all we are going to find life as we know it here on Earth at some other part of the universe, then it is going to be on these extrasolar planets. Okay? So, so with that as the introduction, let me just move on to the presentation. Okay, so one of the first things we learn in school when we study about outer space are the planets of our own solar system. And we know that there are 8 planets in the solar system if you discount Pluto, etc. And we have the inner planets of the solar system, which is Mercury, Venus, Earth, and Mars. And these are all made of rocky material. Okay, whereas the outer planets such as Jupiter, Saturn, Uranus, and Neptune, they are made of gases. Okay, they are predominantly made of gases with cores that are made of ices. So the reason why we have rocky planets in the inner part of the solar system and gaseous and icy planets on the outer part of the solar system is because closer to the sun, the temperatures are higher. So only non-volatile elements can condense to form planets, whereas further away, ices and gases can condense to form planets. So based on this one example of our solar system, for the most part of the history of astronomy, this is the only planetary system that we had information on, and all our ideas about how planets form around stars, all our theories about how planets form around stars were based on this one example of our solar system, where we have rocky planets in the inner part of the solar system and large gaseous planets on the outer solar system. So the formation of planets for the most part of the history of astronomy was based on just this one example of our own solar system. And the reason is because astronomers did not know whether planets exist around other stars or not. Okay. But we know that Sun is not the only star in our galaxy. There are roughly 200 billion stars in our own galaxy, and Sun is just one star in this vast galaxy of 200 billion stars. So here is a photograph of the night sky, and on the foreground is a telescope that it's called the Himalayan Chandra telescope. It's a telescope that is owned and operated by the Indian Institute of Astrophysics in Bangalore. In the background, you can see a very starry sky. So I just wanted to I just wanted to show this picture to tell you that there are untold number of stars in the sky, okay? And Sun is just one star in it. So there is no reason why our solar system has to be special. Okay? I mean, Sun is just one star. So for a long time, astronomers have been speculating that there could be planets around the stars that we see in the night sky. Okay? So if there are planets, then the question is, how do we go about finding those planets? How do we go about finding these exoplanets or extrasolar planets, which are planets orbiting other stars, okay, beyond the confines of the solar system? Now, as it turns out, it's not very easy to discover planets around other stars. There are some great barriers, or there are some great challenges in finding planets around other stars. So I'll first explain what are the challenges, what are the observational challenges in finding planets around other stars, and why it took us such a long time for astronomers to discover extrasolar planets. So this is an image that some of you may have probably seen. Okay, this is an image that was circulating in social media for a very long time. This particular image is an artist's impression of the sun and the planets of the solar system drawn to scale. Okay, so this is the sun right here, and these are all the planets of the solar system. You have Jupiter, Saturn, and all the other planets. So the purpose of showing this picture is to remind ourselves that planets are incredibly small when compared to stars. For example, Jupiter, which is the largest planet in the solar system, is still 10 times smaller than the sun. That means that you can put 10 Jupiters from one end of the sun to the other end. Okay, so that's how big the star, the sun, is compared to even the biggest planet in the solar system. If you take the case of Earth, you can actually fit 100 Earths from one edge of the sun to the other edge across the diameter. So that means that Earth is 100 the size of the sun. Okay. So planets are incredibly small when compared to stars, and coupled to that is the fact that the stars that we see in the night sky, they are at enormously large distances from us. Okay, so the stars that we see in the night sky, they are 100 or 1,000 or 10,000 or more than that, light years of distance from us. So light year, just to remind you, is the distance that light travels in 1 year. Okay, in astronomy, distances are not usually referred to in kilometers or meters because the numbers are very large. So it becomes very cumbersome to, if you start writing distances in astronomy in kilometers or meters. So instead, it is distance in astronomy is usually mentioned in terms of light years, and it's the distance that light travels in 1 year. So that means traveling at a speed of 300,000 kilometers in 1 second, how far does light reach in 1 year? Okay, so that's 1 light year. So these stars, it's a large number. A light year is a very large number, and these stars that we see in the night sky are hundreds of thousands of light years away from us. So from those large distances, even a big star is going to look like a dot. Okay. It is going to look like a point source in the sky. So even if you use a large telescope, we are not going to see anything more than a dot if you look at these distant stars. So the star, which is a big object, because of the large distance that separates us from the stars are going to look like points. Now, the planets that are orbiting around these stars, which are much, much smaller than the star, is therefore going to be much smaller than a point itself. Okay, so that's what this video shows. Okay, so this is, let's say that this is a hypothetical star-planet system. This is just an animation. This is not real data. So this is a star-planet system. Okay, the planet is very small compared to the star, and the star itself is at very large distance from us. Light itself will take 100,000 years to reach us from these distant stars. So if the star itself is going to be a point source, then the planet that's orbiting the star is going to be smaller than a point. And along with it, there is also an additional disadvantage, which is that stars are extremely bright when compared to planets. Okay? Typically at visible wavelength region. I'm sure all of you have studied the electromagnetic spectrum, which goes from radio wavelengths to gamma rays. So the visible part of the electromagnetic spectrum is what the human eye perceives, what the human eye sees. So the visible part of the electromagnetic spectrum, in that visible part, a star is typically 1 billion times brighter than a planet. So what that means is that if you were to point a telescope at a star with a planet that is going around it, for every billion photons, a billion is 1 followed by 9 zeros. Okay, for every billion photons that you get from the star, you're going to get 1 photon from the planet. So there's a huge contrast in brightness. Okay, so all these facts together make the detection of extrasolar planets a huge challenge. Okay, the star itself is a point source. Planet is going to be a smaller than a point source. The star is extremely bright when compared to the planet. It's usually 1 million to 1 billion times brighter. So the common analogy that people use is it's trying to photograph an LED light that is next to a floodlight. So I'm sure all of you have seen the huge 1,000-watt bulbs that illuminate the stadiums. Okay, the floodlights that are used in stadiums, and the floodlight bulbs usually have a wattage of about 1,000 watts. Now imagine that there is a tiny LED that is glowing next to it. Okay, when you look at it, you will not be seeing the LED. You'll be, because the LED's light will be lost in the brilliant glare of the stadium light. Okay. So that's exactly the situation here, the tiny planet, the small amount of light that we get from this tiny planet will be lost in the brilliant glare of the giant stars that they orbit, which means that finding extrasolar planets through direct imaging, through photography, directly seeing extrasolar planets is a huge challenge. Now, as it turns out, there are some, but that doesn't mean that we cannot find planets around other stars. As it turns out, there are some really good, really efficient, indirect ways of finding extrasolar planets around other stars. Now, these are called indirect methods because in these methods, which I will describe in a minute, in these methods, we don't directly see the planet around the other stars. Okay, what we end up measuring is the star itself, and based on some behavior of that star, we infer the presence of a planet around it. Okay, so that's why it's called indirect method. We don't directly see the planet, but our observation is confined to the star, and based on some peculiar behavior of that star, we come to the conclusion that there is a planet revolving around it. So that's why these are called indirect methods, because you're not directly seeing those extrasolar planets. And two of the most efficient indirect methods for finding exoplanets are the radial velocity method and the transit method. These two methods have been the most successful or the most efficient methods for finding planets around other stars. I will describe each one of them. The rest of the presentation is mostly going to be about that. I will describe radial velocity method in some detail and transit method in a little less detail. Okay, so let's start with the radial velocity method. I'll go through the basic physics of radial velocity method. It's not very complicated at all. Okay. So this is a picture from an 8th standard textbook. Okay, and I'm sure all of you have seen a picture like this. Okay, so the picture like this is usually shown in a physics textbook when they talk about the topic center of mass. A center of mass is the point that you can weigh, you can balance the weight of these two people. So if you have two people sitting on a wooden plank, and if these two people are of equal weight, equal mass, then the center of mass will be at the center of this plank. Okay. Now, if the two people who are sitting on two sides of the wooden plank, if they have unequal weight, if one person is really big compared to the other, then the center of mass will be shifted closer to this person. So that's the essentially center of mass. You can think of it as the point of balance. Now, this idea is what is going to help us to understand this radial velocity method. So, as I already mentioned, a star is usually 1,000 times more massive than the planet. So, here is a star and there's a planet. Usually, we think of the planet as revolving around the star. Okay, we say that the Earth is going around the sun, or Mars is going around the sun, or Jupiter is going around the sun. That statement is not fully correct. Okay, what is happening is that the planet is actually going around the center of mass of the star planet system. So Sun and Jupiter, if you take, there is a center of mass to it. And Jupiter is actually going around the center of mass of the system. Now, as it turns out, in the case of our solar system, since the Sun is much more massive than Jupiter, the center of mass of the Sun-Jupiter system is inside the Sun itself. So therefore, it's okay to say that the Jupiter is going around the Sun. Similarly, if you take Earth and Sun, okay, a Sun is really massive when compared to Earth, which means that the center of mass of the system is going to be even much more inside the Sun, very close to the center of the Sun. So, very loosely we say that Earth is going around the Sun, but actually Earth is going around the center of mass of the system. So this center of mass of typically star-planet systems, it's called the barycenter. Now, what is interesting is that as the planet goes around the center of mass of the star-planet system, the star will also be going around the center of mass. That's because there is a mutual force of gravity between these two. And the gravitational force is what keeps the planet in its orbit around the star. The planet so the star exerts a gravitational force on the planet, and the planet in turn exerts the same amount of gravitational force on the star, gravity being a mutual force. So the star will not be stationary. As the planet revolves around the star center of star-planet system center of mass, the star will also be going around the center of mass. Now, in most cases, as I mentioned, the center of mass will be inside the star itself. Okay? So you will not see the star moving much, but suppose Okay, let's suppose we say that there is a planet that is sufficiently massive such that the center of mass is outside of the star. Then if you are looking at such a system, okay, then as the planet revolves around the star as shown in this animation, the star will also be going around in tiny circles around the center of mass of the system. So that is what so there's some crosstalk that's happening. Yeah. Okay, so microphone is on. You can just mute it. Okay, so this animation shows that when the star is going around the center of mass and of the star planet system, and so it's not stationary, but it's going around in these tiny circles. This motion of the star going around in these tiny circles because of the gravitational pull from the planet, okay, this is generally referred to as wobble motion. Sometimes it's referred to as wobbling, or sometimes it's referred to as reflex motion. These are all terms that people use to talk about the fact that the star is not stationary, but in fact it will be going around in circles if it has a companion, like a planet. Okay. So, and it is this wobble motion that is measured in, it is this wobble motion that's measured in radial velocity method. Okay. So astronomers try to look at a large number of stars and they try to see which stars are exhibiting this wobble motion. If the star is exhibiting a wobble motion, then it's an indication that there is a planet that is going around it. So let me just explain this a little bit more. Let's say that this is a star, okay, and there's a planet. Okay, I think somebody is annotating on the screen. I think maybe we should. So there's a star and there's a planet that is going around the star. Okay. Now, as I mentioned, there will be a center of mass for this star planet system. The center of mass will be outside the star. And let's say that we are recording a spectrum of the star. So what is shown in the bottom in a large range of colors is the spectrum of the star. And just to remind you what a spectrum is, okay, if you have a source that is emitting light, okay, if you collect that light and send it to a spectrograph, which has a dispersing element like a prism. I'm sure all of you have done this experiment where you split white light into 7 different colors. So the prism is called a disperser because it splits the light into its component colors. In the same way, if you're looking at a star and if you collect the light from that star with the help of a telescope and you send it to a spectrograph, the spectrograph is going to disperse the light into its component colors and you'll get a spectrum of that star. Okay? And interestingly, the spectrum of stars have absorption lines like what you see here. So every dark line that you're seeing is an absorption line that is produced by atoms and ions on the surface of the star. So these absorption lines occur at certain specific wavelengths. And so as shown in this animation here, if we are constantly recording the spectrum of a star, constantly monitoring the spectrum of a star, and if that star is not stationary, if it is going around in small circles, okay, then when we look at the spectrum, we will see that the spectrum is shifting towards higher and lower energies. So this is called blue shift and red shift, something that you must have studied in school. Okay, so when the star is coming towards us, the light will be shifted towards blue wavelengths, which is what we refer to as blue shift. And when the star is moving away from us, the light will be shifted towards lower energies or longer wavelengths, which is what's referred to as red shift. So if the spectrum of a star is exhibiting constantly a blue shift, red shift, blue shift, red shift in a cyclical manner, okay, the spectrum of a star is repetitively showing this blue shift and red shift, a systematic blue shift and a systematic red shift, then that's an indication that the star is not stationary, but neither is it going away from us, nor is it coming towards us perpetually, but instead it's going around in tiny circles. Okay? So this is how astronomers measure the wobble motion of these stars by recording the spectrum. What you're looking at here is an animation. Okay, this is not real data. This is just an animation to illustrate the physics behind radial velocity method. As I mentioned, okay, this is an indirect method, which means that we cannot see the planet that is going around the star. In this animation, the planet is shown for illustrative purposes, but in reality, we don't see the planet. Our observation is entirely confined to the star. So since many of you are probably not from astronomy or physics background, I'll just show you how a telescope looks like and how a spectrograph looks like, because a telescope and a spectrograph are the instruments that are used for measuring this wobble motion of stars. So here is a picture of a telescope that belongs to the Indian Institute of Astrophysics in Bangalore. This telescope is located in a place called Hanle at an altitude of about 4,500 meters above the sea level. So this is in the Leh region of Ladakh, which means it's in the northernmost part of India, very close to the Chinese border. And the Indian Institute of Astrophysics in Bangalore operates this telescope remotely using dedicated satellite communication links. So this is the outside structure of the telescope. If you go inside this structure, you can see that inside this dome is a telescope. So what you're looking at here is the telescope that is inside the dome structure. This is the Himalayan Chandra telescope. And the purpose of this telescope is to collect light from objects in the sky. So whether we are looking at planets or whether we are looking at stars or gas clouds or whether we are looking at distant galaxies, the purpose of the telescope is to collect the light and focus it. Okay? The light that is collected by this telescope is sent to a spectrograph. So here is a picture of a spectrograph. This particular spectrograph photograph is of the high accuracy radial velocity planet searcher, HARPS. It's a spectrograph that has yielded a lot of exoplanet discoveries. It's played an important role in the discovery of extrasolar planets. So you can see here that there is a cylindrical chamber, and this cylindrical chamber is a vacuum cylindrical chamber, and inside the cylindrical chamber are the optical elements of a spectrograph. So if you split this cylinder open, you will be able to see the optical elements of the spectrograph. Okay, so there are lenses, there are mirrors, there are dispersers. Usually gratings are used as dispersers to split the light into component colors, etc. So there is a lot of complex engineering that goes into the construction of telescopes and its auxiliary instruments like spectrographs and CCD camera, etc. Just wanted to show you a glimpse of what happens behind the scenes. Okay, so now let's come back to radial velocity method. So I'll just quickly explain the physics of the basic physics of radial velocity method, how it leads to estimation of properties of the planet. Okay, so let's say that this is the star, and this plus sign here indicates the center of mass of the star planet system. Okay, so I have not drawn the planet here, but there is a planet around the star, okay, which is orbiting around the center of mass in a much bigger orbit. And the star, because it's very massive, it is going around in a smaller orbit around the center of mass. Now let's say that this person is us. We are the observers. So this is us here, and we are looking at the system from top. Okay. Now, when we look at the system, when the star is here, okay, its velocity will be pointed like this. Its velocity vector will be tangential to that point. Okay, and that entire velocity is pointed towards us. So if you are recording a spectrum of the star, we will find that the entire spectrum is shifted towards higher energies, which means there's a blue shift. Okay. Now, after some time, as the star will reach this particular point in its orbit around the center of mass, and if you draw the velocity vector will be once again tangential to that point, and this is how the velocity vector would be. And you can see that the velocity vector is not pointed in our direction. Okay? It's pointed perpendicular to our line of sight. So this is our line of sight. and the velocity vector is perpendicular to that. So it's not pointed along our line of sight, which means that we will not see any shift in any blue shift or red shift. We will not see any shift in the spectrum. Now, after some time, the star will be here and the velocity vector will be pointed in the opposite direction. So now we can see that the velocity vector is pointed exactly opposite to the line of sight. So which means that if you record the spectrum of the star at this instant, the spectrum will be entirely red shifted. Okay, when it was here, velocity vector was pointing this way and it was blue shifted. When it's here, it's pointing this way. So it is going away from us. So it's red shifted. And after some time, the star would be here. Velocity vector will be like that. And it is not directed towards us or away from us. So there will not be any blue shift or red shift. Okay, now if you take any arbitrary point within this orbit, okay, like what is shown here, this will be the velocity vector, okay, at that point, and the velocity that is directed towards our line of sight is indicated by this dashed thing. And if you refer to the angle between the velocity vector and the velocity towards our line of sight or towards our line of sight as theta, then VR is V star cos theta. Okay, so if you can construct a right angle triangle here, and VR will be V star cos theta. So this is so if you now keep on monitoring, if you now keep on monitoring the velocity of this star, you will find that the velocity varies as a cosine function, okay, cos theta. Since theta varies with time, it will be the observed radial velocity will be varying as a cosine function. And so this is the observational signal that astronomers get when they are looking at these distant stars with planets around them. So this is the radial velocity curve, and that's the observational signal. Now, next I will explain how one can infer properties about the planet from this radial velocity curve, because our ultimate objective is to see whether the star's wobbling is due to a planet or not. Okay. So for that, let's redraw the same picture that we drew earlier. So here is a star going around the center of mass, and this blue circle represents the orbit of the planet. And so here is a planet and here is a star. Okay. The planet is also going around the center of mass, and by definition, the center of mass is such that by the time the planet completes one orbit around the center of mass, the star would also have completed one orbit around the center of mass. Otherwise, they will not be on opposite sides of the center of mass. Okay. Now, let's say that the radius of the star's orbit is A star, and the radius of the planet's orbit is AP. Okay, so which means at any given instant, the separation between the star and the planet is A star plus AP. Okay, and V star is the velocity of the star. So we know that VR is V star cos theta, and this V star, velocity is distance divided by time. I'm sure you have studied this. Velocity is distance divided by time. So VR is 2 pi A star divided by P. Okay, where it takes for the star to go once around the center of mass, the orbital time period. So to go once in this red circle, let's say the star takes a time P, 2 pi A star is the circumference of the circle. Okay, so the distance traveled divided by time is velocity, nothing much. Okay. So now if you are looking at this radial velocity curve, what it means is that the semi-amplitude of this radial velocity curve, that height will be 2 pi A star by P. So if we can measure, if this is the radial velocity curve that we are measuring by looking at the star, then by looking at the semi-amplitude of that radial velocity curve, we can estimate what is 2 pi A star by P. And period P will be the time it takes for the radial velocity curve to go through one full cycle. So that's period P. So P we can get from the radial velocity curve, 2 pi A star by P also we can get from the radial velocity curve, which means that from this we can find out what is A star, okay, which is the orbital separation of the star from the center of mass. So that's useful, but it's not what we ultimately want. What we ultimately want are the planets within the solar system, the planets around the star. Okay, sorry. So let's now add some more detail to this. It's the same drawing that I had earlier. Now let's say that the mass of the star is m star and mass of the planet is mp. Now we know from Kepler's law that p square is equal to 4 pi square divided by g m star a cube. This is Kepler's third law. I don't know how many of you remember. If most of you are botany students, then you might have forgotten this. But in higher secondary school, we study the three laws of planetary motion that Kepler had enunciated. So this is Kepler's third law, where square of the period is proportional to cube of the separation, where A is A star plus AP. The instantaneous separation between the star and the planet. Okay, now we can also write m star A star is equal to MPAP. That's just the expression for center of mass. Now, A star we know, A we can find out. From that we can find out what is AP. M star also we know. So we know the mass of the star, we know A star, and we know AP. From that we can determine what is the mass of the companion planet. So even if we have not seen the planet, okay, we can estimate how big the object that is going around the star is. Okay, if the mass comes out to be very, very small, then it's most likely a planet. If the mass comes out to be very large, then it is going to be some object, and that is not a planet. Okay. So this is the essence of radial velocity method. Even though we have not seen the exoplanet, by looking at the star and its wobble motion, we are able to infer the mass of the companion planet. We are able to infer how far away the planet is from the star, which is A star plus AP. We can infer how long it takes for the planet to go around the star. Now, not all orbits need to be circular. Okay, sometimes stars and planets can be in elliptical orbits also. So if it's an elliptical orbit, then this is what happens to the radial velocity curve. Here the red is the star and the green is the planet. Okay. So you can see that if it's an elliptical orbit, then the velocity will not be a constant. Only in circular orbits the velocity will be a constant. If it's an elliptical orbit, the velocity will vary depending on how far away the star is from the center of mass, and therefore the radial velocity curve will not be a perfect cosine or sine function, but it will be a sawtooth function like this. So the shape of the radial velocity curve will tell us whether the exoplanet is orbiting around the star in a circular orbit or whether it's orbiting around the star in an eccentric elliptical orbit. So I'm going to skip this slide because probably this level of detail is not relevant. Now, there is an observational bias in this radial velocity method. Okay, so here is a star and there's a planet that's going around the star. Now, as it turns out, it is easy to find massive planets orbiting very close to their star using radial velocity method. That's because if you have a big planet that is orbiting very close to a star, then the wobble motion will be larger, as shown in this animation. If you have a small planet orbiting around a star, then the center of mass will be inside the star itself, as shown here, and you will not see much wobble. But if the planet is really big, like Jupiter or maybe even more massive than Jupiter, then the center of mass will be outside the star and the wobble motion will also be more. Okay? So what that means is that this radial velocity method is biased towards finding large and massive planets like Jupiter orbiting very close to their star. So that's one of the disadvantages of this radial velocity method. It's very difficult to detect Earth mass planets around distant stars using this radial velocity method. So just to summarize, the properties that we learned from radial velocity method is we can know the mass of the planet, we can find out the orbital period of planet around the star, and we can find out how far away the planet is from the star. And finally, we can also estimate whether the planet is going around in circular orbits or in eccentric orbits. So all these information about the planet going around the star is found out not by actually seeing the planet, but by looking at the star's wobble motion. Okay, so that's the essence of radial velocity method. And using this radial velocity method in 1995, so that's about 25 years ago, in 1995, two astronomers, Didier Queloz and Michel Mayor, they discovered the first extrasolar planet around a sun-like star. Okay. So the discovery happened around a star called 51 Pegasi. So those of you who are interested in skywatch, in looking at constellations in the sky, you may know that there is a constellation called the Pegasus. in the sky, and 51 Pegasi is a star that is in the direction of the constellation Pegasus. The 51 Pegasi are approximately at a distance of about 50 light years from us. From southern India, we can see this constellation during the months of September, October, and November. Okay, so this particular star was monitored by astronomers, and they found out that the star is exhibiting wobble motion. Okay, so here is the actual data from that. So this is the wobble motion of the 51 Pegasi star, and they inferred that, they concluded that this wobble motion is because there is a planet going around this star. Okay, now what was interesting was that the orbital period of the planet was 4 Earth days. Okay, now what that means is that the planet takes only 4 days to go once around the star. Now, in the case of our solar system, the planet that takes the shortest amount of time to go around the sun is Mercury. And Mercury takes 88 days to go once around the sun. Now, here is the first extrasolar planet that was discovered, and that planet takes only 4 Earth days to go once around the star. That means that the planet is extremely close to the star, very, very close to the star. And so we don't have a similar counterpart example in our solar system. So the first discovery of extrasolar planet itself created a lot of interest within the astronomy community, because now we are finding planets that are totally different from the planets that we have in our own solar system. So here's a photograph of the 2 Swiss astronomers, Michel Mayor and his student Didier Queloz, who found back in 1995 the first extrasolar planet. In 2019, both of them shared the Nobel Prize in Physics for that discovery that happened 25 years ago, the first extrasolar planet discovery. So that's all about radial velocity method. In the next 10 minutes or so, I would like to talk about the next method, which is the transit method. Okay. The transit method, let me remind you, is also an indirect method for finding extrasolar planets. So that means that we don't see the planet directly. Instead, our observation is confined to the star, and based on measuring some properties of the star, we will infer that it has a planet. In radial velocity method, in the method that we just now discussed, we were measuring the wobble motion. In transit method, astronomers measure the brightnesses of stars, and they see whether the brightness is changing in any way periodically. So what I mean by that is, what I'm going to show you right now is an animation. This is not real data. Okay, let's say that this is a distant star, and we are pointing our telescope at the star, collecting light from it and capturing the light into a camera, and we are measuring the brightness. Using that data, we are measuring the brightness of the star. And let's say that we are constantly monitoring the brightness of the star. So we are constantly monitoring, and when we are monitoring the brightness, if a planet happens to pass in front of the star, as shown in this animation, then for that duration for which the planet comes in front of the star with respect to our line of sight, okay, we will see that the brightness of the star dims. Okay. So you can see the planet coming in and the brightness starts dropping. And then again, the brightness of the star picks up once the planet moves out of the way. Okay. So this fall in brightness happens. I'm playing that animation again. This fall in brightness happens because when the planet comes in front, it's going to block a little bit of the star's radiating surface area. It's going to block a little bit of the area, and the light from that area gets blocked. This planet doesn't fully block the star because the planet is very, very small when compared to a star. It's only going to partially block some small area of the star, and from that area, the light is therefore cut off, and therefore you will see the brightness of the star dipping. Now the brightness will again dip when the planet completes one full orbit around the center of mass of the star-planet system and again comes in front of the field of view. Okay. And then once it moves out of the field of view, it will the brightness will pick up again. So this periodic, okay, repetitively, this dimming of brightness of a star is what is used as observational signal to infer that it is a planet that is causing this dip in brightness. Now, there are some interesting details to this. For example, if we know that there could be multiple planets around the star system. Okay, it need not be just one planet. There can be a small planet and there can be a big planet. There can be many small planets. There can be many big planets going around the star. So if we are constantly monitoring the brightness, when a small star moves in front, there will be a small dip in brightness. When a big planet moves in front, there will be a big dip in brightness, as shown in this animation. So you can see that when the bigger planet is coming in front of the field of view, the dip in brightness is larger. That's because the bigger planet blocks a larger area, surface area of the star. And the smaller planet will block only a smaller area of the star, and therefore the dip in brightness is going to be lesser. Okay? So how deep is the dip in brightness is going to tell us how big the planet is, whether it's a small planet like Mars, Earth, or Venus, or whether it's a big planet like Jupiter, Saturn, Uranus, something like that. And as it turns out, it not only depends on the size of the planet, it also depends on the size of the star. For example, let's say that this is a small star. This red object is a small star, and there's a planet transiting in front of it. You see a certain dip in brightness as shown here. Now, if there is a big star, and if the same planet were to transit in front of it, you will see a lesser dip. That's because the starlight is coming from a much larger area. So the relative to the total brightness of the star, the extent by which light dips varies. Okay, so both the size of the planet and the size of the star plays a role in deciding how deep the dip in brightness is going to be. So here is some real data. Okay, so what is shown here, this particular graph shows the brightness along the vertical axis, along the y-axis, and time along the x-axis. And so, and all the blue dots that you're seeing, they are all measurements of brightness of a single star. Okay? So somebody has pointed the telescope at a star, and they are constantly monitoring. Every few minutes, they are monitoring the brightness of that star. And they find that initially the brightness remains a constant, as shown here. But then after some time, the brightness declines. And then the brightness picks up again. And then it remains a constant for some amount of time. Then the brightness dips again, and then it picks up, it becomes normal, and then again the brightness remains a constant. So we see that there is a repetitive dip in brightness, and the time difference between two dips is more or less the same. Okay? So this is the observational information that astronomers gather from as part of this transit method. They monitor the brightness and they construct something called a light curve. This is called a light curve, photometric light curve. And the depth of this light curve is proportional to the size of the planet to the size of the star. So RP is the radius of the planet, R star is the radius of the star, the whole square. So if you can measure how deep this dip in brightness is, and if you know the radius of the star, which there are ways to find out, then we can find out what is the size of the planet that is causing this dip. So even if we have not seen the planet, we can infer that there is a planet by looking at the depth. And we can also find out how long it takes for the planet to go once around the star. And that will be essentially the duration between the first dip and the second dip. So that's what determines what is the orbital period. So radial velocity method gave us the mass of the planet, and transit method is giving us the size of the planet. The size of the planet will help us to discriminate between a small Earth mass planet and a large Jupiter-like planet. So that's, I'll just skip this part of the presentation. It's not very important. So using this transit method, astronomers have found many extrasolar planets. So here is one very famous example. This is called the TRAPPIST-1 system. This was the news of the discovery of this TRAPPIST-1 extrasolar planet system came in all the major newspapers. Okay, so this is a star. TRAPPIST-1 is a star that is roughly at a distance of 40 light years from us. Okay, that means light takes 40 years to reach us from that distant star. And astronomers were constantly monitoring for a period of 20 days from September to October in 2016. They were constantly monitoring the brightness of this star TRAPPIST-1. as part of a larger survey. And they found out that this particular star, TRAPPIST-1, has not one, not two, but 7 planets around it. So the dip in brightness of the star due to each of those planets is given here. So the planets are generally named as B, C, D, E, F, G, H. Okay, so the TRAPPIST-1 is the name of the star, and the first extrasolar planet to be discovered around it is called B. The second is called C. The third is D. That's usually the way, the nomenclature method. So they found not one but 7 planets. Okay, so that's very similar to our own solar system where we have 8 planets. So we have found evidence for multi-planetary systems around distant stars. And so this is an artist drawing. Okay, so as I mentioned, in transit method, we don't get to see the planet, but based on data collected using transit method and radial velocity method, astronomers estimated how big and how small these planets would be and how far away they are from the star. Based on that, here is an artist impression of how the TRAPPIST-1 extrasolar planetary system looks like. So here is the star. It's a very, very faint star. It's not a very bright star. It is much fainter than the sun. And these are all the planets that are revolving around it, B, C, D, E, F, G, H. Now, what is interesting here is that all these 7 planets are orbiting very close to the star, completing one full revolution around the star in a manner of few days. Okay, so what that means is that if you take this TRAPPIST-1 exoplanet system, the entire exoplanet system of TRAPPIST-1 will fit inside the orbit of Mercury within the solar system. So here is a schematic drawing of our solar system. This is Mercury, this is Venus, this is Earth and Mars. So that's how far away Mercury is from the sun. And this entire TRAPPIST-1 system can fit within the orbit of Mercury, which means that all these planets are closer to the star than Mercury is to the sun. So it's a very, very different, very, very bizarre world out there. And the discovery of extrasolar planets has repeatedly shown that our solar system, the other planetary systems could be very different from our own solar system. Okay. So to summarize this transit method, the kind of things that we can learn about the exoplanet from transit method is the size of the planet, its orbital inclination. We can find out how inclined the orbit is, etc., the orbital time period, and so on and so forth. Okay, so now in the last 2-3 minutes, I'll go through what is currently happening in this field. Okay, so both this transit method and radial velocity method are indirect methods. We don't get to see the extrasolar planet. Okay, all our observation is confined to the star. Now, even though both these techniques have been very efficient in showing us extrasolar planets, but even then, okay, what would be really interesting would be to see these extrasolar planets for real. Okay? If we can see the planets with the light coming from those planets, then that will be the most definitive evidence for the presence of planets around stars. So directly photographing extrasolar planets, that's called direct imaging. And in the last 10 to 15 years or so, because of the improvements that have happened in imaging technologies, and also as telescopes and CCD cameras have become better, and with the improvements in adaptive optics systems, which is a cutting edge optics design, astronomers have been able to directly take pictures of planets revolving around other stars. And here is one such example. HR 8799 is the name of a star. Okay, stars are generally given catalog names. So HR 8799 is a catalog name of a star. And in this image, this region where I'm pointing with my mouse, that is where the HR 8799 star is. And when they try to image the star, using high contrast imaging, using some very powerful telescopes on the ground equipped with adaptive optics system, they discovered 4 planets around the star. Okay, this B, C, D, E. These are 4 planets that are orbiting around the star. So this is not an artist impression, or this is not an animation. This is real data. So what you're looking at is light coming from those distant exoplanets. Okay, these 4 exoplanets, and directly imaged by the telescope CCD camera system. Okay. And this particular HR 8799 exoplanet system was constantly monitored for a period of 7 years. And what we are going to see next is an animation by stitching together a large number of images taken of this HR 8799 system. And you will see the planets revolving around the star. So this is not visualization, this is real, this is not animation, this is real data that you're going to look at. So in the center, let me just explain, before playing the animation, the visualization, I'll just explain what it is. The center black region, this is where the star is. And since the star is usually very bright compared to the star planets, okay, so stars are usually 1 billion times brighter than planets, we will not be able to see the planet if the starlight is there. So what they do is they have covered the light from the star, they have masked the light from the star so that we get better contrast in the surrounding area, and we will be able to see planets near to the star. Okay, so the starlight has been blocked out here, and the 4 dots that you see displaced from the center, they are the 4 planets B, C, D, and E. And in the bottom you can see date, okay, 31st July 2009. Okay. That date will keep changing as I play this animation. Okay, and you will be looking at 7 years of data. The animation is only 5 seconds long, so pay attention. So I'll just play it once again. So from 2009 to 2016, that is 7 years of data compressed to 5 seconds or less than 5 seconds. Okay, so you can see that the planets are revolving around the star. So this is direct imaging. We are actually seeing exoplanets now. So here is another example. Okay, this is a star called Beta Pictoris, and around the star Beta Pictoris we see a planet. So this is the star, this black circle over here. The light from the star is masked out, or it is blocked out, so that we can see this planet. And below you can see that the time is changing, and with increase in time we see the planet moving relative to the star. So if we are an alien species, okay, and if we are sitting somewhere far in our own galaxy, and if we were to look at our own solar system, we will probably see the planets in the solar system doing this, moving relative to the sun. Okay. So as I was mentioning, I'll just last 1 or 2 slides more. The first extrasolar planet around a normal star was discovered in 1995. Okay. So since 1995, 25 years have gone by, and these 25 years have been a period of great progress in the field of extrasolar planet discovery. In this short span of time, the number of extrasolar planets that astronomers have discovered has increased by the dozens. Okay, now it is in the thousands. Okay, so what we are seeing here is a histogram that shows the number of extrasolar planets discovered along the vertical axis. So the vertical axis shows the number of exoplanets discovered, and the horizontal axis is the discovery year. And it's a cumulative histogram, which means that whatever data is in this histogram is added to that. Whatever data is there is added to that, so on and so forth. So it starts from 1989 and it goes up to 2020 year. And the color coding indicates the technique that was used for finding extrasolar planets. So red indicates radial velocity method, green indicates transit method. Both of them are indirect methods. Blue indicates direct imaging, which means directly for taking pictures of extrasolar planets. And then there are half a dozen other techniques. But you can clearly see that radial velocity and transit method have yielded the most number of detections. Okay. And the number of extrasolar planets known has steadily increased. Okay. Now, as we speak, astronomers have discovered more than 4,000 planets orbiting various stars within our own galaxy, the Milky Way. So prior to 1995, the only planetary system that we knew of was our own solar system. But in the span of 25 years, we have now discovered more than 4,000 planets orbiting various stars. And you can also notice that initially, most of the exoplanet discoveries happened through radial velocity method, but very recently, this transit method has really picked up in terms of yielding a large number of detections. And the reason for that is the launch of a telescope, space-based telescope called the Kepler Space Telescope. Kepler Space Telescope was launched in 2009. So this is a telescope that is put outside of the Earth's atmosphere. It is in a heliocentric orbit, Earth trailing heliocentric orbit. It orbits the sun, trailing behind the Earth by about 100 million kilometers. Okay? And that's how far away the telescope is. And from that vantage point, Kepler has been looking at constantly monitoring the brightness of about 150,000 stars in our own galaxy. And by constantly monitoring this brightness of these 100,000 stars, Kepler has discovered 2,600 extrasolar planets. So which means out of the 4,000 plus planets that we know today, more than half of it was discovered by this one space-based telescope, that is Kepler. The mission got over in 2018, so Kepler Space Telescope is no longer functional. And Kepler has been really a game changer. Okay? The launch of Kepler has completely changed our understanding of extrasolar planets. So to give you an idea of how powerful or how important it has been, okay, so here is a graph that shows the number of planets that were known to us before Kepler. And the graph here shows the number of extrasolar planets that we know after Kepler. And what is most important are these data points over here. So these are planets that are similar to Earth, that have masses and sizes similar to that of Earth. So before Kepler, we hardly knew of planets that are similar to that of Earth orbiting around other stars. Most of the planets that we were aware of were planets like Jupiter, Neptune, etc. Because the discovery primarily came from radial velocity method. But because of Kepler, now we know that there are thousands of planets similar to Earth orbiting around other stars. So this really increases the possibility of finding an Earth-like planet orbiting around another star in some distant part of our own galaxy. So Kepler mission, as I mentioned, officially got over in 2018, but there are a large number of ongoing and future missions that are planned, space-based missions, exclusively for discovering planets around other stars. TESS is a mission that's Transiting Exoplanet Survey Satellite. That's a satellite that was launched in April 2018. And it is already up there in the sky. It is there in the sky, collecting a lot of data and giving us new insights into extrasolar planets. And then there are a couple of other missions that are also planned. So as a final slide, as a final takeaway message of this presentation, okay, even if you were to forget everything that you heard in this presentation, what I would like you to still remember is the following thing, that when we look up into a clear night sky, we see these innumerable number of stars. We see these tiny stars twinkling in the sky, and there are countless numbers of these stars in the night sky. And research of the last 25 years in this field of extrasolar planets is telling us that each single one of those stars that we see in the night sky possibly has one or more planets revolving around it. It is just a matter of finding them, and which, as we saw, it's not very easy to find extrasolar planets, but it's not impossible either. So what that means is that the universe seems to be bursting with planets. In fact, there are probably more planets than stars in our own galaxy, the Milky Way. And this particular fact that there are probably more stars, more planets than stars in our own galaxy, this is a very profoundly important discovery because it enhances the odds. It enhances the probability of finding Earth-like planets that can potentially be a safe haven for life. A planet similar to Earth where liquid water exists, a planet with a dense atmosphere where the phenomenon of life as we know it is a possibility. And so I want you to remember that whenever you look into the night sky, you have to imagine in your head that each of those stars have multiple planets around it. And what is equally more interesting is that we have only searched the tiny volume of our own galaxy. We have only searched about a few 100,000 stars for planets, and already we have found 4,000 plus extrasolar planets. So there are 200 billion stars in our galaxy. So you can just imagine how many exoplanets could be there. So coming back to this original question of whether we are alone in this universe, is Earth the only place in this entire vast universe, in this entire cosmos, where there is life? Okay, so to that question, we still do not have an answer. Okay, so I will leave you with a very famous quote from Arthur C. Clarke. Arthur C. Clarke said that there are two possibilities. Either there is a cosmic loneliness to our existence, either we are alone in this vast universe, or perhaps we are not alone, and both are exciting possibilities and maybe for some of us a bit scary possibility. So I will leave it with that, and I will show you two books which you can read if you are interested more on this topic. Both these books are written at a popular science level, which is easily accessible to everyone. Okay, so with that, I will stop the presentation and I'll be happy to answer questions if you have any.
Thank you, sir. Dear participants, if you have any queries, kindly put up in the chat box.
Good morning, sir.
Yeah.
I'm Sister C from the Department of Physics, St. Mary's College. It was a wonderful presentation, sir. It was very interesting. We got so many insights about what is there in our galaxy. There are so many galaxies. We don't know much about we are able to see that around every thousands and thousands of stars, we have so many planets. It's really, it was a wonderful presentation, sir. It was very informative and it's very interesting. Sir, I would like to just know whether how can our students in future, if they are interested in astronomy, what are the places where they and how they can apply for it and get into such interesting fields to explore. Can you just give some insight about it, sir?
Yeah, sure. So it's very difficult to answer that in a couple of minutes, but I will try to quickly answer it. So the tools of the trade of astrophysics are physics, mathematics, and increasingly the computer programming also. So computer programming is also now playing a very vital role in data analysis, not just in astronomy, but in all fields of science. I'm sure in biology also there is a increasing use of big data algorithms, machine learning algorithms, etc. So if there are students who are interested in having a career in astrophysics, then what they should do is they should focus on fundamental physics courses that is taught at BSc, MSc levels, and also mathematics courses. Now, and they should have a fascination for mathematics and physics. Mathematics is the tool that we use to analyze the universe, and physics is also the framework that we use to understand the universe. So there should be an interest towards both these subjects. Along with it, they should also try to learn get themselves familiarized with computer programming. So that doesn't mean that they have to go to a computer institute, pay an exorbitant fee and learn it. Computer programming can be learned by oneself. If there is no course within the curriculum, they can learn it by themselves. And when they are in their BSc and MSc, they can try to try for internship positions in national level institutes across the country. Now, I know that it's very, very competitive. There are thousands of colleges in India, and students from all these colleges could be applying to premier institutes in the country for research internship positions. But that is a given. But then they can keep trying for all these things. And there are about 12 or 15 national level institutes within India that are doing fundamental research in astrophysics. So these kind of research opportunities, summer research opportunities, December research opportunities, this will be useful for them to get a closer understanding of what astrophysics really is, how much of physics is involved in it, how much of mathematics is involved in it, how much computer programming is involved. So those research experiences of a few weeks or few months will help them to make an informed choice. And in this field, if they are looking for a long-term career, a PhD is almost a must. Okay, so you're looking at they will have to prepare themselves for a doctoral program in astrophysics. Yeah, so with the MSc, it's very difficult because this is purely an intellectual pursuit. I mean, there is no direct relevance to the industry, the private sector world outside. So the jobs are mostly confined to academia. Academic institution, so they should plan for a PhD. But yeah, so that's in short, that is what the answer is. So what I would tell the students of physics who are listening this is that they should take their fundamental physics courses and mathematics courses very seriously, because that is the foundation on which everything else is built upon.
Yes, yes.
And astrophysics is ultimately a way of looking at the world around us and the world above us through the prism of physics. So
Yes,
physics
yes.
is important. And
Yes.
since there are biology students also who are listening to this, I would like to mention that there is an emergent field of research called astrobiology, which is a happy marriage between physics, chemistry, geology, and biology, and atmospheric science. And in this field, you have researchers from all these disciplines coming together to address one fundamental question, which is whether life can exist beyond Earth, okay, in other planets. So the astronomers help to understand these planetary environments. Geologists will give the geology perspective, and biology is very, very important, because even if conditions are favorable for life, life as a phenomenon, for it to spontaneously arise, that is a much more difficult problem. So that's where you need the help of biologists to understand what are in extreme environments can life thrive, can life arise. And then there is also atmospheric science people who contribute to this, because atmosphere has a symbiotic relationship with biomass on any planet. So there is a lot of interdisciplinary work that is happening in this field. So even if you are a student of biology, you can still contribute towards answering these basic questions.
Yeah, thank you, sir. Thank you, sir. And sir, recently the American Space Agency, NASA, they have sent to the planet Mars, no sir, a car-sized rover equipment. They are trying to find if there is any biological signature in that planet. Can you tell us something about that, sir? Maybe the biological students will be interested about it.
Yeah. So the planet that is most likely to have supported life in some form or the other, maybe not evolved life forms, but maybe microbial life forms, is likely to be Mars, and that's what the hypothesis is. Mars is a planet that has had a history that is similar to that of Earth. There is overwhelming evidence that seems to suggest that liquid water once flowed on the surface of Mars. And we know that water is a precursor for life. Water is an essential ingredient for life. So therefore, there is a lot of focus on finding the presence of microbial life on Mars. All the past missions and even the current missions to Mars have at least had one payload which is going to look at signatures of microbial life on Mars, or at least some leftover things from life. Okay, so even the current mission also has a similar objective where it's trying to look for traces of life. Now, in the past, there have been many missions which have tried to analyze samples directly taken from Mars, soil samples, in situ analysis, which means then and there itself, it does analysis of the soil to see whether there is presence of life or not. And so far, all the results have turned out to be negative. Okay, so that there has not been any conclusive evidence that there is even microbial life on Mars, but that's not a very big disappointment, because if you put that same payload, if you take that same experiment and do it on the Atacama Desert or the Sahara Desert on Earth, you will come to the conclusion that there is no life on Earth. Okay, so yeah, so where we do the experiment also matters a lot. So that's one aspect of this Martian thing. So there are at least 10 or 15 orbiters and missions that are in and around Mars that are trying to look at various aspects of Mars. One other point which I want to mention is that these extrasolar planets, now astronomers have started discovering atmospheres of these extrasolar planets.
Oh, very nice.
Yeah, going from finding those planets, now we are detecting atmosphere. Now, the reason why detecting atmosphere is very important is because if you look at Earth, Venus, and Mars, three planets which are roughly at the same distance, all three have atmospheres. Venus's and Mars's atmosphere, the dominant element is CO2. Whereas on CO2 is present only in trace amounts. We have a lot of oxygen and water vapor. In fact, 1 part in 5, that is 20% of Earth's atmosphere is made up of oxygen. And
Yes.
there's a lot of water vapor. And the reason why Earth's atmosphere has so much oxygen is because there is a biomass, there is life on Earth. So the abundance of oxygen on Earth increased after the first life forms, the photosynthetic algae originated on Earth. And it is these photosynthetic algae through anaerobic respiration pumped up the level of oxygen in the Earth's atmosphere. So the presence of O2, O3, H2O in the atmosphere of a planet could be an indication that the planet could be supporting life. So people are trying to, sitting here on Earth, they are trying to detect these extrasolar planet atmospheres and trying to see whether there is the atmosphere is oxygen rich or not. And if it is oxygen rich, then there's an indication that there could be life beneath that.
In those planets, okay, sir.
Exactly. Yeah.
Thank you.
Because
Sir,
physically going to these planets is impossible because it will take thousands of years to reach them.
Yes, yes. Thank you, sir. Very nice, sir. Thank you, sir.
Sir, I have one question, sir. So many Martian research indicated that existence of life millions of years back. What was the cause of disintegration of, what would have been the cause of disintegration of such life in Mars?
Yeah, so the primary reason is because Mars is smaller than Earth. Okay, so Mars has a mass that is only 1/10 the mass of size, that is about 1/10 the size of the Earth. So Mars is a smaller planet compared to Earth. And if a planet is small, then it's very difficult for that planet to hold on to a dense atmosphere. So the light from the energy from the sun is constantly heating the gases of the atmosphere. Now, unless the planet is sufficiently massive, it will not be able to hold on, gravitationally hold on to the atmosphere. So Mars, over the last 4,500 million years of the solar system's history, Mars has been slowly losing its atmosphere. So it probably started out as a planet with a dense atmosphere, and over a period of time, the atmosphere has been lost to outer space because it doesn't have sufficient gravity to hold on to its own atmosphere. Even now, Mars is losing its atmosphere, and now Mars has only a very thin, a very wispy atmosphere. Now, atmosphere is extremely important for a lot of reasons. One is atmosphere helps to build up atmospheric pressure, which allows water to exist in liquid form. Okay, so without liquid water, it's very difficult for life to thrive, life to survive. So what happened in the case of Mars is a kind of runaway glaciation where the whatever water was present on the surface of Mars either got evaporated from the surface and escaped into outer space because Mars was not able to hold on to its atmosphere, or it got or whatever was remaining got submerged within the surface as subsurface ice. So from a wet planet, Mars has now become a barren and dry planet with very thin atmosphere, and this is probably one of the reasons why Mars evolved in a completely different way compared to that of Earth. So there is a field of research called comparative planetology where they try to look at Venus and Mars as contrasting examples compared to Earth. So how come among these three only Earth happened to have life? Okay, what all geological factors could have played role in that? So that's my short answer to the question.
Thank you, sir. Thank you. Yes.
Okay, so if there are no more questions, then perhaps we can end the session.
Thank you so much, sir, for your interesting presentation. Your simple explanation and amazing animation clearly explain the astro concepts, extrasolar planets discovery and its basic in a very clear way. Thank you so much, sir.
Thank you. Thank you. Thanks for everyone for tuning in and for listening for the last 1 hour. So can I log off now?
Yes, sir.
Thank you. Thank you.
Thank you, sir.
Okay, ma'am, shall we start the technical session, ma'am? Glory, ma'am.
Jenny?
Ma'am, shall we start the technical
Yes,
session?
yes. And ma'am is in the meeting, ma'am.
Yes, ma'am. Yes, ma'am.
Okay,
I'll
okay.
ask Sumati ma'am to introduce her. So let me
Okay.
start, ma'am.
Okay.
Dear participants, we are now going to start our technical session 4. The chairpersons would be Dr. Jennifer and Hari Krishna and Dr. M. Glory, who will be the chairpersons for this particular session. I now invite Dr. Maria Sumati, Assistant Professor of Botany, to introduce the chairpersons. Sumati ma'am?
Am I audible, ma'am? Am I audible?
Yes, ma'am, you are.
A pleasant good morning to you all. It's a great pleasure to welcome you all to this session. I'm very glad to welcome and introduce the chairperson of this session, Dr. Jennifer Ann Harikrishna and Dr. M. Glory. First of all, I would like to introduce Dr. Jennifer Ann Harikrishna, Director, Center for Research in Biotechnology for Agriculture, University of Malaya. She is a professor of genetics, Institute of Biological Sciences, Faculty of Science, University of Malaya. She has completed her BSc in microbiology from University of Surrey, UK in 1985 and completed her PhD in molecular science from Granfield University, UK in 1990. She is an honorary visiting fellow, Department of Genetics and Genome Biology, University of Leicester, UK from 2008 to 2023. She has been awarded many prestigious awards like Whitbread Scholars in 1985 to 1989 and awarded the Granfield University Chancellor Gold Medal for the Most Outstanding Graduate Student of the Year in 1990 for industrial research, leading to 2 UK patents for the brewing industry. She has published 78 peer-reviewed papers and has authored 9 book chapters. She has many ongoing research works on safety of a genetically modified organism for sustainable agriculture and food security with the RM of 258,000 from 2019 to 2022. Biosafety, biosecurity, and genetics improvement of plants and aquatic animals with RM of 139,000 from 2019 to 2021. Elucidating the role of small open reading frames and small coding genes in response to drought stress using gene overexpression system in Oryza sativa FRGS with RM of 158,000 from 2019 to 2021. She has registered many patents under her name. Some examples are a method for constructing recombinant soluble flat touch single chain variable fragment against cucumber mosaic virus patent in 2004, plant virus protection solution patent in 2009. 14 candidates had successfully completed their doctoral degrees under her guidance. Now, 6 candidates have been pursuing their PhD degree under her guidance. She has been a reviewer for some renowned scientific journals like Asia Pacific Journal of Molecular Biology, Journal of Experimental Biology, Journal of Oil Bomb Research, Malaysian Journal of Research, Journal of Biotechnology, etc. She has been an external examiner for in AIMST University, India, Mudok University, West Australia, University, Vellore, Tamil Nadu, India, University Ebenson, Malaysian Universities in Malaysia, Mona University, Malaysia, Malaya University of Science and Technology, Taylor's University, Malaysia, University of Malaysia, and internal examiner for University of Malaya, MPhil, MSc, Biotech, and PhD.
Sumati ma'am?
Am I audible?
Yes, ma'am. Yes, ma'am.
She held an editorial and advisory position and editorial board members, Annal of Botany in 2015 to at present. Associate editor, Asia Pacific Journal of Molecular Biology and Biotechnology in 2002 to 2015. Member of advisory board to the Malaysian National Pepper Board in 2016 to 2021. It is our proud privilege to have such an eminent and humble person in our midst today. On behalf of Botany Department, I extend my cordial welcome to you, ma'am. Next, I would like to introduce the next chairperson of this session, our beloved HOD, Dr. M. Glory, who is the backbone of our department. I am so happy to introduce our mentor in our midst. She has completed her BSc and MSc degree in Botany from Holy Cross Navapoi. Holy Cross. She attended many training programs, seminar, symposia, and presented as well. She has published many papers in the national and international journals. She has been a resource person to a lot of colleges. She has been awarded with Best Ecologist Award in 2016 by Madhavi Literary Society, Singapore. Two candidates have successfully completed their doctoral degree under her guidance. She has completed one major project entitled Studies on the Impact of Heavy Metal Pollution on Mangrove Ecosystem of Thoothukudi and development of strategies to conserve the regenerate of mangroves in 2013 to 2016. She completed project titled Studies on the Impact of Heavy Metal Pollution on Mangrove Ecosystem of Thoothukudi and Development of Strategies to Conserve and Regenerate on Mangroves in 2013 to 2016. The funding agency UGC granted rupees 9,79,000 for this project and also completed 2 student projects. I am very happy to have such an eminent person in midst today. I welcome you, ma'am. I also extend my grateful welcome to you, my dear participants. Once again, I welcome you all for this.
Hello, Jenny. You invite. Hello, Jenny.
Yes, ma'am. Yes, ma'am.
You invite Ritika.
Okay. Okay, participants, we are starting the technical session right now. So the first participant will be of Miss Ritika Thomas from USA. She is a young reviewer and an environmentalist. Her research findings are pertinent to climatic change issues and global warming. This is our immense pleasure to introduce her as our third generation learner of Department of Botany, because she is the granddaughter of Martha Rangasamy, who's our illustrious alumna of batch in 1959 to 1962. Her undiminished love towards the college continued for more than half century. So now I invite Ms. Ritika Thomas to present her review paper. Ms. Ritika?
Everyone.
Good morning.
Good morning. My name is Ritika Thomas, and I am in grade 11 at the Bridgewater Raritan High School in New Jersey. First off, I sincerely thank Dr. Glory, who provided me with this awesome opportunity to present in this conference and be part of this prestigious scientific community. I would also like to thank my Jijima, Dr. Giri, who is my scientific mentor and constant supporter. I want to start by saying that being an advocate for our environment and climate change has led me to choose this topic of a spatial network of skeletal proteins in a coral known as Stylophora pistillata. So, who doesn't love corals? They're a beautiful part of our marine ecosystem. What is climate change and the jargon used often these days? Let's explore this term quickly before we connect it with corals. Climate change specific to the ocean is a gradual process where the ocean absorbs heat because of the emissions of greenhouse gases produced by humans, resulting in the rise of water temperature and sea level. Simultaneously, marine species and ecosystems are affected. The structure of a coral consists of biominerals consisting of a highly organized organic mix of proteins that resemble what is in our bones. Amazing scientists from Rutgers University in my home state of New Jersey have researched and conducted a series of experiments on the coral Stylophora pistillata to find out that they have the ability to carefully arrange the proteins in them to form rock-hard skeletons that help them withstand climate change and stay alive. We think corals are brainless blobs. Through this research, we can actually see they do wonders to keep themselves alive. Biomineralization is a process by which stony corals secrete calcium carbonate to strengthen their skeletal systems. For the first time in scientific history, the Rutgers scientists have shown that several proteins in corals work together to create optimal conditions for biomineralization.
Excuse me, ma'am. Are you sharing your screen?
No, I'm not sharing my screen actually.
Oh, no. Okay. Right.
So to continue, so through my own scientific thinking, I've concluded that these climate change resilient corals can be identified and used for selective breeding. These corals can be fragmented and planted at reefs around the world. They can be sexually recombined with other coral populations, making other species also more resilient to climate change. Reef conservation in both hot and cold bodies of water with different coral species must be employed to protect the diversity in their habitats. Using genomics, we can find which corals are tolerant to live in high temperatures and resist bleaching, and the genetic variants associated with climate change. In addition, corals are bright and colorful because of microscopic algae called zooxanthellae. The zooxanthellae live within the coral in a mutually beneficial relationship, each helping the other to survive. But when the ocean's environment changes, if it gets too hot, for instance, the coral stresses out and expels the algae. As the algae leaves, the coral fades until it looks like it's been bleached. The process called coral bleaching occurs when the temperature of the water remains high. As a result, the coral won't accept the algae back and eventually it will die. If corals can withstand climate change, according to this Rutgers research, as an environmentalist, I truly believe that the temperature fluctuations on a daily basis are often sufficient enough to expose corals to different temperatures. This encourages greater tolerance and helps them retain their bright colors. As an international scientific community, we must not stop by just learning about these spatially arranged proteins, but instead, we should continue to do more research and take actions to help protect these important coral reef ecosystems. If you have any questions about my reviews, please feel free to reach out to me anytime. And thank you for your time and thank you for listening.
Hello, Ritika. Hello.
Hello. Can you hear me?
Do you feel the disintegration of concentration that is thousands of years in the ocean Do you feel damages of these coral reefs will alter the carbon cycle of the atmosphere, thereby global warming?
Yes. Well, actually, coral bleaching, it really affects the marine environment, especially the carbon cycle, because it involves the ocean. And so to save these populations, it's best if we realize that we have to keep the environment healthy, especially our marine environment and the ocean.
Oh, fine.
Yeah.
Nice, nice. Any question?
And ma'am, good morning, ma'am. If you have any questions, please ask, ma'am.
You can, Annie ma'am, you can give your suggestion on climatic change issues and disintegration of coral reefs. But this girl is very much interested in analyzing, in studying about the disintegration and the damages of coral reefs due to ocean acidification. If you have any suggestion, any advice and research scope in this direction, you can give advice to this environmentalist, Ritika Thomas.
Hello, Ritika. Can you hear me?
Yes, I can.
Yeah, thank you for your presentation. I'm a person who goes diving, so I really appreciate the beauty of corals. So when you do this kind of quite fundamental research, how do you see it being extended into practical use?
Well, humans do benefit from things in the ocean environment, especially. So if the habitats of organisms are kind of taken away or destroyed, it definitely impacts humans as well.
So what would be the advice that you can give based on your studies that can help in coral conservation?
Well, probably keeping the marine ecosystem like the least polluted from at least a human perspective, like maybe like leaving less trash in the ocean, leaving less oil spills, like simple things like that, and like bigger global issues that we can like start to minimize on.
Yeah, I think also what some countries are trying to do is have marine parks so that people can visit, but in limited numbers. When people see the corals themselves, they grow to love the beauty, and they become also campaigners for this, because it's very difficult. You need everybody in the world to cooperate, which is a big challenge. And but it's I think the more that we put out information and help people learn about it, I think that is really good. So I'm glad you've chosen this topic of study. I think it's very important. Thank you.
Yes, Ritika. Besides the aesthetic value, the coral reefs has lot of economic as well as ecological significances. As a young scientist, you are aware of keeping this coral reefs. Absolutely, it is correct. People like young chap like this, one who is concentrating on protecting such ecosystem. We all know this coral reefs are the tropical rainforest of the ocean. It does a lot of ecological services to the maintenance of sustainability of the ocean ecosystem. Once oceanic ecosystem is altered, because oceanic ecosystem itself is controlling the climate of the earth, absolutely, surely, any damage to the coral reefs, subsequently the damage the entire ocean system, thereby direct impact will be to the climate of the earth. So congratulations, Ritika. I wish your work and your research will be a successful one in this direction in your future. Thank you so much for your contribution and your presentation. Nice presentation. Thank you so much, Ritika.
Thank you. Thank you for the opportunity.
Okay.
Thank you, Ms. Ritika.
Jenny, shall we? Okay, we can invite the second person to do.
Yes. Now let me hand over this technical session to Dr. Daftel. Daftel, ma'am.
Yes, ma'am. Very good morning to one and all connected here. Now I call upon Dr. Botany Devi to present her paper. The next presenter is Dr. Ajit Kenyar.
Hello, am I audible? I'm Dr. Sridevi. I can't hear you properly, ma'am. Is it my name, Botany
Yes, ma'am.
Sridevi?
Yes, ma'am.
Yes.
Yes,
Okay,
ma'am.
okay. Is it my
You are
turn? Okay.
audible. Yeah,
Okay,
yeah.
okay.
You can share your screen, ma'am.
Okay, ma'am. Thank you.
Daf, kindly ask the participants to stick on their time.
So,
Dear participants, please be mindful of your presentation duration. Only 5 minutes, 4 minutes for your presentation and 1 minute for discussion.
okay. Thank you, madam. Thank you for giving me this opportunity. So, good morning, everyone. I'm Dr. Sridevi, lecturer in microbiology, Department of Microbiology, TSWRDC Warangal East. So today I'm going to present my topic on bioethanol production with the inoculation of yeast using vegetable and fruit waste as substrate. So the main objective here is to determine the utilization of fruit and vegetable waste autohydrolysis liquor as substrate towards bioethanol production just by using indigenous yeast as starter culture. So we know very well that fossil fuels are being used carelessly by humankind, and this type of energy cannot supply all of the energy requirements. So this has caused CO2 emission to increase rapidly, bringing about some changes in the global climate. Hence, people being to search for new alternative renewable energy sources and technologies to save the world climate and better the quality of life. New alternative and renewable energy sources such as solar, wind, geothermal, hydrogen, and biomass are the new sources for supply energy demand for the whole world. Instead of petrol, new clean and safe renewable energy resources such as bioethanol could be considered. Bioethanol, the kind of biomass energy, is an alternative to the ever-depleting fossil fuel. So research on bioethanol production from biomass has been rising recently owing to its potential to be a more economical and sustainable alternative energy source when compared to fossil fuels. So traditional production of bioethanol is mainly from sugar, including starchy biomaterials, so it is called as first generation bioethanol. However, this causes competition between food and biomass energy sources. So the developing countries like India, food crisis is equal to energy crisis. So increasing demand for energy, the food versus fuel debate, and competitive market pressure for environmental sustainability to use second generation biomass feedstocks and to reduce carbon emission. So biofuels generated from lignocellulosic biomass, so it is nothing but second generation biofuel, represent one of the potential renewable source of energy so that are non-polluting and are sustainable. So therefore agricultural waste, because India mostly, so we are having agriculture, definitely we are having so many waste products from agriculture. So agriculture waste are attractive feedstocks for bioethanol production. These wastes are cost effective, renewable and abundant. Meanwhile, so in our investigation, we selected fruit and vegetable waste. So they're also having a very good, they're abundant and they are having good amounts of saccharides in the form of lignocellulose. So high source of lignocellulose could be hydrolyzed into glucose xylose, which could be further converted to bioethanol by microorganisms. Actually, our college is a residential college. So mostly in our mess, all these waste will be generated, and that waste will be, I want to use those waste so for renewable energy source. So this is a small work carried out by my students at our college. So this is a residential college. So first of all, we just tried to isolate indigenous yeast from grapes. So for that, so we have taken partially fermented grapes. So from that, yeast cultures were isolated on malt extract agar medium, and they were subcultured, stored. And for the alcohol production, so we used yeast cultures grown in by yeast extract peptone dextrose broth. So this is a new strategy for the development of for the production of second generation bioethanol production. So without any treatment, simply we are just boiling the biomass, and whatever the extract we are getting without any pre-treatment. So we are using as a substrate for bioethanol production. So we are not going for any pre-treatment like acid hydrolysis, no biological treatment. So in order to simplify the process, we want to check whether this particular auto hydrolysis liquor, it is nothing but water, hot water. When the liquid, here it is a water, which will cause no harm when it is subjected to heat treatment. So we are getting some extract that is nothing but auto hydrolysis liquor. So we want to test whether that particular auto hydrolysis liquor can serve as a substrate for bioethanol production or not. So here we have taken fruit and vegetable biomass plus water, and we autoclaved it. So whatever the residue is there, we discard it. So mostly lignin part will be discarded, and the soluble fraction. So we have taken that particular liquor, which is having the soluble fractions of sugars, hexoses, pentoses, simple sugars. We have taken that liquor part as a substrate for bioethanol production in submerged fermentation by using the yeast. So this yeast culture was inoculated into the into the broth, auto hydrolysis liquor, and after 24, so we have estimated the ethanol concentration at 24 hours, 48 hours, and 72 hours by acid dichromate method. So we also estimated the reducing sugars. So what is the amount of reducing sugars and expressed in terms of glucose concentration? So reducing sugars that are available in auto hydrolysis liquor. And titratable acidity, it is expressed in terms of percentage of lactic acid. So we have taken culture broth and titrated against 0.1 normal NaOH using phenolphthalein as indicator. So this is the small partially fermenting grapes. So this is the source for the yeast isolation we have selected. So here from this we isolated yeast. From that these yeast cultures were subcultured. This identification is based on simple morphologic microscopic observation. And here this is the fermentation studies. So reducing sugars estimation in the auto hydrolysis liquor and alcohol estimation. So we selected banana peel, papaya peel, pomegranate peel, sapota peel, potato peel. So all these peels, because daily all these wastes will be generated at our hostel. So we have taken all those wastes and autoclaved them, whatever the liquor we are getting. So we analyzed for the ethanol estimation. So we got good results in potato peel as well as banana peel. So good ethanol production. So good reducing sugars estimation in banana and potato peel. So titratable acidity. So at 72 hours of incubation time, we got good results. And here the use of alternative sources, so which are underutilized agro waste like fruit and vegetable waste for the production of bioethanol has been found to be economical and cost effective. So we want to simplify the procedure. We want to check whether this particular liquor can be used as a substrate for bioethanol or not, because we are not going for any pre-treatment techniques. So we got good results. So because all these biomass are good, they are rich in cellulose, hemicellulose, and lignin. So which gives rise to zero waste generation technique. And still the work is going on for the yeast identification, because this is the corona time. So we ended up to this level only. So that yeast strain, it has to be identified, and still work is going on. And we are planning for bioethanol production by using some weeds, most probably aquatic weeds, so which are not at all used as non-food. So we are planning for production of bioethanol by using non-food plant biomass as a substrate, like using Icornia, Pistia, Parthenium. So they cannot be used as food, and there is no competition for food, and there won't be any food crisis for second generation production of ethanol. So thank you, madam. Because you have given only 4 minutes of time, that's why I have ended up my presentation. Thank you, madam. Thank you, ma'am. Thank you, ma'am.
Shall I go first with questions?
Okay, ma'am, sure.
Okay, thank you, Sri Devi. I'm very fond of yeast because that was my PhD topic. I was working with industrial strains. So I have a few questions when you're isolating wild strains. One of the issues in fermentation is, especially when you're doing no pretreatment, is how are you going to optimize the conversion to sugars? Because yeasts have quite a limited ability to produce the amylases, glucanases, the debranching enzymes. So simply heating will mean that a lot of the polymer material is not accessible to be converted to alcohol. So do you have any comment on that?
Yes, madam. Mostly the hemicellulose content will not be, especially lignin content and other polysaccharides will not be simplified. So this is a preliminary test. So how much amount of reducing sugars that we are obtaining after heating, we are testing. So the yield is definitely less, but in further studies, this liquor may be subjected to biological treatment by using white rot fungi. I had white rot fungi which can produce hemicellulases, cellulases, and lignolytic enzymes, so that we will get a simple sugars after conversion of all these polysaccharides into simplest forms. So we are trying on that, madam. I'm having white rot fungi. So for the treatment of all these polysaccharides.
So you would do that as
we are planning this a small work.
Yeah.
So
yeah, you could do that as a pre-step before the
yeah.
The second point is that when you're using the wild yeasts, they're not naturally highly tolerant to ethanol. It's quite toxic actually. So this is why in industry they have selected and even genetically engineered strains to increase their tolerance. Because otherwise you will get a yield of ethanol at which the yeast will die because it becomes toxic. So any comment on this?
Still no, I'm not having that much of details about the organism, madam. So it is giving a small yield, but I have to go, if at all we succeeded in our future work, definitely we go for strain improvement. If we get a good strain.
Okay, so the other thing you can do, because you are doing your fermentation, you can look at the yeast that survive the process. So what are the living yeast at the end? And maybe you can also consider sort of passaging the yeast to select for the most tolerant. So each time maybe you can do subsequent fermentations and see if they get to a higher tolerance of ethanol. So that might be one thing you could consider that doesn't require, a high selection, but is part of your process. And you may be able to find, because they mutate naturally quite highly, you may be able to find you can select for strains with higher ethanol tolerance, which would be useful for this process. Yeah.
Definitely, ma'am.
Yeah, that's something I can suggest to you. But yeah, I think this is very good. I mean, we really need to look at sustainable energy production, and using the food waste is a really excellent source for this. So thank you for looking into this area. It's very important.
Thank you. Thank you, ma'am. Thank you.
Thank you.
Thank you.
That's all the questions I have, Dr. Glory.
Next, I invite Dr. Ajit Kenga to defend his paper. Next presenter is Ms. Rajani Srishal. Now I invite Dr. Ajit Kenga to defend his paper.
Yes, madam. Thank you very much. Am I audible to you all? Hello?
Yes, sir.
Yes, sir. You are audible.
Yes, sir. You are audible.
Yeah, let me share my screen. Is my screen visible to you all? Hello?
Yes, sir. Yes, sir.
Okay, thank you very much. Our respected chairpersons and all the delegates of the today's international conference and all the participants. Good morning to you all. I'm Dr. Ajit Kengar from the Department of the Botany, VG Vazir College, Autonomous, Mumbai. And today I'm going to present my paper, Induction of Somatic Embryos from Ruta graveolens and Important Medicinal Aromatic Plants. Yeah, this is my college, one of the finest institute in the Mumbai for the particularly science. We have a great infrastructure, at least in the biological sciences, is one of the best college for the biological research in Mumbai and in Maharashtra, and one of the finest institute in the Maharashtra because accredited 4 times with A, and we are the pioneer in the NAC. We were the first affiliated college in the Maharashtra in the 1997 with the NAC, and subsequently all the cycles we are the first one to accredit to the NAC. And this is my abstract. I will not go to the details because that will be depicted in the next. I'm talking about this plant. This is a plant called as a Ruta graveolens. It's a very important aromatic and medicinal plant belonging to the citrus family, that is a Rutaceae family, and is a very popularly called as a herb of grace because of tremendous use in the medicinal values in the pharmacogenesis. And actually this is an exotic plant, but it's a naturalized and cultivated everywhere in the world, and particularly in the India also. This is the plant. I'm not going into the details of this. Yeah, this is a very important plant because of the medicinal value, and this medicinal value is because of these 120 natural compounds belong to different classes. Particularly 4 classes have been identified, like a furanocoumarins, acridone, quinoline, alkaloids, etc. And even it has a very good essential oil, which is a present principle in the leaves of the plant, which is a strong detergent odors. These are the uses, and I'm not going to, because there are limit of 5 minutes, but the whole herb is about efficient, anthelmintic and antiplasmotic, carminative, expectorant, etc. It has a good alkaloids are there, which is successfully used for treating glaucoma and atropine poisoning. Volatile oil of this plant is antioxidant and phototoxical properties and used in cosmetic and foods. And the aim of my experiment was to establish viable, efficient protocol for the induction of the somatic embryos from the callus of the root graveolens. Even it was the aim was evaluate effect of different PGRs on callusing and induction of the somatic embryos. And The present investigation was therefore carried out to check the potent ability of the PCR on induction of somatic embryos from the callus of the ruta graveolens. Okay, as you know, the somatic embryogenesis is having more benefits than the traditional PTC, and it has very great values for the development of the new plants which are genetically identical. The material and methods. The plant was collected from our own company called as SH Kelkar Company, which is in the Mulund, Mumbai, and further it was maintained in the medicinal and aromatic plant of my college. Surface sterilization of the explant, where the explants called a stem having 1 to 1.5 centimeter washed with the running tap water for 10 minutes to remove the dust and other contaminants, followed by washing 5% tipol to remove the dust and all these. Then thoroughly washed with the running tap water. The cleaned explants were then treated with 3% Dettol solution. The washed explants were further treated with 1% Bivestin, which is a systematic fungicides. And then it was transferred to the laminar airflow. Then in the laminar airflow, it was explant were treated with the 7% ethanol for only 30 seconds. Further, it was followed by washing with the 3 times distilled water, sterile distilled water, of course, and then it is subjected to the 0.1% AgCl2 for 4 minutes, repeatedly washed after 3 to 4 washing done to the treated surface tolerant AgCl2, followed by Ciplox treatment for 1 minute, and then the explants were aseptically inoculated in the MS medium, supplemented with the different combination of auxin and cytokinins. And this is actually the method we use for the induction of the callus and proliferation. Particularly, the Na-2,4-D was used for the callusing, and the concentration was for the particularly 2,4-D 2.26 micromolar to the highest as a 13.43 micromolar. 3% sucrose was used as a carbon source, and gelling agent was 0.8, and all the the conditions were like a standard condition were maintained for the this experiment. For the induction of somatic embryos, the callus which is obtained from this 4.5 to be, because it was an optimum result was given by this concentration was used, and that callus was it was transferred on the new medium called as a somatic induction medium, which is in combination of the cytokinin or alone, particularly MS with the BAP, benzylamine 2.22 to highest was, it was 13.31 micromolar. Even kinetin was also used, and this was 18 cultures, 18 culture tubes were used for this experiment, and the gelling agent was similarly like a standard plant tissue culture medium 0.8%, pH was maintained 5.7 using the NaOH and 0. SCl as per the requirement. Cultural conditions, it was incubated 25 plus minus 2 degrees Celsius under 16 hours photo period with cool and fluorescent light. And the number of somatic embryos formed was recorded after 14 days. Now this is the result where we can see the callus induction was done using the 2,4-D, and this is the 4.52 micromolar, which gives the result in the initiation was for only 12 days, and the callusing degree, degree of callusing was highest degree, and it was yellow green fragile callus was obtained. This is the photograph of the callus, which shows the very good proliferation and initiation. And coming to the I'm really sorry. For in vitro induction, this was the done. I think it is repeated. Let me check. Yeah, for the BA induction, this alone using the BA as a cytokinin for induction of somatic embryo. This is the table you can see. This is the highest degree of the callousing percentage was done on 23 plus minus 1.5, but this was, it was 75% callus response in the BA. This is the callus showing some of the somatic embryos are seen in the callus. And this is the combination which is gave good result in combination with the NAA. BA was kept as a constant because it was gave good result for this, and in combination with 2.69, which is the lowest concentration, it gives 90.67 callus response was there, and the maximum mean number of somatic embryos was from 27 plus minus 1 plus 1.15 embryos were recorded. And this is the photograph of this result. Okay, now coming to this discussion, as you know, the cytokinin are the good giving the result, as so many authors are described in combination of the combination of the cytokinin oxygen gave result. In our case also, because the Bhaskaran and Grando all has reported this cytokinin has given the best result with oxygen. In even in the case of Ramakrishna in 26 in the Citrulus colosynthesis, they have also obtained the good result with using the BAP as lower concentration, found very optimum concentration for the high frequency of the embryogenesis. And this is their result obtained in the Citrulus colosynthesis in combination with the BAP and NAA. And this is the agreement with this result with this. Even the Shastri's result was in agreement with my result. Timir, 2007, obtained somatic embryo from the leaf explant on base MSC medium supplemented 2.3 molar kinetin and using the IB as in the Jatropha curicus. This is the conclusion of my study. Murasigescu plus the medium content consists called as a 2,4-D, which gives the good result for the callousing. And even in combination with the NA and both are the lower concentration, actually BAP and NA give good result for in this study. And this study is again, provide a medium containing both oxine and creatine was capable of inducing the formation of somatic embryogenesis. And definitely this study would help for the large scale production of the root agarrants by somatic embryogenesis. This is I'm acknowledging the University of Mumbai for providing the financial support to carry out the research work under the minor research project. I'm also thankful to the management and principal of my college, Dr. B.V. Sharma of my Kelkar Education Trust, Vijay College, for providing a very good necessary infrastructure and support. These are the references I followed. Thank you very much. Hello, am I audible? Hello?
Yes, sir, you are.
Yeah. Mine is over. Thank you very much.
And ma'am, any questions?
Thank you for the nice presentation. I think working with somatic embryogenesis is always very tricky. They say it's more like magic than science.
Yeah.
Because you have to have, like the green fingers, but in the lab green fingers. So I think it's good work because, as you say, this can really scale up production of quality of the medicinal plant. Have you looked at many different genotypes in your study?
I'm actually not audible, madam. Can you be louder, please?
Oh, actually, I can't do anything about that.
Yes, please, please.
I can't make my sound any louder. I'm using the microphone on my laptop. So
Okay.
I was just asking if you have tried different genotypes and whether you find different results.
No. Only the Elisate, the species is there, not different genotype actually.
Okay, so sometimes you may find different responses with different genotypes. So
Okay.
it might be worth collecting different materials. And also, is there much variation? Is it known if there's much variation in the compounds between different accessions?
No, madam. No.
Because
Hello, sir.
yeah, you can choose to use an accession that has a lot of a particular metabolite of interest. So sometimes that is one of the ways that people can go. Of course, you want this mixture. That is the value of medicinal plants, that it's not just simply one compound, but the mixtures of compounds that is important. Thank you.
Hello,
Yes,
sir.
ma'am.
Hello, sir. I have one question.
Yeah, please.
Your conclusion is this somatic embryo can be exploited at a commercial scale for extraction of this secondary metabolites from this particular. Why should you go ahead with this tissue culture techniques for commercial exploitation of the secondary metabolites instead of going protoplast culture?
Yeah, protoplast culture is not tried actually. The cell suspension culture already, callus culture, cell suspension culture is done, but not, the report in the case of the somatic embryogenesis is only one report is found to me, and that is from the outside the Middle Eastern countries, and this is the first effort done in the India, and already I have done so many work in the root agrogenesis, in the microprovocation, their bioreactor studies, their and oil analysis, everything is done.
Yeah, my suggestion, whenever plant is micropropagated for commercial extraction of secondary metabolites, it is better to go ahead with the protoplast culture rather than somatic embryo. Why should we go ahead with a tedious process? If plant is in extinct condition, we can go ahead with this thing. That's my suggestion. Thank you so much for your presentation.
Thank you, Mary. Can I just say, protoplast culture so far not done in all over the world in the root agrogenesis. That is my information. But that is good opportunity to researchers to go for the protoplast culture.
Okay.
Thank you, madam. Thank you very much.
Thank you.
Next, I call upon Ms. Rajini Srishat to present her paper. And I request Ms. Syed Ali Fatima to get ready for the next presentation.
Hello.
Hello, ma'am.
Hello. This is
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Audible to everyone?
Yes, ma'am.
Yes, I'm sharing my screen.
Yes, ma'am. Please.
Hello. Rajini, your screen is not visible.
Yes, sir.
Are you sharing?
Yes. Sir, I am about to share my.
Okay, okay.
Hello. Hello.
Yes, Rajini.
Hello.
Yes, ma'am. Yes, ma'am.
Hello. Sir,
Yes, ma'am.
ma'am, there is some issue with my PPT. Can I ask sir to share?
Yes, ma'am. Yes, yes. With sir, ma'am?
Yeah, I'll share, Rajini. Just.
Sir, then I have to make you a co-host. Kindly wait, sir.
Yeah, please, please.
Jennifer, if it's so problem, ask other next participants to present.
I made sir as the co-host. I think he'll be sharing the screen.
Okay.
Yes, he will be.
Rajni ma'am, you please stop sharing your screen. Then only sir can do it. Rajni ma'am. Ma'am? Ma'am, can you hear me?
Hello. Rajini?
Sir, if there is no problem, can I call the next participant? Can you press it at the last?
Please do that.
Okay.
I'll share afterwards.
Okay, okay, sir. Ms. Said Ali Fatima, can you start with your presentation? Ms. Said Ali Fatima?
Yeah, I'll start. My screen is visible.
Yes, your screen is visible, ma'am.
Good morning, everyone. This is my work titled Salanin as a potential therapeutic agent that targets spike protein of SARS-CoV irrespective of N501Y and B484K mutation. We all know about Asadirachta indica, commonly called neem. It is the most useful traditional plant in India. Each part of the neem tree has some medicinal property and is commonly exploitable. Medicinal properties of neem like antibacterial, antifungal, antioxidant, anti-inflammatory activities, especially antiviral activity has been proved by many researchers. Like me, we all know curcuma longa turmeric. Turmeric is also a traditional medicinal herb. It is used for many purposes in home. Apart from its culinary uses, turmeric is used to treat many diseases. Turmeric also has antibacterial property, antifungal, antioxidant, anti-cancer activity, especially antiviral activity. Severe acute respiratory syndrome, coronavirus 2, which caused coronavirus disease 2019, the respiratory illness responsible for the COVID-19 pandemic. It infects a large number of people, resulting in death and excess mortality. This is the structure of SARS-CoV-2. SARS-CoV-2 contain 4 structural protein and 16 non-structural protein. Structural protein include spike protein, envelope protein, nucleocapsid protein, and membrane protein. From that, spike protein is the one which is responsible for allowing the virus to attach and to fuse with the membrane of a host cell. So now the global scenario is supporting the world by the development of drug which is less toxic plant products. This is my work plan. First, to identify and download the structure of SARS-CoV-2 spike protein using protein data bank. Next, to identify and download the structure of bioactive compounds from database. Next, docking of the identified compounds with SARS-CoV-2 spike protein. Finally, analyze and characterize the interacting residue of dock structure using leaf plot analysis. Recently, SARS-CoV-2 spike protein is mutated on a asparagine 501 is substituted by tyrosine and glutamic acid 484 is substituted by lysine. So compare the same compounds with wild type of protein and mutated protein. This is the structure of SARS-CoV-2 which was identified and downloaded in protein data bank. This is the open state of spike protein and this is the closed state of spike protein. In open state, receptor binding domain is accessible and in closed state it is inaccessible. This is the structure of bioactive I selected from me. Through this literature, this compacted from further activity. Structure of bioactive compounds is acted from turmeric. It also selected through this research given. Next, it's the molecular docking. It is a technique used to predict how a protein interacts with ligand. Autodoc 4.2 was used to study the binding affinity from the identified bioactive compounds. This picture shows that a ligand binds with protein. Next, this graphical representation shows binding energy of compound against wild type of spike protein. Here, curcumin binds more effective, followed by salanine in closed state. The same curcumin binds more effectively, followed by nimbin and salanine in open state. This is also a graphical representation which shows binding energy of compound against spike protein of SARS-CoV-2 which is carrying mutation. Here, salanine bind more efficiently, followed by curcumin, turmeric, curcumin. The same salanine will more efficiently, followed by curcumin in open state mutated. Finally, I analyzed using leaf plot analysis. It was performed to analyze bond interaction and residues. Her more efficiently binding compounds were analyzed. So curcumin and salanine bind more efficiently. So I used that compound for leaf plot analysis. This is the binding residues of curcumin and salanine. And in open state, this is the binding residues of curcumin and nimbin. Here, curcumin binds more efficiently in wild type of protein in open and closed state. So this is the binding residues of curcumin. Red represent the closed state and pink represent the open state. The middle part is the common binding residues of curcumin in open and closed state. And this is the binding residues of salanine and tamarind in closed state mutated protein. And this is the binding residues of salanine and curcumin in open state mutated protein. Here salanine is the common which is bind more efficiently. So salanine bind more efficiently in mutated protein of closed and open state. So this is the binding residues of salanine. Red represent mutated protein in closed state. Pink represent mutated protein in open state. This is the common residues of salanine. Finally, I concluded that curcumin has least binding energy and closed state followed by salanine. However, when the protein is carrying mutation, salanine binds more efficiently followed by turmeric with negligible difference in the binding energy. In open state also, curcumin has least binding energy followed by nimbin and salanine. However, when the protein is mutated, salanine binds more efficiently, followed by curcumin and imine with slight difference in the binding energy. Even though curcumin binds more efficiently when the protein is in wild type, but curcumin loses efficiency when the protein is carrying mutation. So I conclude that the alanine binds more efficient irrespective on the state of the protein as well as mutation. I concluded that salanine will be better compound to target against SARS-CoV-2. SARS-CoV-2. These results have to be taken further in cell model to similar action of compounds in vivo. As the present discovery of the SARS-CoV-2. Thank you. Ma'am.
Hello, Fatima. Can you hear me?
Yeah, ma'am.
Okay. Thank you for the very interesting presentation. So these are natural products. How would you see them being administered if they have some protective effect against the virus?
Hello. Hello, ma'am.
Hello, can you hear me?
Yeah.
I think I have a problem that people can't hear me. I tried.
No, ma'am, our voice is very audible, ma'am.
Oh, okay.
They have some technical problem, ma'am.
I see. Okay, thank you, Flora. I was just wondering how you would see this natural product being used. Is it in a form of herbal food, or how would you administer this? Thank you.
Secretary Fatima. Ms. Saidali Fatima.
Hello. Can you hear
Have
me?
Yes, ma'am. Have you understood the question, ma'am?
Sorry, ma'am. What? Some technical problem. Please again tell me. Hello. Ma'am.
Ma'am, the question asked was how you can administer this in our daily food like that.
Because it is easily available. We normally taking that apart from its salanine is extract from neem and prepare as drug and take it give more response against SARS-CoV-2. Hello, ma'am. Did you hear me?
Yes, ma'am, we heard you.
Yes, can I ask some question?
Yes, sir.
I'm just asking from neem extract, how you make the sample? I mean, how you can get the desired material from the neem extract, neem leaf extract?
So,
It's only done with. Yes, sir.
It's a green chemistry approach or what? That's what I want to ask.
No, sir.
I'm asking, is this green chemistry approach, as you told that you are using the neem leaf extraction. So that's why my question, which process you have applied for your research?
No, neem leaf extract. Commonly, I selected these compounds from whole neem and study bioinformatics study only, not doing in vitro studies.
Okay. And your work is molecular docking. Molecular docking will be applicable for vaccinology. What do you think?
Using these studies, next we going to in vitro studies and analyze this result.
No, I'm asking molecular docking. You are showing that molecular docking. So molecular docking can be applicable for vaccinology. I mean, production of vaccine, nanomedicine, like that.
Yes, sir.
Did you attempt anything?
No, sir. This is my first work, sir.
Okay. Okay. Thank you for your nice presentation.
Rajini ma'am, are you ready to present?
Hello, yes, ma'am. I'm ready to present. Just I want a favor from Ajit sir. Can he present for me?
Yes, yes.
Can
Yes,
I
just
share the screen? Hello.
Yeah, I'll share.
Thank you. Thank you, sir.
And the next presenter is Dr. Bennett. I request Dr. Bennett to get ready for the next presentation.
Yes, Rajini.
Yes, sir. Hello. Hello, everyone. Am I audible to everyone? Hello. Am I audible to everyone?
You are. Yes, ma'am. Yes, ma'am. Yes.
Yeah, thank you. Thank you. Yeah, my studies are on HPTLC profile and antimicrobial activities of the Caesalpinia bondusella. My guides are Dr. Ajit Kengar and Dr. Aruna Rai. So next. This is the abstract of my paper. As we have decided to study the antimicrobial properties and the HPTLC profile of the secondary metabolites which are present in the plant, that is Caesalpinia bondusella plant. This is the introduction that plants are immense source of the secondary metabolites and the medicines for thousands of years. They are also known as the green medicine, and it is safe to have them without any side effects. Many literatures it has given proof. So secondary metabolites are nothing but the biomolecules which are present in the plants. They are antibiotic resistant in human and also are useful as in the plants as a plant pathogens. So plants possesses different medicinal values such as antiviral properties, anti-diabetic, antioxidants, and antimicrobial properties. And my plant is Caesalpinia bondusella, as I said earlier. It belongs to family Leguminosae. The subfamily is Caesalpinia. These are the Caesalpinia plant, which are with the green ica beans. The seeds are very hard. You can see this is a pricky shrub, which is available occurred all over the world, but now it is seems to be endangered species. Next slide. Yes, the medicinal importance of the Caesalpinia bondusella is that it is having immense of the importance in the traditional medicines such as the diabetes, anti-inflammatory studies, anthelmintic properties, anti-estrogenic properties. It is also used as anti-malarial drug, also analgesic, and it is also used in the Ayurveda as a memory enhancer. Next slide, please. So the concern were that we have been decided to study the callus and the seed as a crude part of the plant. The callus is grown in vitro condition already in in vitro conditions by using these various plant parts such as the seed, apical meristem, leaves, and the internodes. So aims were there decided to study the antimicrobial properties and the secondary metabolites present in the plant. With the help of HPTLC analysis, we have tried to find out number of the secondary metabolites which are present in the plants. Next slide, sir. So these are the material methods which we have used for the HPTLC studies. We have taken a 1 gram of a plant sample in a ratio of a 10 ml of a methanol or any organic solvent we have used. Here for the HPTLC studies, we have selected a methanol as the preliminary study has shown various secondary metabolites present with the extracts of the methanol. The solvent system is used for the mobile phase or a solvent system which we have used was a toluene is to chloroform is to ethanol in the 40:40:10 ratio, and the plates were sprayed with the anisaldehyde and sulfuric acid reagent. They were dried at 100 degrees Celsius in a hot air oven for 10 minutes for the develop. For antimicrobial studies, we have taken the same ratio, 5 gram of powder in a 50 ml of organic solvents. Here we have taken 2 solvents like methanol and diethyl ether in the 40% of this concentration. It was kept for 40 hours, like a cold infusion methods. We have taken the extracts for the maximum of the secondary metabolites which comes out or the leaches out from the plants, and extracts have been prepared. 48 hours, the extracts were filtered with a Waterman filter paper, and the extracts were evaporated till the dryness. And after that, whenever it has been used or applied, again it has been liquefied. Next slide. The bacterial strains which we have used, such as the gram-positive bacteria and the gram-negative bacteria, because these are the highly pathogenic bacteria, Bacillus subtilis, Staphylococcus, E. coli, and the Klebsiella pneumoniae were selected. We have procured these strains from the Bombay College of Pharmacy that is located in Santa Cruz in Mumbai. Sir, next slide, please. Yes. The results were revealed that when we have developed the HPTLC plates, these are the 3 plates which we have studied. Plate 1 denotes that visible under the visible light. Plate 2nd is under the 250 nanometer. Plate 3rd is denotes the 366 nanometers under the UV light. These plates are before the derivatization. 1st and the 4th tracks reveals the seed extract. 2nd and 5th track reveal the callus extract. 3rd and the 6th track reveal the seed oil. Before the derivatization, no clear fluorescent bands were appeared. But sir, next slide, please. Yes, but after the derivatization, that is after the spraying of the anisaldehyde and sulfuric acid reagent, the plates have been developed. So you can easily find out the bands in the bands segments, which shows the different secondary metabolites which are situated in the plants. So we have next slide. Yes, this is the densitograph, which shows you or which tells you exactly the amount which are present in the seed. The different peaks shows you the amount. Number 1 track and the number 7th will show you the highest of the secondary metabolites which are present in the seed. Next slide. So next slide, please. Yes, the second one shows you the callus, which are having near about five of the peaks, in which the first one is the very highest in the densitograph. That means it is highly, the present of the secondary metabolite is highly present in the first track. Next slide, please. Next, yes. This is the last one slide. Sorry, this is the callus. Sorry, this is the seed oil, which shows you near about four different peaks, which tells us that the callus and the seed are shows more of the secondary metabolites present, shows the present in compared to the seed oil, whereas seed oil just shows the 4 of the secondary metabolites only. This is the HPTLC peak values, which gives you the exact number, maximum number, the area which has been occupied in the densitograph. Next slide, please. Yes. This is regarding the callus. The highest were 69.31, as we have seen in the densitograph. The first one was a very higher. The area occupied is the 69.37%. Next, please. Yes, these are the results of Caesalpinia bondicella seed extract, which shows you the methanolic seed extract gives a good inhibitory properties against the E. coli and against the Bacillus subtilis also. Next slide, please. Next slide, please. Yes, these are the plates, which shows the result of the callus extract, which shows that there were no much inhibition has been observed against the callus extract. Next slide, please. So next slide, please. Yes. Here are the, in the tabular form, the result has been written. The gram-negative and the gram-positive bacteria in terms of the seed extract, that are the methanolic seed extract, shows the more relevant result in the inhibition properties of the seed extract of Caesalpinia ponducilla, whereas the diethyl ether does not show any much inhibitory properties. Next slide, please. Next slide, please. Yes, the callus extract also shows the good result with the methanolic extract only, with the gram-negative and gram-positive bacteria too. Whereas the diethyl ether does not show any inhibitory property against against the gram-negative bacteria. Next slide. Yes, these are the discussions which comes after the results, that HPTLC studies reveals that seed oil, methanolic extract, and the seed of the seed and the callus shows more of the presence of the some common compounds, as well as some compounds only detected in callus but not in seed oil. Same here in the callus also, the some of the compounds which are present in the callus, they were not present in the seed extract. Antibacterial study shows that the methanolic extract in the more concentration gives the best results against the pathogens such as E. coli, Klebsiella pneumoniae, Bacillus subtilis, and Staphylococcus aureus than the callus extracts. While the callus extracts does not shows the appreciable inhibitory activity against E. coli, Klebsiella pneumoniae, and Bacillus subtilis, but there were no activity has been seen against the Staphylococcus aureus, as it is a more pathogenic bacteria, we can say. As we have seen, diethyl ether does not show any of the inhibitory properties. These are the references which I have done for my studies. Last but not least, thank to all of you for listening to me. Thank you.
And ma'am, if any questions?
I have one question. Can you please tell me what is the green medicine?
The green medicine is the plant which has been studied for the secondary metabolites. Okay, the secondary metabolites having the role, a definite role in the activity against the physiological activity in humans as well as in other animals too. The green medicines are till today we are in the belief that they don't have any of the side effects. So whichever we are extracting from the plants, that are nothing but the green medicines.
Actually, you make the word green medicine. Actually, you are processing some green chemistry approach or something else, right? My comments is green medicine seems medicine is green. So you just think about it. Green, which process you are applying? I mean, green chemistry approach or green extraction to make the medicine. That's why I'm telling you. My comments is there. Okay. Thank you for a nice presentation.
Yes, sir. The approach is okay. Thank you, sir.
Ranjani, can you hear me?
Yes, ma'am, I can.
Okay, very nice work. Is this traditionally used as a medicine? And may I ask, how is it traditionally prepared when it is used as a medicine? How would you take this?
Ma'am, the seeds has been used as in the decoction also as in a seed powders. As in Ayurveda, the seed powder has been used in preparation of the churnas and also in the quats or the kadhas we use in the preparative medicine in the Ayurveda. The proportion has been decided according to the patients to whom which we are going to give and the severity of the diseases. So kadhas, quats, tablets forms and the churnas are there, which are in the form of the seed powder, the leaf powder, and the quats has been made from all that available plant resources. In this form of the they can give the medicines.
I wonder, because you have looked at solvent extraction, have you looked at aqueous extraction? Because often for traditional medicines, like in Malaysia, I'm familiar, it's normal not to use alcohol because of the Islamic preference. So they will actually use a steeping in water or boiling, and it will, maybe you get a different profile and different activity if you use. Yeah, have you tried that?
Yes, ma'am. Previously, we have done with the aqueous extract, but the aqueous extract do not show any inhibitory property with the antibacterial activity. We don't know how, but we fail to get the results for the inhibitory properties against the bacteria. Yes, there are the results which gives the good properties with the aqueous extract also, but not in the case of the antibacterial and antifungal studies. The extract has definitely having a good medicinal value with the aqueous extract also, but in antibacterial we doesn't found that, ma'am. We have tried that.
That is interesting. Okay, thank you very much.
Thank you, ma'am. Thanks a lot.
Now I call upon Dr. Bennett to present her paper. And the next presenter is Dr. Celine Paparani.
Good morning, ma'am. Am I audible?
Yes, ma'am.
My screen is
Kindly stick on to that presentation time because we have many members waiting.
Yeah, sure,
Please
ma'am,
give much importance to your discussion part.
Okay, ma'am. Okay.
You can go on with the introduction and the materials method. Give much importance to your discussion part.
Okay. A very good morning to everyone present here. This is Bennett from the Department of Botany, Holy Cross College, Nagarkoil. I am very glad to present my paper entitled Biochemical Characterization and Biopesticidal Activity of Extracellular Polymeric Substances produced by Pseudomonas aeruginosa B01 isolated from sewage water. So extracellular polymeric substances, that is abbreviated as EPS in this PPT to introduce. So these are the extracellular polymeric substances, or the mixture of organic compounds that are released into the surrounding medium by microorganisms like algae, fungi, and some bacteria. EPS give protection against some toxic materials and external harsh environment like salinity, temperature, and pH. Again, this EPS acts as carbon source and energy resource during starvation. So in this study, EPS was isolated and characterized from Pseudomonas aeruginosa B01, which was screened from sewage water. The purified EPS was then analyzed for monosaccharide composition using gas chromatography and mass spectrophotometry. Then biopesticide was also formulated using EPS, and its activity towards the pest mealybug was elucidated. In methodology, sewage water samples around the Nagarkoil area were collected and were used to screen EPS producing bacteria. For this, a total of 1 ml of sewage water was aseptically added in physiological saline, and serial dilutions were made up to 10 to the power -7 and inhibited in nutrient agar medium. Bacteria which produce EPS, that was characterized by forming a very thick slime around the colony, were subsequently selected and purified by streaking the 4 quadrants to obtain single colonies. Bacterium which showed maximum production of EPS was selected for further study. This is the picture which showed EPS around the colonies. The potent EPS producing bacteria was subjected to 16S rRNA sequencing, and an accession number was assigned, and which was identified as Pseudomonas aeruginosa B01. Purification EPS was done by precipitation with trichloroacetic acid to eliminate the proteins. Again, it was precipitated with double volumes of ice-cooled ethanol. Further, EPS purification was done by following the combination of ethanol precipitation and also dialysis. Then the monosaccharide composition of the purified EPS was analyzed by GCMS. Then biopesticide was formulated using EPS in dust and liquid form by adding sucrose as additive and in the ratio of 10:100, and its activity towards the pest was elucidated. The fruits of cocoa plant infected with the pest was sprayed with EPS and pest reduction was noted. So result, the gas chromatography and mass spectrophotometry result showed in this graph. So this showed the total sugar content of EPS was found to be 43.9 microgram per milligram, and the compounds presence of 3 monosaccharides that was noted in redding, that is D-mannose, D-galactose, and D-glucose. And there are also some other polysaccharides are also noted here. They are octosilaxone, hexadecamethyl, cyclohexane, cyclotrisilaxane, or the other compounds that are noted here. So these are the field trial treatment that is EPS that is used as a biopesticide. And here in this picture, this fruit that is infected, fruit with a mealybug, this is the non-infected. Here, this is after treatment. This is the before treatment. This one, after treatment, it shows no infection at all. So maximum reduction of mealybug was noted. The fruit of cocoa plant sprayed with the EPS dust showed 73% of pest reduction, whereas the fruit sprayed with the EPS liquid showed 51.5% of pest reduction after 2 weeks, that is 14 days of treatment. So maximum reduction is noted in powder form of EPS. So to conclude, EPS from Pseudomonas aeruginosa B01 is an efficient green pesticide with the characteristics of zero pollution, non-toxic, and high safety to non-target animals. Thank you. Hello.
Hi, ma'am. Do you have any questions?
Hello. I'm not familiar with this method of using the EPS. Has it been used before in this way? And if not, what made you decide to explore this?
Sorry, ma'am. I don't get you.
Okay.
Sorry?
Has there been previous reports of using EPS as a pesticide?
Yeah, ma'am. Yeah, ma'am. It's my research work. The EPS that was extracted from the bacterium Pseudomonas aeruginosa, then it is used as a biopesticide.
Yes. Has that been done by other people before?
Not it. Not it.
Ah, that's why.
Have to practice, ma'am. Have to practice. This is a research work done by me.
Yes. So what made you think of using this as a pesticide?
So to avoid the chemical pesticide that cause the pollution, to avoid the use of chemical pesticide, and also this one target only the pests which are affecting the plant, not the other animals.
But how did you get the idea that this would work?
Sorry?
How did you have the idea in the first place? That was what I'm asking.
The idea? Because many other researchers have been working on biopesticide. This was the first work, not the first work, but numerous work has been done by previous scientists. So referring those articles only, I have decided to do this.
Yeah. Okay. Very nice. Thank you.
Thank you, ma'am.
Now I call upon Ms. Swati Lakshmi to present her paper. Swati Lakshmi. Swati Lakshmi, you can share your screen.
Yes,
and
ma'am.
the next presenter is Dr. Sandana Mari.
Ma'am, is my screen visible? Hello, ma'am.
Yes, ma'am. Yes, ma'am.
Is my screen visible, ma'am?
Yes, ma'am. Yes, ma'am. But have you shared your screen?
I have been sharing. So is it visible? My presentation is it visible, ma'am?
No, not yet, ma'am.
Is my screen visible now, ma'am?
Yes, visible.
Visible. Yes, ma'am. Thank you. So I'm Mrs. Swakalakshmi. So I'm doing my under the guidance of Dr. T. Kondrati, Head and Assistant Professor of Botany, Kamaraj College. So I'm here to present a paper titled Assessment of In Vitro Anti-Diabetic, Anti-Inflammatory, and Antioxidant Activities of Rhasis flabelliferlin underground sprout. So the aim of the study was to explore the anti-diabetic, antioxidant, metal chelating, and anti-inflammatory properties of Rhasis lin underground sprout in vitro. So we all know plants have been a source of nutrition in human diet for over ages, and scientific studies reveal that intake of these plant products is health promoting, and also it prevents diseases because of presence of such substances known as phytochemicals. And the study material palm tree has diverse applications, and it is said to possess more than 800 diverse applications, as no part of the plant goes waste. So it is also called Kalpavriksham, and it is the tree of Tamil Nadu. It is also said to possess a high nutritional value and also has biological and pharmacological importance. Uh, so coming to materials and methods, the plant material to be studied, that is the underground sprout, is collected and the peels were removed and boiled for 15 minutes, and the boiled sprouts were cut and thoroughly ground into fine powder. And for extraction, I have used chloroform as the extracting solvent. And to assess the anti-diabetic activity, DNSA method was used, and alpha amylase was used as the target enzyme. So the mixture was cooled, and it was the absorbance was measured at 540 nanometer, and the percentage inhibition was calculated. And to determine the total antioxidant activity, Preto et al.'s phosphomolybdenum green method was adopted, and the absorbance was measured at 695 nanometer, and the percent of antioxidant activity was calculated. And to assess the metal chelation activity, to assess the ferrous ion chelating ability of the extract, Dennis et al. Procedure was used, and the reaction mixture was measured at 560 nanometer, and gallic acid and ascorbic acid were used as a control, and percent inhibition was calculated.
Excuse me, ma'am. Ma'am, you can directly go with your result and discussion.
Yes, ma'am. So results that we obtained from the anti-diabetic activity shows that it has highest amylase inhibitory activity, and it suggests that the alpha amylase, if it inhibits alpha amylase, it would induce, the extract would induce a delay in carbohydrate degradation, and which results in decrease in glucose absorption. So here the table and the graph shows the inhibition percentage is 79.41 for our extract. And coming to antioxidant activity, the table shows against the standard, we used acarbose. So against the standard, it shows 96% antioxidant activity, which is high. And regarding the metal chelating activity, the ability of our extract was moderate, and and the findings indicate that the extract has a capacity for ion binding, and antioxidant activity. It also implies the antioxidant activity and the ion binding capacity are interlinked. So here the table shows our sample showed 25.5% of metal chelating activity. So in order to assess the anti-inflammatory activity, we used a proton denaturation assay, and it was the text extracted significantly inhibited protein denaturation. Protein denaturation, which might be an indicator of for inflammatory and arthritic diseases. So our sample showed 91.18% of protein denaturation activity. And to conclude my presentation, the anti-diabetic activity, anti-inflammatory, and antioxidant activities were noted in our assays. And since the plant exhibited, significant activities, it can be used for the use by further purifying, isolating, and before being used as a drug. And the tests have been done, the findings suggest, it had been done only in vitro, but the findings suggest that it might be used as a fruit drug and also a dietary health supplement. And it also seems appropriate to consider it as a nutritional and nutraceutical ingredient for health promotion. And so these are some of my references which I took as for reviews. So thank you for this.
Thank you, Sati Lakshmi. Can you hear me?
Yes, ma'am, I can hear you.
Okay. So there are many medicinal plants, and a lot of these types of study. What do you think is the best way to focus on increasing the value? Because it's similar in Malaysia, we find the same thing. A lot of people do show it has all these activities, but then they don't take it any further. It never gets developed into a drug. It just stays as a health supplement. What do you think is the best way to see forward?
Ma'am, then I couldn't hear the last word. What would I suggest?
How can we go forward from being just a health supplement to being a drug, and what is the role in colleges and universities? Because I think colleges and universities, we do a lot of this very early stage, and then we stop and we look at another plant and another plant. How can we actually stay on one plant and get a product made?
So I'm supposing the question would be the role of colleges and universities to proceed these researches. Is it that, ma'am? So I'm not getting it properly because there are some technical problems. So
I'm asking you. Thanks.
So that colleges and universities must provide good facilities for us, for students like us, because research students, there are so many research students here focusing on drug development, and they need to focus on the drug development, but in some places there are no facilities like that, and being from remote areas, we couldn't explore so much. So if universities and colleges can facilitate, provide us the facilities, or make us know the facilities where it is, so there could be more researches, and there could be more, we could explore more in such fields. Hello, ma'am.
Yes, thank you. I think also some of you who are young scientists need to go into business as well, not just for everyone to stay as an academic. That is another thing that we try to encourage here, but not that many scientists feel they want to be business people. But we should encourage those who have the feeling to go into business and support them to go into business. I think this will be good. Thank you.
Yes, ma'am, because I also like to become a young scientist come businessman, but facilities here doesn't suit me. So yes, thank you, ma'am. Thank you.
Hello. Hello.
Hello.
Yeah, I have one question regarding this. Shall I?
Hi. Yes, sir.
Yeah. So when we talk about the extract, is it an 100% pure active ingredient which is extracted from the sources, or is there any other impurities in that extract?
It is not 100% purified extract, sir. So that's why I said it could be further used. I mean, before it could be used as a drug, it should be purified and characterized, isolated, because it is simply an extract which is made from chloroform. So it is not 100% purified, and it is not 100% could be made into drug, because we know chloroform could not be used as a drug which we can consume as used for oral administration. So it is not 100% pure.
Yeah, and this is the question actually I was looking for, because whenever we are talking about the plant extracts, so we always get stuck up with something like, no, we don't have a proper procedure to remove the impurities. So in this case, even though you have a very good results, if we not able to understand, optimize the procedure to eliminate those impurities, then there will not be any value for the study now.
Yes, sir. But since it is a preliminary study, so I didn't opt for that, and it was in vitro. So when we go for in vivo or a step ahead of this experiment, we'll definitely go through that, sir.
Okay, thank you. Thanks.
Now I invite Dr. Sandana Mari to defend her paper. And the next presenter is Dr. Selvi.
Dear participants, kindly stick on to the time. Please give much importance to your result and discussion. Just slightly touch your introduction and the materials with it, but you don't have to read it completely. Please stick on to the time.
Jennifer, ma'am.
Yes, ma'am.
Ma'am, I think Dr. Sandana Mari has left the meeting. Shall I call upon the next participant?
I think Selvi ma'am is presenting right now.
Okay. Okay, ma'am.
Ma'am, Sandana Mari ma'am has just now joined.
Daf ask Selvi to present if Sandana Mari have some
Selvi
problem.
ma'am. Selvi
ma'am. Yeah, she is presenting her screen, ma'am.
But she's not answering. Selvi ma'am.
Selvi ma'am, unmute your mic.
Daffodil ma'am.
Hello.
Can you, ma'am? Selvi ma'am. Ma'am, please present, ma'am.
It's visible?
Yes, ma'am, it is.
My voice is clear?
Yes, ma'am.
Very good morning to one and all connected here. I am Dr. Selvi, Assistant Professor of Zoology, St. Mary's College, Autonomous, Thoothukudi. My research topic is molecular docking studies of potent anti-cancer agents from liver extract of marine pufferfish, Arothran hispides. Ocean covers 71% of the earth and contains approximately half of the total globe biodiversity. The bioresources present in the marine ecosystem have potent biomolecules, that is natural organic compounds. These compounds are reported to have the biological activities. So intensive research for decades has proved that the marine organism are magnificent source of the bioactive secondary metabolites. So bioactive secondary metabolites produced and stored by this organism may be potential bioactive compounds. So for this study, I have selected the pufferfish Arothran hispides. There are 189 species of pufferfishes and 28 genera in the family Tetrodontidae. So the skin and certain other internal organs of the pufferfish are highly toxic to the humans. It will eat all types of food such as shrimp, fish, corns, etc. The fish which contain the tetrodotoxin, which is a non-protein organic compound and one of the strongest paralytic toxins today. Many bioactive compounds isolated from various marine organisms, especially from the fishes, leads to the development of the new drugs and therapeutic agents. Cancer is one of the leading causes of the death in both developed and developing countries. Therefore, for the wild concern, developing of the new anti-cancer drugs represent today's once more the most important research areas. An analysis of the number of chemotherapeutic agents and their sources indicate over 74.8% of the approved drugs and derived from the natural compound. Several anti-cancer agents.
Excuse me, ma'am. Selvi, ma'am. Excuse me, ma'am. Ma'am, I request you to go with your result and discussion.
Docking plays an important role. So this is for anti-cancer activity, the MTT assay for cell viability by Mossman method, the percentage of inhibition and cytotoxicity also calculated. For the cytotoxicity, for the anti-cancer activity, the percentage of cytotoxic inhibition will be increased, the increasing concentration, and it will be reduce the activity of the cell viability. So the molecular docking method by ACD Hemsketch method, for this we have to select the protein and the ligand docking. For the anti-cancer activity, BCL2, one human target was selected. So the ligand selection and binding site prediction, virtual screening, finally run the docking. So for this studies, there are 8 ligands are combined with the BCL2 of the human from the oleic acid with arginine 143 having high docking score value, that is 46.88. So these are the pictures, that is the interaction of the ligand with the BCL2. So my conclusion, the C possesses plenty of the new drugs. So from this, on the basis of these results, the Arothran hispides appears to be a good candidate species for the extraction of safe natural anti-cancer agents and also could be used in the human therapy. Hence, this information may help to develop potential purified bioactive compounds from Arothran hispides in the pharmaceutical industry for the development of the drugs, but it requires further clinical trials. My sincere thanks to our Marian family, especially my research guide, Dr. P.J. Josephine, to do this work successfully. Thank you.
Hello,
Hello, ma'am.
Can you hear me?
Yes, ma'am.
Thank you. That is very interesting.
Ma'am.
Interesting to use marine resources in this way. How could this be done practically? Would the compounds be purified and then produced chemically? Is there some sustainable way to get this compound from actual fishes? Is it really possible to do that in a sustainable way?
Ma'am?
I'm asking, is it possible to extract compounds from fishes in a sustainable way?
Yes, ma'am. The fish which contain the toxin, tetrodotoxin, it is given to the anti-therapeutic agent for the cancer patients. Chemo.
But
for chemo.
how would you produce this sustainably?
Ma'am, not audible, ma'am. Ma'am, hello.
Can somebody help me? Because I think I'm clear, but I don't know how to. A lot
Only
of
the
people
fish is.
my question. Yeah,
Hello?
I can't do this. I can't do this because nobody can hear me. Maybe I type the question. Can you see the chat?
Yes, ma'am.
Can you see the chat?
How can this be produced sustainably without affecting fish populations? Only the fish is eaten in the name of the chicken in the foreign countries or in the hotels, but the internal organs, lung, liver, all these organisms are a toxic. So it is a paralytic to the human being. So if it is not cooked clearly, the fish mussel also leads to the paralytic attack to the human beings. So from our literature study, it is the tetrodotoxin is given to the chemotherapy. So that's why it is the preclinical trials for the drug designing. Ma'am. To produce a drug or not. So only the preliminary work we have done, ma'am. Hello. Ma'am.
Sylvie ma'am, she posted thank you.
Okay, thank you. Thank you, ma'am.
Now we invite Dr. Sandhanamari to present her paper. Dr. Sandhanamari, next presenter is Deepa, Miss Deepa. Now, Dr. Sandhanamari, you can share your screen.
Can you audible, ma'am?
Yes, you.
Please wait, ma'am.
Sandhanamari, ma'am.
Yes. Can you see my slides, ma'am? Hello.
Are you sharing your
Please
screen?
share your screen.
Can you audible, ma'am?
Yes,
You
you're
are audible,
audible.
but your screen is not visible, ma'am. Kindly share your screen.
Yeah, I try, ma'am.
Is there any problem?
Yes, ma'am. Yes, sir.
Shall I ask the next participant to do?
Yeah, sure, ma'am. I'll
Okay.
next time. Thank
After
you.
ma'am, can you call the next participant?
Next, I request Ms. Deepa to present her paper.
Yes, ma'am.
Ms. Deepa.
Yes, ma'am.
And the next presenter is Mary Steffi. Deepa, now you can share your screen. And the
Yes,
next
ma'am.
presenter is Mary Steffi.
Ma'am, my screen is visible.
Yes, visible.
Good afternoon, everyone. Dear ma'am and sir, I am R. Deepa, student of 3rd BSc Microbiology in St. Mary's College, Autonomous Thoothukudi, under the guidance of Dr. Joyce Mary Albert ma'am. My topic is anti-diabetic activity of curd on albino rat. Introduction. Curd is regarded as a complete and natural food. It is a product of the milk which is white in color and resulted due to the bacterial action. Curd is prepared either from cow or buffalo's milk of family white. The curd prepared from buffalo's milk is denser 16 to 19%, than cow's milk 12% due to higher total solids. The microorganisms involved in the formation of curd are that such as Streptococcus cermonas, Streptococcus lactis, Streptococcus thermophilus, Lactobacillus bulgarius, Lactobacillus acidophilus, Lactobacillus helveticus, and Lactobacillus ceremonias. Probiotics are live microorganisms that may be able to help prevent and treat some illness. Probiotics are made up of good bacteria that helps keep your body healthy and working well. Microorganisms considered as probiotics, Lactobacillus species, Bifidobacterium species, L-casein. Reported beneficial effects of probiotic consumption include improvement of intestinal health, amelioration of symptoms of lactose intolerance, reduction of risk of various other diseases, and several well-characterized strains of lactobacilli and bifidobacteria are available for human use. Induction of diabetes alloxan 2456 or tetraoxypyrimidine 2456 or pyrimidine tetrone is oxygenated pyrimidine derivative was and originally isolated in 1818 by Bedmetalli and got its name 1838 by Friedrich Wöhler and Justus von Liebig. Alloxan is a toxic glucose analog which selectively destroys insulin-producing cells in the pancreas were administered to rodents and many other animal species. This causes an insulin-dependent diabetic mellitus called alloxan diabetics. In these animals, which would characterize similar to type 1 diabetes in humans. Authors are materials and methods. Animals. Male Mr. rat weighing 190 to 210 gram were used in experiments. They were maintained in standard environmental conditions, temperature for about 25 plus or minus 20 degrees Celsius, relatively humidity 55 plus or minus 10%, 12 hours dark or light cycle. They were fed with standard diet and water ad libitum. Chemicals and reagents. Alloxan monohydrate was obtained from SG Fine, Mumbai, and all other chemicals were of analytical grade and were acquired for commercial source. Alloxan-induced diabetic rats. Diabetics were induced by injecting alloxan monohydrate of 150 mg per kg body weight intraepithelially. After 1 hour of alloxan administration, the animal was given fed ad libitum and 5% dextrose solution for day 24 hours. Animals were kept under administration for 48 hours and blood glucose level was measured. Fasting glucose level should be more than 250 mg per dl. Experimental groups. Group 1, normal control saline. Group 2, diabetic control, alloxan 150 mg per kg. Group 3, diabetic rat plus glybenthymide 600 mg. Group 4, diabetic rat plus 200 mg per kg of sample. Extracts were given orally for 7 days at maximum dose 200 and 400 mg. Fasting blood glucose level was estimated for after 7 days at time intervals 0, 1, 3 and 7 hours of drug administration. Results and discussion. The blood glucose level in normal rate is the range of 85 to 132 mg per dl. Treatment with alloxan has increased the blood glucose level to a range 250 mg to 270 mg per dl after 5 days. Single dose administration of extracts at 200 mg per kg showed significantly reduced the blood glucose level on alloxan, induced diabetic rat, value control, glyman-climate 10 mg per kg, significantly reduced blood glucose level at first, second, and fourth hour after single dose administration. Alloxan induced diabetics. Repeated dose administration with the rat reduced the glucose level in time-dependent manner over the period of 3 weeks. However, animal treated with dose shows the significant decrease in blood glucose level on 20th, 21st day of treatment when compared to standard found some incubation 7 to 21 days. The supplementation improved the glucose tolerance in the fasted normal rats. Effect of single dose treatment of sample on blood glucose level on alloxan induced diabetic rats. Next one, effect of repeated dose treatment of sample on blood glucose level on alloxan induced diabetic rats. And the last one, percentage incubation of glucose in alloxan induced diabetic rats when sample orally administered in different days of study. Summary. Curd is natural and leading food which prevents from numerous enteric diseases. It contains lactic acid bacteria and prevents balance of proteins, carbohydrates, fat, vitamins, minerals, and water. Curd boosts the immune system and enhances stamina. Lactobacilli are used as probiotics, but significant investigation of such strain is chancy. The current aims to isolate and identify lactobacillus strain from curd. Samples for probiotic characteristics and antibiotic resistance determination. Curd samples were screened for the presence of lactobacilli. Alloxan is oxygenated pyrimidine derivative. Alloxan is a toxic glucose analog which destroys insulin-producing cells in pancreas when administered to rodents and many other animal species. This causes an insulin-dependent diabetic mellitus called alloxan diabetics. Treatment with alloxan has increased the blood glucose level to range 250 to 270 mg per dl after 4 days. Single dose did not show the significance of blood glucose level on alloxan-induced diabetic rat with controlled glyman-climide 10 mg per mg significantly reduced the blood glucose level at first, second, and fourth hour of the single dose. Repeated dose administration with the rate reduced the glucose level in time-dependent manner over the period of 3 weeks. However, animals treated with dose shows the significant decrease in blood glucose level on 21st day of treatment. When compared to the standard found some incubation 7 to 21 days, the supplementation improved the glucose tolerances in the tested normal rats. At present, people in the modern world are getting healthy conscious and have therefore opted for the change in terms of diet and their lifestyles. Conclusion. It is a time and dose dependent test. The blood glucose level in normal rat is the range of 85 to 132 mg per dl. Single dose did not show the significant blood glucose level on alloxan-induced diabetic rat, while controlled glyman-climide 10 mg per mg significantly reduced the blood glucose levels at first, second, and fourth hour after single dose. Repeated dose administration with the rat and glucose level in time-dependent manner over the period of 3 weeks. However, animal treated with compared to standard found some incubation 7 to 21 days. The supplementation improved the glucose tolerance in the tested normal rats. The result of study curd should be suitable for diabetic patients. Thank you. Thank you, ma'am. Ma'am.
And ma'am?
And ma'am?
Can you
Any question from your side, ma'am?
Just a comment. I'm very interested that curd has these good effects, and because I enjoy it in my diet too, and I think there's some indication that it also helps in our digestive system to encourage the good bacteria as well. So this is all very helpful in the case of diabetes. I think, I don't know for India, but in Malaysia, we have a very big problem now with diabetes, especially in young people, obesity and diabetes, and it's quite worrying. So this is an important area of research, because I think the diet and lifestyle is really, I think we forgot how we used to eat. I think the older generations used to eat more healthily, and we have to put some science to it, maybe to convince younger people to follow a good diet. So very nice research. Thank you.
Thank you, ma'am.
Sandanamari ma'am, are you ready to present? Now I request Ms. Mary Steffi to present her paper. Mary Steffi.
Ma'am, am I audible, ma'am?
Yes, Steffi, you are.
Okay, thank you. Good afternoon, everyone. I am Mary Steffi from St. Mary's College, Thoothukudi. The title of my project is Floristic and Ethnobotanical Survey of Terrestrial Vascular Flora in Pulangarsal Village, Thoothukudi District, Tamil Nadu and India. India is a mega diversity country, and the ecological diversity of India is enormous. Basically, the plant survey helped to determine the native plants, local flora and their uses, and endemic plants. Medicinal plants play a vital role in supporting healthcare system in the world. The rural population in developing countries utilizes locally available medicinal plants for their primary healthcare needs, because there is no hospitals for their health needs, so that they collect the locally available endemic plants and use that plants for their healthcare needs. The village folks develop their own therapeutic knowledge for the treatment of ailment with herbs, and this knowledge is only stored in their mind, because they are not well-educated people. So that they store only in their mind, and they transfer their knowledge to their younger generation. The scope of my study is this plant survey is necessary to make the flora and to conserve the plants. The ethnobotanical survey helps to collect the indigenous knowledge of plant from the native people that will be used for future research. With the consideration of this scope, the objective of the study is to study the floristic diversity of terrestrial flora in Pulangarsal village of Thoothukudi district, to study the medicinal plants used by the people of the study area, and to collect the information from the indigenous people about the medicinal plants. I have make the field trips from December 2017 to February 2018, twice in a month. The mature healthy plants are collected, and collected samples were identified by the help of Flora of Presidency of Madras by Gamble, Flora of British India by J.D. Hooker, and Flora of Tamil Nadu Carnatic by K.M. Matthew. And I have used some research floras too. The local inhabitants were interviewed to know about the uses of indigenous flora for curing different diseases, and the herbarium was made by the collected samples. This is my study area. My study area is Pulangarsal village in Thoothukudi block in Thoothukudi district of Tamil Nadu state, India. It is located 13 kilometers towards south from the district headquarters, Thoothukudi. Pin code is 628103. It is near to Bay of Bengal. So there is a chance of humidity in the weather. Let's see the result and discussion. The December 2017 to February 2018 survey of terrestrial vascular flora of Pulangarsal village. I have documented 130 plant species. which is belonging to 115 dicotyledons and 15 monocotyledons. The 130 plant species were belonging to 47 families and 113 genera. Of these, 106 were medicinal plants. The families with the most species were Poaceae 13 species, Papilionaceae 11 species, Cucurbitaceae 9 species, Amaranthaceae 9 species, Solanaceae and Euphorbiaceae were 8 species, and Malvaceae 7 species, Asteraceae 7 species, and Lamiaceae 5 species. The genera with the most species were Cenchrus 3 species, Ipomia 3, Solanum 3, Yerva 2, and Boerhaavia 2, and Sida 2. The Kulangarsal village is blessed with lots of plant resources, particularly medicinal plants. And these plants were established both in wild types as well as in cultivated mode. The medicinal flora of Kulangarsal village are not fully exploited. Some medicinally important plant species are fast diminishing, which are mainly due to the human interference. Therefore, the area needs proper protection for the conservation and survival of bioresources. These are 130 plant species collected from Kulangarsal village and their role. This is the traditional home remedies of Kulangarsal village for their primary ailment. I have collected 53 traditional home remedies from the indigenous people of Kulangarsal village. The habit-wise distribution of plant species shows 49% of herbs, 11% of shrubs, 20% of trees, 16% of climber, and 4% of creeper. These are some plant species collected from Kulangarsal village. Now I concluded my presentation. The information of traditional medicinal knowledge was collected from the local peoples residing in Kulangarsal village. During the course study, it has been seen that the local people having a great idea on the utilization of natural products in their daily life, especially against diseases. The study area is a good resource of medicinal plants, but due to lack of attention, some plants are may lost in future. So steps should be taken to conserve these plants and make valuable utilization of them. Thank you.
Thank you, Mary Steffi. Can you hear me?
Yes, ma'am.
This is wonderful work and really very important, I feel, around the world with the pace of development. A lot of this knowledge, which is very important, will be lost if people like yourself don't go and collect and document the information. So how will you be documenting this? Are you going to think of putting online, or what is your idea?
I'm sorry, ma'am, I can't understand.
How will you share your results? How will you document this, your findings, so that other people can know this and also maybe do the same thing for their communities?
I have collected the plants and document by using the floras available in our college and also online facilities, using online facilities. And it will help me a lot to document these 130 plant species.
Yeah. Will you put your results into any online catalog?
No, ma'am. I'm only use the floras.
Yeah, but will you add your information to existing online resources?
No, ma'am, not yet.
Okay. Do you plan that?
Ma'am. Yeah.
I'm suggesting that you do this and that you encourage others in your communities around India to do the same thing. You could collect so much wonderful information before it's lost. It's really very important this is done. Yeah.
Thank you, ma'am. Thank you for your appreciation.
Can I ask Mary?
Yeah, sir.
Yeah, Dr. Ajit Kengar, Mumbai. Yeah, this is a good work actually. Which flora is used for identification and any authentications done by some experts or by
Flora,
own?
sir, I have used mainly flora of Presidency of Madras, by Gamble.
Yeah,
And
you identified, but
for reference, I have used the flora of Tamil Nadu Carnatic.
yeah, authentications done.
Sorry, sir.
Have you authenticated the species with some taxonomist?
Hello.
Yes. Understood my question?
Hello, sir. Hello.
Yeah, I am asking you.
He is asking that you authenticate with somebody. You authenticate with Josephine ma'am, the taxonomist from our department. That's why he is asking.
Yeah, sir. I'm authenticating our department staff, sir.
Okay.
Hello.
Yes. Okay. Fine. Go ahead.
Yes. Thank you, sir.
Flora ma'am, shall we continue with the technical session?
No, it's time for lunch break. Jenny will announce that.
Flora ma'am?
Yes, Jenny?
Ma'am, you want to thank ma'am?
Okay. Good afternoon, everybody connected here. It gives me an immense pleasure to thank Professor Jennifer and Harikrishna ma'am for accepting our invitation in a short span of time to grace the chair and deliver an invited talk in International E-Conference on recent trends in science and technology. Further, the question raised by her to the paper presenter shows an insight and proof paves the way for innovative think and out-of-box thinking. Her questions raised keen interest among the audience and throws light on advanced research. We are proud to have you on board at this moment, and we are really thankful to you, ma'am. The conference organizers express their sincere thanks to you from the bottom of their hearts. Thank you once again, ma'am, for your blissful presence.
Thank you very much for inviting me. It's a pleasure to meet you all and to listen to your wonderful and beautifully presented talks. Thank you very much.
Thank you, ma'am. Dear participants, we shall now break for lunch and we shall be connecting in the same link after 1 hour. Now it's 1:10. Kindly join the link by 2 o'clock so that we shall have the next session with Professor Jennifer and ma'am. After that session, we will be continuing with the technical session. Okay. After the technical session, we'll be having the valedictory function. So kindly break for lunch and meet here by 2 o'clock. Thank you.
And I'm just going to tell you a little bit first about the university where I'm working. And then I'll go into the background of RNA silencing, especially using double-stranded RNA. And then after the introduction to the topic, I will go into the specific examples that we have used in our university in Malaysia for working with orchids. And this is a part of our orchid biotechnology program. And we've been using double-stranded RNA in plant protection and also in trying to develop novel flowers. So first, a little bit about the University of Malaya. So often I get asked this question, if you are in Malaysia, why isn't it University of Malaysia? Why is it University of Malaya? And that is because the university is older than the country of Malaysia. So the university was established in 1905, and the area where we're situated, the peninsula of Malaya. So that was how the university got its name. So we're here in about halfway down in Kuala Lumpur, just above where Singapore is down there. And Malaysia later on joined with parts of North Borneo, the states of Sabah and Sarawak to become the country of Malaysia. So there are actually universities of Malaysia, but we are older, so we are the University of Malaya. And the research center I'm working in is focuses on biotechnology. So we are all biotechnologists, many of us working on plants, and we're trying to do the biotechnology that can be applied in agriculture. So we have some quite nice facilities, and we just moved some of our labs into this rather new building, which I'm proud of, but we also are using a lot of very old buildings as well because we are an old university. So the slides are taking a little while to change, so bear with me while wait for the slide. I think maybe I have to press it more than once. Oh dear, my slides don't seem to change. I have a backup plan, which is to use a different file. So if you just bear with me, I will open a different file. And I need to make that smaller. Okay, are you seeing this slide as well now?
Yes, ma'am. Yes, ma'am.
Yeah. So this is, I'm going to use instead of PDF because I realized I might have this problem. So the next slide, I'm introducing the concept of RNA. And the reason for that is because I think everybody always thinks of DNA as being the most important molecule. And even it's come into common language. You know, it's in our DNA, it's what makes us who we are, and so on. And of course, the DNA is very important. But the DNA is like the library, it stores all the information. And just like a library, it's not much use if nobody ever reads the books. So the reading of the books is when we make the RNA. And that is the information that is in the DNA and how it is used, especially to make proteins in the cells. So the RNA molecule is essential for coding, decoding, regulation, and expression of genes. So in each cell, which particular proteins are made and when they are made and how much is made is all also regulated by RNA, as well as being encoded in the messenger RNA. So this is very important for function. And that means that if we look at RNA, we can understand function. And if we regulate RNA, we can control function. So the regulation of messenger RNAs can be used to regulate proteins. And proteins are important because they are the enzymes, they are the structures, and they're very important in what the cells look like and how they make up the organism and what the organism is able to do. But the RNAs are also important in regulating how much of the RNA is used to make protein. So if we can...
Excuse me, ma'am.
Yes, hello?
Excuse me, ma'am. Sorry to interrupt, ma'am. Actually, the slides is not moving.
I think I have to close the other file and I have to reshare the other slides. Okay.
Yes, ma'am.
Voice is very clear.
Okay, so now can you see these slides?
Yes, ma'am. Yes, ma'am. It's
Okay,
clear.
so I was just explaining about the structure of DNA and how it is used to make RNA and then how that is used to make proteins. And I was explaining then from this diagram that if we can stop the RNA being used to make proteins, then we can regulate how much protein is made. So the regulation of RNA by proteins and RNAs is important for what the organism is able to do. So then we come to the topic of RNA silencing. So RNA silencing is actually a naturally occurring process. And I want to emphasize that because we're going to use it later in the slides as a biotechnology where we manipulate it. But we didn't invent something. Nature already uses this, and it is used to regulate how much of the RNA is used to make proteins. And we call this post-transcriptional gene silencing when the messenger RNA is regulated. We can actually also use RNA to regulate even how much of the RNA is made, the transcriptional gene silencing, but we are not using this for biotechnology. We are only using the post-transcriptional. So you may have heard of the term RNA interference, or they shorten it to RNAi. And this is actually more commonly used in human or animals for RNA silencing, but RNA silencing, RNA interference, RNAi are really all the same thing, just different terms. So even before we even knew what DNA did and even what RNA did, the first observation of RNA silencing had probably been reported. Now, this I got from a review paper by Sir David Bolcom, who is one of the key figures in RNA silencing in plants. And he wrote this review called RNA Silencing in Plants. And in it, he acknowledges that earlier scientists had actually observed RNA silencing without knowing what it was. And so this is very interesting because they made a scientific observation and they even used the information in science before the mechanisms were understood. So this is a paper from back in 1928, nearly 100 years ago, and you're looking at a plant that has been infected with virus. So I hope you can see that the leaves down here are showing the virus symptoms. So it's important that if the virus is mild enough that it doesn't kill the plant, what will often happen is that the plant not only survives, but the new leaves that emerge have no virus symptoms. And this guy, Wingard, in 1928, noticed this, and then he tried to infect these new leaves with virus to see if they would develop symptoms like the older leaves, and they didn't. So he found that they were protected. What he didn't know was what was the mechanism. And the mechanism actually is inside the plant. The plant recognizes the RNA from the virus as being a foreigner, and it starts to defend itself against the RNA by producing RNA against the virus. So these young leaves are protected by RNA silencing, even though that mechanism was not known till many years later. So from these first observations of RNA silencing, I want to make the first point. Viruses are great targets for RNAi. In fact, that is how plants that survive against viruses protect themselves. They use RNAi. So if plants themselves by nature use RNAi to protect themselves against viruses, we can do that in biotechnology. We can use the same mechanism. The next interesting observation was many years later, quite recently really, 1990, when people were first doing genetic modification of plants. So by this time, we had the technology to introduce new genes into the genome of plants, and all sorts of exciting new experiments could be done. And I like this one because they were working on flowers, and I'm working on orchids, so it's a different flower. This is Petunia. And what this research group wanted to do, they took a flower that has a purple color, and they said, if we add more copies of the gene that makes this purple pigment, it's a gene called chalcone synthase in the flavonoid synthesis pathway. If we add more copies of that gene, we will get more of the enzyme, and we will get the flowers that have more purple, or they are darker in color. So that is what they did. But to their surprise, they didn't get that result. The result they got was quite different. They had variegated flowers, some of them with totally white flowers and some of them with white patches. So when they added more of the enzyme, they got less of the pigment. So there was something they called co-suppression. They didn't really understand how it happened, but they knew that it was actually very useful biotechnology because we could make variegated flowers. So, and the same phenomenon where you added genes, but instead of getting more of the gene product, you got less of it, was seen in other plants and fungi. So from this observation, we can say that co-suppression, and we now know the mechanism is also RNA silencing or RNA interference, can silence plant genes as well, such as the genes that make the plant flower color. So we could use this as well to manipulate the colors and patterns in flowers. So there's two important uses that plants naturally do that we can borrow in biotechnology through RNAi. The next step in the story was interesting. The people thought of a mechanism called antisense RNA for choosing which genes to silence. Now, antisense RNA is also not an invention of people. It's also used in biology. Often antisense RNAs are used as primers, particularly in prokaryotes. Those of you studying bacterial genetics will be familiar with antisense RNAs. So what is an antisense RNA? Well, the DNA is double-stranded, but only one strand is made into messenger RNA. And that single strand is what the ribosomes use to make proteins. If you get the gene by putting a promoter to make the RNA of the other strand, opposite strand to the messenger RNA, or what we'll call the complementary strand, these two strands can hydrogen bond together and make a double-stranded RNA, just like the double-stranded DNA. Now, the double-stranded RNA can't be used by the ribosomes. So when we put an antisense in to make a double-stranded RNA, we can stop the protein being made. So we can trigger our gene silencing. And because the sequence is specific, we know which gene we want to silence, we can put in an antisense RNA and switch off just that gene. So it was a very precise technology. And this antisense RNA technique then can be used to lower the amount of protein based on the RNA sequence. And of course, the more time goes past, the more plants we have the DNA sequences for, and the more genes we know the sequence of, then the more we can use this type of technology. So in fact, the RNA, antisense RNA was the method used for the very first approved RNAi crop. And in fact, it was the very first approved genetically modified food, which was the flavor saver tomato. I know that many young people here, you probably never heard of it, or maybe you read about it if you're studying biotech. It was only in the market for about 2 years, and it was sold in the USA, but also in Europe. So what happens here is they put in the antisense to a gene called polygalacturonidase, which makes the enzyme that makes the cell wall soften as the fruit ripens. So by making less of that softening enzyme, the walls and the skin of the tomato was firmer, and so it didn't spoil as quickly. So this was very good. It protected the tomatoes from bruising and gave them a longer shelf life. But the story goes, around that time, people started to get worried about genetic modification, and it was all tied up with the story of Monsanto and then trying to sell people their particular seeds and herbicides. And eventually they took it out of the market because public didn't want to buy it for various reasons. It isn't unsafe, and the reasons were somewhat confused, but it does illustrate how important it is to communicate with the public and explain what you're doing, and also to respect their fears and wishes. The next genetically modified plant in the market was actually papaya that was resistant to papaya ring spot virus. And this is in Hawaii, also in USA. So here the papaya has antisense to the coat protein of the papaya ring spot virus. So when we do that, the virus can't make its coat protein because the antisense binds to the sense, the coat protein cannot be made, and the virus cannot propagate in the plant. So the plant is protected against the virus, and the normal plant is not protected. You can see all the virus symptoms. So this showed a very powerful use of antisense or RNA silencing for the first biotech crops. So what was the mechanism? Well, you might think I've told you the mechanism, that the RNA in 2 strands can't be translated by the ribosomes. That was only part of the story. The true story came out later. And actually there were 2 groups, well, many groups, but these 2 groups are the most famous. The first group I'm mentioning are the people who won the Nobel Prize for the discovery of the RNA interference mechanism. But they weren't working in plants. They were working in the little nematode worm C. elegans. They were doing antisense experiments, but one of their controls was to put in double-stranded RNA. So they put in the sense RNA, they did another experiment with the antisense, and they did one with the double-stranded RNA. They thought this wouldn't have any effect on gene silencing. But in fact, the double-stranded RNA was much, much stronger at gene silencing than the antisense RNA. And the reason is that double-stranded RNA is recognized by the plant cells like a virus as being something foreign. It uses RNase enzymes, DISA, to cut it into short pieces. This one strand of that recruits some other proteins to form what is known as the RNA-induced silencing complex, and it will bind to the matching messenger RNA, the complementary one, and another RNA is called Argonaut, will chop it up into pieces, and so it can't be made into proteins. At this stage where it's cut into these short RNAs, they amplify the signal. So that is why the silencing is very strong. Each of these goes and recruits more of these complexes and silences. So it's more strong than just blocking the ribosomes. It actually recruits another pathway that cuts up the RNA. So their work was published in 1998 and they won the Nobel Prize. But around the same time, and in fact published earlier, David Borkum's group I mentioned earlier had shown that in plants, the RNA trigger is responsible for the virus resistance that I showed you earlier in the experiment by Wingard, and also the homology-dependent gene silencing that we saw in petunias. But because the work is in plants and there is only a Nobel Prize for physiology and medicine, and this wasn't physiology and medicine, this group didn't win the Nobel Prize. But don't worry, they did win other prizes and they also patented the technology first. So they weren't losers in any way, they just didn't get a Nobel Prize. So Nobel Prizes aren't always the best result. So from this, we know that it's a natural mechanism in plants where if there's a virus infection or a double-stranded RNA, in fact, plants use little genes called microRNAs that fold one RNA into a double-stranded RNA hairpin to regulate their own genes. So it's naturally used in gene regulation and silencing inside the plants, as well as defense against viruses. These are cut into short RNAs that trigger the RNA silencing. So once we know this mechanism, we can use it to trigger the silencing. And because we know it binds to the complementary sequence, if we know the sequence of the gene we want to silence, we can specifically silence that gene. So this allows us to silence endogenous genes in the plants, for example, the flower color, which allows us to change the phenotype. And it allows us to attack against viruses and other pests and pathogens. So not just viruses, it can be used against insects as well. So this discovery, antisense RNA, and then later on, the double-stranded RNA led to lots of commercial use of this in crops. So I started by telling you about the flavor saver tomato and the papaya resistant to ring spot virus. There were lots of other virus-resistant crops, 2 different virus lines in potato, capsicum, tomato, beans. And then the next set were not against viruses, but against other traits. So low acrylamide in potato, a non-browning apple, to enhance nutrient content, increasing antioxidants in tomato, to reduce the caffeine in coffee, to reduce the allergenicity in peanuts, and even to make a tearless onion. How many of you have cried when cutting onions? This is an enzyme, lacrimotor factor, and it's synthesized by this enzyme. If we silence this enzyme in onions, somebody has done this and made an onion that won't make you cry. So it's amazing what we can do with biotechnology. So there we had a whole list of examples I just gave you, but all of them are genetically modified. What you do is you introduce new sequences into the DNA of the plants and make the plant make the double-stranded RNA. Now, when we do this, we have a genetically modified plant or a genetically modified organism. And there are some concerns with that. First of all, they're quite expensive and take a long time to develop. We have to have a transformation system to introduce the new DNA, and usually we will do that into somatic embryos. So we have to have a somatic embryo and regeneration system for the plant that we want to transform. And some plants are quite difficult to do that. In fact, I think till today, nobody has managed to do it with coconut, for example. We just can't regenerate the plants. We could do the transformation, but we can't regenerate genetically modified coconut, for example. And last but not least, there are a lot of public who don't want to eat GMO for various reasons. and they're entitled to those opinions. So we have to worry about whether this is always the best, or we can look at an alternative. So what if instead of making the plant making the silencing RNA molecule, we could trigger that RNA silencing just by applying double-stranded RNA onto the plant leaves? So the question was, is it possible to use exogenous RNA? So endogenous would mean it's made inside the plant by the plant, but exogenous, we make it outside the plant and we just put the RNA on the plant to trigger gene silencing. And I think by now you probably guessed the answer is yes, it's possible. And this group from Spain were the first to demonstrate that in 2003. So they use crude extracts of bacterially expressed double-stranded RNA to protect plants against virus infections. So HT115 is the name of the E. coli strain. And if you just have the E. coli without making any double-stranded RNA, and you put that on the leaf and then you infect with the virus, then you get lots of virus symptoms. The same bacterial strain expressing a double-stranded RNA, paint that on the leaf, and now no symptoms. It protected against the virus. So the double-stranded RNA from the bacteria put on the leaf goes into the leaf and triggers the RNA silencing against the virus sequence and was able to protect. Now we don't have to genetically modify the plant. Exogenous double-stranded RNA can protect plants against viruses. This means we can do it very quickly and very inexpensively. So how is RNAi being used in agriculture? Well, I mentioned the genetically modified plants. We can use it for resistance, to prevent spoilage, for changing nutritional value, or reducing specific compounds like the low caffeine coffee. And as a double-stranded RNA applied to the leaves or other parts of the plants, we can use it to protect the crop against virus, as we just saw, to improve the efficiency of other crop protection methods. So maybe not just on its own, but together with other chemicals. So we could use less of those chemicals, and to prevent infestation by other pests. So here they only mention crop protection, but actually what's not mentioned, this is a slide I have borrowed from Crop Life with their permission. You can actually also use it to alter the plant genes, not just to protect the crop. So you can also change the phenotype like the flowers that I mentioned. So this mechanism is nucleotide specific. That means we have to know the sequence of the RNA that we want to silence. We need to trigger it by using double-stranded RNA. And we have two choices. We could use two strands that are stuck together, or one strand that is able to form a hairpin. Either of these will trigger that. The other thing that's very important to know is that this is post-transcriptional. It occurs in the cytoplasm. So if we treat the plant with RNA, the RNA is taken into the cell. It never enters the nucleus. So this is not going to genetically modify our plant. It's just going to trigger the RNA silencing. And it is not inherited. It is only a transient effect. So it will disappear in time. So there are some uses for which that is the good thing, and some uses for which that may be not the good thing. So sometimes we do want a genetically modified plant, and other times we can use the exogenous double-stranded RNA. I just put as a note here that I did mention there are endogenous pathways that do affect the gene silencing in the nucleus. They alter the DNA, but they originate from the nucleus and they can never be triggered by exogenous RNA. So this method would never change the DNA in the nucleus. If we want to change the DNA in the nucleus, then we have to do a genetic modification to do that type of silencing. So this exogenous RNA will always be transient and will never change the genetics of the plant. So now, knowing all this, we were very excited to see how we can use this technology for orchids. Orchids are a beautiful flower. I think you have many beautiful varieties in India, just as we do in Malaysia. And they're very popular. There's always a demand for new varieties. We want high quality, but they're quite slow growing, and breeding is a slow process. People often use tissue culture to propagate good quality and high numbers of clonal plants. And this allows us to do genetic modification. But even so, it's very expensive and very time consuming to do genetic modification. And also there are some regulatory hurdles. So our motivation was, can we use our double-stranded RNA without doing genetic modification as a biotech for the orchids? And orchids are highly suitable for this type of technology because breeding is so slow and expensive. And if we look at a case like a virus, it is transmitted by contact in this case. The main virus, the major virus infecting viruses is called Cymbidium mosaic virus. It affects over 50 genera of orchids. And it doesn't have any insect vector. It's only transmitted by contact. So the only time the plants are likely to get infected is when people are handling them. So this short window is very suitable for a transient system. And there's a potential also, as well as protecting against the viruses, for using this technique to change the flowers by painting the flowers with RNAi. So since RNA silencing is used to remove or reduce specific proteins, it includes those in viruses, we can use short double-stranded RNA by direct application. And I'm going to give you two examples from our research group, one for virus control and another one for novel flowers. So let's start with the virus. Here's Cymbidium mosaic virus on Cattleya. A healthy flower should look like this, and I think you can agree that this one would not be suitable for sale in the market. And you usually see the symptoms on the leaves first. So what happens when an orchid grower finds this is that they really will just have to throw the plant away. It's no good trying to treat the plant at this stage. So you have to throw them away, which is a loss of income. And because it's highly transmissible, it can easily spread from one plant to another through handling. But what orchid growers often do is they propagate the plants by tissue culture. So they have a fresh, clean set of materials coming out from tissue culture. Now, to prevent them being infected when they're being handled, that would be the perfect time to treat with double-stranded RNA to protect them against the viruses. So this was our experimental design. We would treat the plants with double-stranded RNA against the coat protein gene of the Cymbidium mosaic virus. This will be on the leaves, and it will trigger the RNA silencing. The plants will make the single-stranded RNA that matches the coat protein. This is a tobomovirus, so it has an RNA genome inside the coat protein here. The virus can't assemble if it can't make the coat protein. So if we target the coat protein RNA and no coat protein is made, then no more virus in the plant and the plant will not have symptoms. How do we make our RNA? So we use the same method that the group in Spain had used. We use an E. coli system. We clone 250 base pairs of the coat protein cDNA sequence into two vectors. One would make the sense strand, and the other would make the antisense strand. And the reason was that this was the first time we were doing this kind of research, and we wanted to check what was the effect of silencing with sense or antisense or double-stranded RNA. And by making them in different bacteria, we could do all the comparisons. So we grow the strain, and then we induce the production of RNA from a T7 promoter using IPTG, and then we make just a crude extract. So we have one with a single-stranded sense RNA. Now we mixed it with the virus and treated one set of plants. We had another with the antisense single-stranded RNA. We mixed that with virus and infected a second set of plants. And then we mixed the sense and antisense together and allowed them to anneal to form double-stranded RNA. And then we mixed that with the virus and used that to treat the plants. So it takes a long time to grow the plants. What we did, and because people often ask us, like, which orchid did you use? We simply went to the nursery where they were selling tissue cultured plants and said, what have you got in a set of 30 bottles? Because we need 30 bottles for this experiment. And they had a Cattleya hybrid. So if you're interested in what orchid we used, it was a Cattleya hybrid, and this was the name. We used 6 plants in each of the groups, and then we treated them took them out of the culture vessels, treated them with the double-stranded RNA and potted them, and left them for 30 days. And then we used PCR to detect whether the virus is present or not. So this is the result of the PCR. So to explain this, we have the 6 different groups. This group were just infected with virus. And this high bar here shows you there's a lot of the virus co-protein present, which means these plants were well infected with virus and they had plenty of virus. This next group were infected with virus, but also treated with a single-stranded sense RNA. And you could see even the sense RNA gave them some protection. They have less of the virus co-protein, so they have less infection. We can also see this in the symptoms. The other group here were treated with virus and the antisense strand. And now you see that the antisense strand is a little bit better than the sense strand at protecting them. What about when we use the double-stranded RNA? Okay, with double-stranded RNA, we get what is in fact like a negative. We have normalized this to the plants that were just treated with double-stranded RNA and not infected. So we made that 0. So sometimes you get a slightly below 0, but this is effectively 0 presence of virus, even though they were infected with virus. And this group was not treated at all. Okay. So what we can say is with the double-stranded RNA against the virus co-protein, we effectively had no virus present. We couldn't see it. And even the sense and antisense are able to give some protection against the virus. So remember, this is not a genetically modified plant. We have just treated the plant with the RNA made in the bacteria, and it's able to protect the plant. So we have patented that and we won a few awards. So we're quite excited, but we haven't commercialized it yet. And I've got another talk on why that is the problem. Commercializing, as you can see, I'm interested in that from the questions I asked some of your speakers today, is a very difficult thing to do. But we hope we will get to a commercial point. So we can use RNA silencing to remove specific proteins like those expressed from viruses. And we had shown that we could do that. So the next thing we wanted to know is, could we use it to silence genes of the orchid flower itself? And could we change the flowers if we use this double-stranded RNA? So again, not doing genetic modification. Can we simply treat with RNA we've made in bacteria and get a change in the phenotype? So then we had to decide what genes to use. Remember, it is sequence specific, so you have to know the sequence of the gene you want to use. So what we did, we targeted some transcription factors, and these are proteins that regulate other genes. And we chose MIB family because those are involved in colors, in anthocyanin synthesis, in some dendrobiums and other plants, and flavonoid synthesis, and they're also involved in cell shape. But it's a very big family of genes. So we had to figure out which particular gene sequence we're going to use. You can see there are a lot. So we took the genome sequence of Dendrobium catenatum. We didn't do the genome sequencing. This is published and in a database. And we analyzed that genome sequence to identify all of the transcription factors in the MIB family in that genome, and there are 63 of them. That's a lot, and we don't have the money to test 63 genes. We said maybe we can do 2 or 3 genes, so we're going to have to pick some. So what we did, we aligned up with other sequences from Arabidopsis and various other plant species where those sequences had been associated with functions. So for example, this group in other plants have been shown to control the shape of the petal cells. And this group was shown to control flavonoids, and this also pigments, and this anthocyanins. So we picked genes from these groups that we knew were homologous to those in other plants that had functions in flower shape and flower color. The next thing we had to do was to actually, I know many of you are botanists, so you will appreciate this. If you're going to do a characterization of changes, you have to first know what is normal. So we worked together with Dr. Trudy Schwartzacker from University of Leicester, who's a very good botanist. None of us are actually botany trained. to do all the characterization of the flowers. So what does a normal flower look like? So we would be able to see if our double-stranded RNA had made any changes. Then we did the experiment like before. We've identified the genes that are involved during flower development. We're going to make double-stranded RNA to those genes, again, using the bacterial system. And then we're going to treat immature flower buds and watch them develop into flowers. So our double-stranded RNA should be finding those transcription factor messenger RNAs and reducing them so that the transcription factors are not made. And then hopefully we get to change the shape or color of the flowers. That was the plan. Okay, so the first thing we needed to know, what the first gene, it's from a dendrobium hybrid, and we called it MIB1 because it was the first one that we worked with. And when you do that, you just get to name it what you like. So we called it MIB1. And we first of all made sure that, is that actually even a gene that's important in flowering? So what we did was we measured the normal level of messenger RNA through the development of the flower. And we saw, yes, indeed, it increases as the flower develops. So it must be doing something during flowering. So if we can silence it, maybe we will see some difference in the flower. So again, we cloned it into a bacterial expression vector, only this time, instead of making sense and antisense in two different vectors, we just made them together. We already know that double-stranded is what we want, so we didn't make separate sense and antisense, we just made double-stranded. We used that to make crude lysates from the bacteria and to paint it onto the flower buds as they developed. So we have a control that doesn't have the double-stranded RNA, and one which does have the double-stranded RNA that will hopefully reduce the level of the MIB1. We watch the flowers develop and we see what happens over 30 days. So I'm just showing you 3 stages, stage 5, stage 6, stage 7. And in each case, the one on the left is not treated and the one on the right is treated with double-stranded RNA. So if we look at the level of the messenger RNA for the MIB1, in the blue shows the untreated and the red shows the treated. So this was good. We have reduced the amount of messenger RNA by using our double-stranded RNA. But when we look at the buds, we really cannot see any difference in shape or color. And the student doing this work was really disappointed at this point. And we said, well, we know we've done something because the RNA has reduced. Maybe we need to look really closely. So then we did some electron microscopy to actually look really closely at the petals. And what we found was, this is what the normal shapes of different parts of the petal flower epidermis is like. Then we could compare, I'm going to go through that one, and compare after the treatment. And what we found was that for the sepals and the petals, we could not see any differences, but on the lip, this is what the normal epidermis cells on the lip look like. They're quite pointy and conical, but after we treated them with a double-stranded RNA, they became much flatter. And if we look from the side, you can see them pointy here and then more dome-shaped here. So it wasn't the big result we were hoping for, but it was enough to get a nice publication and also to prove that we had silenced an endogenous gene in the flower through the treatment. So I managed to get a bit more funding and some new students, and I said, let's try some other genes because we do believe this is going to work. So we called the next ones MIB3, MIB4, and MIB5. And this time, I don't know if you remember from the petunia, the chalcone synthase, it's not a transcription factor, but it's one of the genes in the flower color pathway. We said, let's also use double-stranded RNA against chalcone synthase and see if that also changes the color of the flower. So here, what I'm showing you is the expression during flower development from stages 1 to 5 and sepals, petals, and lips of the open flower for each of these genes. So they all seem to be related to flower development. Then we cloned the genes into that vector to make double-stranded RNA and treated the flowers. So here I'm showing you now the buds during flower development and the open flower. On the top row are the ones that have been treated with double-stranded RNA to MIB3. The next one is double-stranded RNA to MIB4. The next one is double-stranded RNA to chalcone synthase, and this one is empty vector. So this is what the normal flower will look like, and it's quite a strong purple. So I hope you can see now that for all of the 3 different treatments, we have managed to change the flower color. We have reduced the amount of pigment in those flowers. And also, maybe you notice that the shapes of the buds themselves have also changed, and the shape of the sepal here and the lip here have changed. So when we go on, I was telling my student, this is all very nice, and I can tell you it's a different color, but how do we quantify that? So he went away and found a way to quantify the color using an algorithm that measures 3 different ranges, light to dark, red to green, yellow to blue. And then we put this into a number system, and then we can do a comparison between the control and the treated for each of the different panels and tissues. To cut a long story short, so the delta E is the difference, the change. We saw the biggest change in the petals for the MIB3 treatment and in the sepals for the MIB4 treatment. But we also see a change in the chalcone synthase as well. So strangely, the MIBs have a stronger effect than silencing the chalcone synthase. We can also quantify that as a color change in a bar chart. So again, this is just showing the figures from the table, just for the petals, sepals, and lips of the open flower. And we can see that MIB3 has the biggest change on the petal and MIB4 on the sepal. So we changed the color. What about the biochemistry? So we also measure the anthocyanin content in the flowers. And we also see that that has been very much reduced. So the blue bars are the MIB3, the orange bars are the MIB4, and the gray bars are the chalcone synthase. The yellow bars are the untreated. So we can see that whichever treatment we give, at every stage, we reduce the anthocyanin content. So now I come to the conclusions. Is double-stranded RNA a good biotechnology for orchids? I would say it's promising. We can use it to protect against the virus very effectively. And other people have used it for control against other pests and diseases. So there's more possibilities there. We also used it to show that we could change the transcript level of flowers of various genes. So first thing is we could determine what those genes do by looking at these changed phenotypes, or what they call reverse genetics. You silence the gene and you see how the genotype changes, how the phenotype changes, and then you can say that is what is the role of this gene. And of course then is the potential for flower modification. Again, we only have to paint the flowers with the RNA. We only make the RNA in bacteria. So it's quite a cheap technology that could be interesting to use. Rapid and relatively inexpensive, no genetic transformation involved. So it's also faster for functional studies as well. So yes, we are going on to look at more genes, and we're still trying to find the one that will have some wow factor, but we've already managed to change the shape and color of the flowers. So we're quite pleased with that. So how do you apply it? In our experiments at first, we have just been painting it on, but lots of people are looking into using this technology developed as a spray. You don't want to go and paint in a whole field of plants. So how will you do that? You'll have to have some mechanism of spraying it onto the plants. And this particularly against viruses and also against pests like insects. All the big ag bio companies like Monsanto, Bayer, Syngenta have patents. So if you look in the patent databases for patents on RNA sprays, you will see lots of people are very excited about this area. What about the stability? RNA isn't a very stable molecule. How often do we have to spray, and how do we make sure it sticks to the plants and stays in the field? Lots of people are working on that too. And one I will mention, because she's an Indian scientist who is working in Australia, Nina Mita, has developed something called bioclay, a polymer that you can mix with the RNA to make it stick onto the plants. And they're using that to help use against tomato viruses. It has potential for use in novel phenotypes, and it's perceived it will be more acceptable because there's no GMO released. But when we come to the GMO, we also have to look at the guidelines. I've also been working together with other scientists in India, and we've been looking at your biosafety guidelines and the Malaysian biosafety guidelines, which are very similar. And at the moment, it's not really clear how the double-stranded RNAs will be regulated. Australia, where Nina Mita works, already have decided that this is not a genetically modified organism. It is a pesticide, so it will be regulated as a pesticide. And the same thing has already been decided in New Zealand and also in USA and also in Canada. So several countries are really getting ready to commercialize this technology. And I think it could be a very important one for countries like India and Malaysia too. So these are some of the headlines from papers in 2017, and now 2021, just in February, spraying crops for game changer, modify plants without changing DNA, tunable crops, transient reprogramming of crops for agronomic performance. So not only for controlling pests, but also for agronomic traits and also important phenotypes like color. So I hope you'll agree, this is a cutting edge, exciting technology, not yet commercialized, but very soon to be, I am sure. I have to thank all of my funders. First of all, of course, the conference organizers, thank you again for giving me this opportunity to be with you today. We had funding from Ministry of Education, Malaysia, in various grants. This was several small grants that we put together to do different pieces of the work. My collaborators, I have a wonderful first postdoc, and now she's a senior lecturer with us, Purabi Mazumdar, who's actually from Assam, Guwahati IIT originally. My colleague, Prof. Yasmin in University of Malaya, and Dr. Trudy Schwarzacker in the University of Leicester. And these three very hardworking master students, Teng Wei, Su Yi, and currently writing up the work on the MIB is Muhammad Ashraf. We have actually published quite a lot of papers in this area, and we hope with Ashraf's work to publish some more. So with that, I thank you. And I encourage you to look up other work that's going on in Sabah, because lots of people are doing other exciting things. We can be found on Facebook and Twitter, and also at the University of Malaya website. Thank you very much.
Thank you, ma'am, for your excellent, highly informative and wonderful presentation, Dr. Ann. And that one doubt I want to, what's the scope of this antisense technology in treating genetically disorders in human beings?
Yes, so I think the very first case of this was actually now many years ago. I think even back before the year 2000, they were trying to use this type of technology for treating eye diseases. Macular degeneration in the eyes was the very first clinical trials. Two different clinical trials were tested on elderly human patients, so went to human clinical trials. It had promising early results, but then they didn't find it very reproducible. And I think some of the problems are with the stability of the RNA. But if you look at the recent vaccines now, people are using RNA vaccines against COVID, but they're also talking about developing them against cancer. So I think they're starting to work out some of the issues of stability for clinical work. And so, yes, I think you will start to see it used against human diseases as well, especially where a transient effect is useful. So for all of these, including the vaccines, it's only a transient effect. But where a transient effect is suitable for the disease treatment, I think it has a lot of potential.
Ma'am, nice. Thank you, ma'am. One more question I have, ma'am. How will you relate for our students the epigenetic action and RNA silencing? Epigenetic events.
The epigenetic effect?
And RNA silencing. Is there any relation? because this most of the RNA, double-stranded RNA, particularly acting like epigenetic action.
Okay.
Either at the transcriptional level or at translational level, as you say. Is there any natural relation between this epigenetic action and RNA silencing?
Yes, there's another pathway in the nucleus. So what I have been describing is the pathway in the cytoplasm. So whenever we apply RNA from outside of the nucleus or outside of the cell, it will not have an epigenetic effect. It needs to be in the nucleus to have the epigenetic effect. So the way to introduce that is either you have to do genetic transformation, or possibly if there are viruses that go into the nucleus, this would be a way that you could introduce those effects. Now, that is a lot more dangerous for clinical application, because it's going to actually maybe change the DNA and have a long-term inherited effect. But there are a lot of people interested to see how it might be still useful for gene therapy, for example. So I'm not in the medical area, but I believe there's a lot of interest in that. And probably they will use some kind of viral delivery systems to get it into the nucleus, and then you can do the modification. So what normally happens inside cells naturally that use what they call the siRNAs that cause these epigenetic effects is that they trigger DNA methylation. So these changes in methylation will affect whether the genes can be transcribed. So that's why they call this transcriptional gene silencing. They prevent RNAs being made. Whereas what I've been talking about today is the post-transcriptional. So the RNA has already been made as in the cytoplasm, and you're stopping it being made into the protein. So this is only a transient effect. But there's definitely a potential for doing the transcriptional gene silencing as well. It's a little bit more complicated and a little bit more of concern because of the permanent genetic change.
Thank you, ma'am, for your explanation.
And I have one doubt. Hello, ma'am.
Hello, yes.
Ma'am, you are talking about the second part of your work, no? Not the transient expression, that is controlling the virus. The other part, the color you were changing, no? The orchid flower color. In that you were creating the plasmid vector and then inducing, like rDNA you are creating and then making the plant genome, accepting
no transformation. No, the flower color
just like it's a medicinal.
Yeah, the flower color also just treating with the double-stranded RNA. No genetic transformation. Yeah.
So you have to continuously treat the plant to keep the flower color.
Only during the development. So while the flower is developing, you apply the RNA. Once the flower has developed, it has already changed the color. Because the
okay, that's also transient.
Yes, it's transient. Yes.
That is also a transient expression. Oh, I thought you changed, like knockout, you changed the genomic part. No. Okay, ma'am.
We want to explore the transient. I think it's not. I always say this about the technology. It's not instead of. It's as well as. So I think when people are looking at crop improvement, it's not either you must do GM or you mustn't do GM. I think you need to look at what is the effect that you want. Sometimes GM will be the best way, and sometimes the transient will be the best way. And sometimes maybe you have both GM and transient being used. So I think it's more that it's not you have to do this or you have to do that. You can use whichever technology is suitable to achieve your targets. And I think this is the best way that people have to think. So consider what are the options that are going to be better for what is the end result that you want. So for research, if we just wanted to check lots of transcription factors and we had to do genetic modification for everyone, we just couldn't get enough money to do that kind of research. But if we can use a transient system, then maybe we can study more genes. So it will allow us to work a bit faster and use our resources better. But maybe after that, we still want to make the genetically modified plant once we know which gene we want to use. I hope that answers the question.
Yeah.
Yeah.
Yeah, ma'am, I have one more doubt. When you make the recombinant plasmid for the bacterial transfection, how do you make both the strands it get transcribed? Promoter is there in the both the strands. You engineer
Yes,
it
actually,
with the promoter at the both the end.
So this is actually, we didn't make this vector. It's already, you can, I think you can buy this one, PL440. So there's a T7 promoter here. There's another one here. So this strand this way will be made into one strand of RNA, and this strand here will be made into the other strand of RNA. So just put your piece of DNA in there and two strands will be made, and they will anneal and form your double-stranded RNA. So it's very easy. Yeah.
Okay. Okay, PL4440 is the vector, right?
Yes. PL4440.
4440.
Yeah. I think if you look for our paper somewhere here, I've got the paper. This paper, I know it's a bit small, double-stranded silencing. This paper will give you the information on the vector. Yeah.
Thank you so much, ma'am. It's a great book anyway. Thank you, ma'am.
Thank you.
Jenny, shall we wind up the session?
Yes, thank you so
question.
much for all the interesting questions, and
Yes.
I'm glad that you enjoyed the talk. Thank you. So
Jenny, can Pauline,
Yes, ma'am.
Jennifer? Oh, okay.
Yes,
Shall
ma'am.
we
Yes.
continue the next session with the presence of Dr. Ann? Shall we ask the students to present?
Yes, please.
Yes, ma'am. We shall resume the meeting session.
Can you be here? Can you act as the chairperson again for our presentation?
Yes, I can. Yeah.
Yeah. Thank you so much for your patience
You're
or
welcome.
listening of young budding scientists. Jenny, shall we start? Pauline, Jennifer, shall we start?
Yes, ma'am. Yes, ma'am. We shall, ma'am. So, dear participants, we are now resuming the technical session which we have left in the previous session. So, participants, please be ready. Daffodil, ma'am, shall I continue?
Hello, Dad.
Yes, ma'am.
Invite the first presenter now.
Dr. Sandana Mari, is she there?
If someone is not, please invite the next person to do.
Ma'am, she is not here. Shall we invite Selvanandi?
Oh, okay, ma'am. Okay. Selvanandi?
Yes, ma'am.
Are you ready to present your paper?
Yes, ma'am. I'm ready.
Okay, then
Yes, ma'am. I'm
share
ready.
your.
Okay, ma'am.
And the next presenter is Ms. Shanta. I request Ms. Shanta.
Yes, ma'am. Is this visible?
No, it is just sharing. It's not visible yet.
Oh, just a second. Ma'am, is it visible now?
Yes.
Silvanandi, you can start.
Okay. Okay.
Just open your
Good
presentation.
afternoon, everyone connected here.
Your presentation is not seen.
Ma'am, is it visible or not?
No, your mobile screen is visible, but not the presentation. Yes, now it is.
Oh. Ma'am, is it visible now?
I don't know why it is rotating. It has been
Excuse me.
stopped.
Oh. I hope it is visible now.
It is in the wrong direction.
But it is in reverse on. Okay.
Shall I start, ma'am?
Yes, yes, you can.
Okay. Okay. First of all, I thank the organizers for allowing me to present my research work in this international conference. Metabolite profiling, a way to guarantee the quality of mushrooms cultivated in agro. This is my presentation topic. Malnutrition and inefficient agricultural waste management are major problems faced with most of the growing countries. Continuous
Excuse me,
vegetable and
Selvanandi.
meat price
Excuse me.
to
Selvanandi,
yes, ma'am.
your slide
Yes,
is not
ma'am.
moving. It's showing the first slide only.
But have ma'am.
Oh, it's not moving. Your
Visible
first
now?
slide is only, yes. But it is, yes, you can.
I think there is some network issue.
Selvanandi?
She has joined just now only, ma'am. She left the meeting. Now
She has joined back.
Hello, excuse me, ma'am.
Yes,
Hello.
Selvanandi?
Hello, ma'am. Ma'am, can you hear me?
Yes, I can.
Hello.
Selvanandi?
Ma'am, sorry for the interruption, ma'am. There is a big network issue, ma'am. Hello. Hello.
Yes, Selvanandi?
Ma'am, please allow the next person, ma'am. I will rectify the problem and join soon, ma'am. Hello, ma'am.
Okay, okay.
Okay, Selvanandi.
Okay. Sorry for the interruption, ma'am. Sorry.
Then now I call upon Mrs. Shanta to present her paper. Shanta?
Selvanandi, can you stop screening?
Are you able to see this presentation now?
Selvanandi, can you stop presenting your screen? Shanta ma'am, you can start with your presentation.
Yes, ma'am. Are you able to see this presentation, ma'am?
Yes, ma'am, we can.
So good afternoon to everyone. Today I am going to present on the topic identification and quantification of potential bioactive compounds with Champia compressor. Introduction. Seaweeds are macroscopic algae growing in the sea. The total resources of seaweed in India are about
Excuse me, ma'am. The slide isn't moving, ma'am. Thank you.
Excuse me, ma'am. Start slideshow, ma'am.
Now, ma'am.
Ma'am? Shanta ma'am?
Yes, ma'am.
On the top of the screen, you can find slideshow. Like first is home, then insert, design, animation, slideshow. Click on slideshow, ma'am.
Okay.
Ma'am, there you have to select from beginning.
Okay, ma'am. Okay. Hello.
Yes, ma'am, you can start.
Yes, ma'am. Okay. Seaweed contains natural bioactive compounds such as steroids, tannins, alkaloids. These bioactive compounds have curative properties for tuberculosis and even tumors. Here I have chosen three red seaweed, Champia compressa, because most abundant in Mandavam region. It has more activity also. From Mandavam coastal area, Ramanathapuram methodology. First, the standard procedure were followed by the following experiment. The first one, the phytochemical analysis were done by for 5 different extractions: chloroform, ethyl acetate, hexane, aqua. Quantity to quantify the phenol, alkaloids, turbinoids, steroids by using same 5 different extraction method, and then methanol extraction was subjected in GCMS analysis and then FTR analysis. Results. This is phytochemical analysis. Tested by 5 different solvents, same solvent, the chloroform, hexane, ethyl acetate, methanol, and phytochemicals were tested during the experiment. Out of 10 phytochemicals, 7 phytochemical constituents were present in all the extraction. Anthraquinones was absent in all the extracts. Various phenol, turbinoids, saponins, steroids were present in all the extracts. Soon as the quantity analysis was to quantify the phenol, alkaloids, turbinoids, and steroids. Use 8 different solvents. The first one is the phenol. Phenol content was found to be higher range in aqueous extract, and then lower value was found to be hexane extract. And the next one is the alkaloid. The alkaloid content was found to be highest in ethyl acetate, and lowest was found to be aqueous extract. Next, and steroid and turbinoids. The highest steroid and turbinoid content was observed in chloroform extract and then methanol extract. The lowest steroid and the turbinoid, hexane and aqueous extract. And the next one, FTAR, it showed in this graph. There are 30 major peaks obtained from the FT analysis that represent the functional groups such as, these are the functional group. So mostly carboxylic acid, amine salt, and then isothiocyanate, nitro compound are present. The higher peak at 3278.7 due to the OH stretch of the carboxylic acid. And then next, amine salt have NH stretch of the B 200930. And then GCMS analysis. GCMS analysis, methanol extracts of Champia showed there are 6 compounds. This fucosterol, catacozan, squat were performed predominant in terms of the percentage. These compounds have been reported to possess certain biological actions such as anti-inflammatory, antimicrobial, antioxidant, antidiabetic, and cytotoxicity also. Okay, these major group compounds in the biological activities are given in the table. Selected the seaweed sample champion qualitative and quantitative assay. It was found to contain bioactive compounds. They are found to have antimicrobial, and tumor activity. FTR revealed the occurrence of potential functional group. GCMS reported show the presence of number of bioactive compounds which possess antibacterial, anti-diabetic activity also. Based on the result, it concluded further in vivo studies are necessary to confirm the pharmaceutical activity.
Jennifer ma'am, if you have any queries, please ask.
I don't think I have any specific question. It's just a comment maybe that I think it's a really good idea. Yeah, it's a good idea to look at this. Dr. Ajit, please go ahead.
Thank you.
Ma'am, sorry for the interruptions. You can continue, ma'am. Sorry.
I think some confusion. I say I don't have question. Maybe just a comment that it's really important to look at the seaweeds. I'm happy today we have several cases where people are looking and in all sorts of resources, from under the water to on land to waste products. I think this is really very good that everyone is maximizing the biological resources around us. So excellent. Thank you.
Daffodil ma'am, can we call the next participant?
Yes, ma'am. Selvanandi, are you ready?
No, ma'am, I need few more minutes, ma'am. I'm fixing the issue, ma'am. I'm connecting my laptop. I need 2 more minutes, ma'am. Please allow the next participants, ma'am.
Okay, ma'am. Then Ashley, now I would like to call upon Ashley Bemisha to present her paper. So Ashley Bemisha.
Yes, ma'am.
And the next presenter is Libika, Miss Libika. So Ashley Bemisha, you can share your screen.
Okay, ma'am. My PPT is visible and not visible, ma'am.
It's not showing much, it's just a white background is seen.
Good morning, ma'am. My topic is synthesis of plant extract mediated metal nanoparticle and their UV visible spectrometer and catalyzation. Introduction. Due to repeat installation or organization or environment in undergoing great damage and a few large amount of hazardous and unwanted chemicals, gases or substances are released, and so now it is needed to learn about the secrets that are present in the nature and is protect, which leads to the growth of advancement in the synthesis process of nanoparticles. The biological molecules undergo highly controlled assembly for making them suitable for the metal nanoparticle synthesis, which was founded in renewable and eco-friendly. The synthesis of metal and semiconductor nanoparticle is a vast area of research due to its potential application, which was implemented in the development of novel technologies. In the present study of synthesis approaches of the copper, cobalt, and manganese oxide nanoparticle using plant extract of Acalypha indica, Clitoria terminata, Mucus aspera, and Pedalium rex. Materials and methods. These plants are selected from synthesis of metal nanoparticles. The plant extract into the flask containing the aqueous ethanol, chloroform extract of plant and copper, cobalt, and manganese oxide solution. The color of the medium changed to brown within 5 minutes. Galvanization of nanoparticle copper oxide, cobalt oxide, and manganese oxide nanoparticle using the different extract of Acalypha indica, Clitoria terminata, Mucus aspera, and Pedalium rex by UV spectroscopy. Collection of plant border preparation. The Acalypha indica, Clitoria terminata, Mucus aspera, and Pedalium rex plant are collected. Then the plants were washed and dried. Plants were dissolved in 100 ml of distilled water, ethanol, chloroform, and extract formed were filled to a muslin cloth. Then the filter was treated with equal volume of water, chilled ethanol, chloroform, and the resultant precipitate will be used for further experiment. Biosynthesis of copper oxide nanoparticle. In a typical reaction mixture, 100 ml of aqueous 1 mm copper sulfate dehydrated was treated with 10 ml aqueous leaf extract and stirred magnetically at room temperature for about 4 hours. The formation of the particles can be seen within 2 hours. Nanoparticle prepared was centrifuged and washed with double distilled water. Biosynthesis of copper oxide nanoparticles. The cobalt nanoparticle was prepared in 250 ml of conical flask in which 50 ml of centimolar solution of cobalt nitrate was mixed with 10 ml of the plant extract along with vigorous shaking on the hot plate till real appearance of dark brown color. Biosynthesis of manganese oxide nanoparticle. 5 ml of plant extract added to 50 ml of aqueous solution of 0.2 m potassium permanganate. In heating and stirring at 70 degrees Celsius and pH 7 for 16 minutes. The potassium permanganate solution changed from colorless to brown with the formation of precipitate. The precipitate was centrifuged at 3000 rpm for 15 minutes and washed with distilled water 3 times. Catalyzation of copper, cobalt, and manganese nanoparticle UV visible spectroscopy analysis. In the bioreaction of copper, cobalt, and
Ashley?
manganese. Ma'am?
Ashley, please move to your result and discussion part.
Result and discussion. UV visible spectroscopy is a practical technique that calculates any optical activity invented from a noble metal nanoparticle for inserting copper, cobalt, and manganese. These nanoparticle dependent LSBR bonds in the visible reaction related to extension of the conduction electron of metal nanoparticles after their unique interaction with the electromagnetic field of light. The formation of copper, cobalt, and manganese nanoparticle during the reaction process in UV be dedicated by change in the color of reaction solution from colorless of dark brown with which can be visually in absorbed metal nanoparticle carry electrons which yield a surface plasma resonance absorbance bond due to a metal vibration of electrons of metal nanoparticle in research in a light wave. The appearance of the peak showed the calculation of surface plasma resonance of metal nanoparticle. The UV visible observation spectrum of copper oxide nanoparticle synthesis by treating 1 mm aqueous copper sulfate solution with along with alkali indica, Lightoria ternator, Lucas aspera, and Pedalium stem extract. The copper nanoparticle prepared by alkali indica stem extract have displayed sharp peak at 400 nanometer, which is assigned to the observation of copper nanoparticle. This spectrum confirms the formation of copper oxide nanoparticle. UV visible spectroscopy is a very useful technique for analyzing nanoparticle formation and the stability of metal nanoparticle aqueous solution. The UV visible observation spectrum of cobalt oxide nanoparticles. This synthesis by particle synthesis by alpha indica, Clitoria ternator, Lucas aspera, and Pedalium earth leaf and stem extract. The sharp peak is absorbed in 380 nanometer in Clitoria ternator leaf, ethanol extract 430 nanometer in alpha indica leaf distilled water, 470 nanometer in Lucas aspera leaf, ethanol extract, 420 nanometer in Pedalium earth leaf ethanol extract. These spectra confirm the cobalt oxide nanoparticle. The formation of reduced manganese nanoparticle colloidal solution were monitored by using UV visible spectrometer. The observation spectra of the supersets were taken between 350 to 550 nanometer. UV visible spectrum of the biosynthesis of manganese nanoparticle using distilled water, ethanol, and chloroform alkali indica, ternator, Lucas aspera, and Pedalium earth leaf and stem extract. A result shows a broad observation peak of between 350 nanometer, which is due to the surface plasma resonance of electron present in the surface metal nanoparticle. The maximum observation peak of metal nanoparticle observed 550 nanometer. Summary and conclusion. Metal nanoparticles have been widely used in range of recent scientific and technologies applications. They can be produced by conventional chemical synthesis or green synthesis methods. Green synthesis consists of a myriad of promising appearance of the protection of metal nanoparticles which restrict properties. Plants represent in the most expert group of living organisms for the green synthesis of metal nanoparticles, and to date, hundreds of species have been used. However, there are several factors that should be taken into account when performing green synthesis of manganese metal nanoparticle remains under enrichment or unexplored. The present work repeat biosynthesis of copper oxide, cobalt oxide, and manganese oxide nanoparticle using the different extract of Agalipa indica, Lucas aspera, Clitoria ternator, and Pedalium earth. Plant provide the better platform. The nanoparticle synthesis they are free from toxin chemical and provide natural copying reagent. The reduction of copper, cobalt, and manganese using the plant leaf and stem extract are viewed by the color change in the reaction solution. Calculation of nanoparticles were done by using ultraviolet visible spectroscopy. The UV visible observation spectra of the copper, cobalt, and manganese nanoparticle when different extract of organic indica, and Pedalium leaf recorded Manganese metal nanoparticles have free electrons which yield air surface plasma resonance observed by due to metal vibration of electrons, metal nanoparticle in resonance with light wave. The appearance of the peak show the characterization of surface plasma resonance of copper, cobalt, and manganese nanoparticles. The UV viscous spectral studies confirm the surface plasma resonance of green synthesis of metal nanoparticles. Thank you, ma'am.
Vimisha, nice presentation. Very good, girl. Who is the next person to do? Daf? Hello, Daf? Who is the next person? Come.
Lipika, you can share your screen. And the next presenter is Monisha.
I present.
Ma'am. Ma'am.
Lipika, you can start, Beta. Your screen is visible.
Okay, ma'am. Good afternoon, everyone present here. My topic is comparative study on metabolic profiling and bioactivity analysis of mangrove species collected from Thoothukudi and Pinocchio. Mangrove plants, the role in ecosystem situation between dense halophytic fishes can the sediment habitat and region. This is salt tolerant, highly supports ecology, economy, and ecosystem of the area. Materials and methods, the documentation of the mangrove associates, then physicochemical analysis of mangrove soils, the collection of sample and preparation of the extract. Then we find out the qualitative analysis, quantitative analysis, antioxidant activity, FTR analysis, GCM analysis, and antibacterial. The species they always and they see have two species, and this is the in Thoothukudi there are 8 herbs, 4 shrubs, and 2 trees. And 3 climbers reported. In Puncoil, the surrounding and Apocynaceae have 2 and Xenopodiaceae have 2 species. Ma'am, ma'am, Am I audible?
Yes, Deepika, you are.
They will continue.
Okay, ma'am. The physicochemical properties of soil, the pH and electric conductivity, and the pH is more or less same in the two sides, and the electric conductivity is a little bit higher in the Punnakoil, unpolluted site. Then the nitrogen, potassium, and phosphorus. Nitrogen and phosphate is higher in Thoothukudi, and the potassium is higher in Punnakoil. The qualitative analysis. In qualitative analysis, we used hexane, chloroform, ethyl acetate, ethanol, methanol, and water. And 15 different phytochemical tests were carried out for the 12 different extracts. In qualitative analysis, the methanolic extract gives the good results than other extracts. Then the quantitative analysis, the phenol content of the selected mangrove plants. The phenol content is higher in the Avicennia leaf collected from the Punnakoil, then followed by Avicennia leaf collected from Thoothukudi, and least in the Rhizophora mucronata, and then flavonoid. Flavonoid is higher in Avicennia stem in both the sides, and the stem and followed by the stem extract of Rhizophora, and then tannin. Tannin content is higher in the Rhizophora stem compared to other extracts. And vitamin C is also vitamin C, the leaves of Rhizophora and Avicennia from the polluted and unsalted site has the high vitamin content than stem extract of the same plant. And vitamin E content is higher in Rhizophora. Protein is also higher in the Rhizophora mucronata leaves. Antioxidant activity. In antioxidant activity, the DPPH and H2O2 scavenging activity. In DPPH radical scavenging activity, the leaf extract scavenging potential varied between 16.9 to 26.2, and H2O2 activity is higher in Avicennia marina leaf and minimum in the stem extract of Avicennia marina collected from Punnakoil. Then the FTIR analysis. FTIR analysis of the Avicennia marina leaf collected from Thoothukudi site shows 18 peaks ranges from 622.67 centimeter power minus 1 to 3422 centimeter power minus 1, which was ranges from OH of alcohol and phenol, CH and C double bond O of alkanes, and NH of amines, and C double bond O of saturated, and SS and B of alkyls. And the Avicennia marina leaf collected from the unpolluted site have 14 peaks. And the Rhizophora mucronata having peak, the peak at 3442 is assigned as OH and hydrogen bond alcohols and phenols. Then GMS analysis. In GCMS analysis, we found some components named 2-ethyl acetylene and indole, and salicylic acid, dimethyl bis trimethyl salicylic acid, and thienofluron carbonate, and 2-hydroxy trexamethyl and cyclohexamethyl. These components are responsible for the antibacterial, antimicrobial, anti-tumor, and antioxidant activities. The activity in antibacterial activity, we have used 4 strains: Escherichia coli, Bacillus subtilis, and Staphylococcus aureus. And in cells of the antibacterial activity, the E. coli was the most susceptible strain, whereas the Vibrio was the most resistant one. Conclusion: the mangrove tissue contains various bioactive compounds such as alkaloids, phenol, flavonoids, saponins, proteins, and trains. Presence of these metabolites is indicative of the potential such as medicinal plants. This results update from the study can be valuable for future studies on Avena marina and Rhizophora mucronata. The recognition of medicinal and bioactive values can enhance the conservation of the plants of the mangroves in Thoothukudi and Punnakayal. However, the chemical constituents present in these plants which are responsible for various activities such as antioxidant, antimicrobial, anti-tumor, antiarthritic, and they are rich in wide variety of secondary metabolites, and they are to investigate further. The adaptivity of mangrove trees to the salinity could be optimized genetically as it isolate the alien genes which will be transferred into the other crops vulnerable to the ecological problems. Thank you. Ma'am.
And ma'am, do you have any questions?
And ma'am, any questions from your side, ma'am?
Flora ma'am, shall I call the next participant?
Okay, Duff.
Monisha? Ms. Monisha, now you can share your screen and present your paper. And the next presenter is Sandhya Rachel.
Ma'am, can you see my slides? Ma'am? Excuse me.
Yes,
Ma'am,
ma'am.
can you see my
Yes,
slides?
Monisha, we can see your slides.
Thank you, ma'am. Good afternoon, everyone. Myself, Monisha Jain. The topic I'm going to explain is the influence of physiochemical parameters on seaweed diversity and distribution of Harel and Gulf of Mannar. Presentation shows introduction, objectives, materials and methods, results. And conclusion. Introduction. Algae are an extremely diverse group of chlorophyll containing organic elements on the plant kingdom. Seaweed substrates such as rocks, dead corals, swivels, and shells in relatively shallow coastal water area up to 180 meters depth. It is also a eukaryotic organism. The marine ecosystem is changing simultaneously due to the natural process and anthropogenic causes like overexploitations of resources, land use changes, and alteration of habitats. Taking into account the change in environment and resources, it is necessary to study their effect on the seaweed diversity and to ensure their regular distribution in the ecosystem.
Monisha, sorry to interrupt you, ma'am. Please go to the result and discussion.
Oh, okay, ma'am. Results. My parameters of water shows colorless, turbidity, solid 42,820 mg per liter, and electric conductivity 61,180. Then power of hydrogen 8.26, then total alkalinity 2,000 mg per liter, then total acidness 5,200 mg per liter. Then chemical parameters of the water shows calcium 1,280 mg per liter, magnesium 480, sodium shows 6,000 mg per liter, potassium shows 8,000 mg per liter, nitrate 40 mg per liter, then nitrite 0.24 mg per liter. Iron, ammonium, magnesium shows null. Then sodium has 8,000 mg per liter, fluoride 1.8 mg per liter, sulfate is 18,520 mg per liter, then phosphate is 0.26 liters. As that of water, the soil also tested for the physicochemical parameters. The pH shows 8.40, then electric conductivity 7.92, bulk density 1.72, soil gravity 2.63 milligram per centimeter cube, soil porosity 32.60, moisture content 24.72%, organic carbon 0.70 grams per acre, nitrogen 275.9 grams per acre, phosphorus 94.73 grams per acre, and potassium 3 grams. Then the list of green algae along the coastal areas Hair Island there for belonging to the four, which comes under four of distributed when compared with other chlorophyll members. Here, then brown algae collected along the coastal areas of Hair Island, in which listed below, they comes under four comes under or identified. Here, most of the some species of Pheophyceae members. Then Rhodophyceae members were identified. Here, families were listed. Here, gradually species distributed. Then some species of Rhodophyceae members, the present study on diversity of species clearly states the change in algae or decrease. To overcome this, there must be some checkpoints to prevent the loss of macroalgal pollution. Excuse me, ma'am.
Ma'am, is there any questions? Next, I call upon Ms. Sandhya Rachel to present her screen. Sandhya Rachel. Next presenter is Jeeva Satyapida.
And shall I start? Ma'am?
Yes, ma'am, you can start.
Good afternoon, one and all gathered here. My topic is morphological, phytochemical, and FTI spectroscopic analysis of selected species of Poecilocaceae. Introduction. Major sources of traditional medicines are plants with large variety of bioactive constituents which are effective against different diseases. Ornamental plants can provide multiple profits with regards to environment, beauty, economic concern, and human lifestyles. Despite the increasing interest of ornamental plants, some of them are also cultivated for their medicinal use as they have many bioactive compounds. Scope and objective: to identify the morphological characters, to perform qualitative analysis of phytochemical in various leaf extracts of selected species of Poecilocaceae, to estimate quantitatively the percentage of elements and the various secondary metabolites present in selected species of Poecilocaceae, to perform the FTIR studies of leaf and stem powder of selected species of Poecilocaceae. This is my plants, Poeciloca grandiflora and Poeciloca umbragicola. Methodology: qualitative analysis, tannin, saponin, flavonoids, terpenoids, alkaloids, steroids, carbohydrates, glycosides, protein, phenols are analyzed qualitatively. Protein, carbohydrate, flavonoid, vitamin C, vitamin E are analyzed quantitatively. By the method of free radical scavenging activity, antioxidant is analyzed, FTIR is analyzed. Morphological characters: selected species of Poecilocaceae. The strength of the stem is prostrate on both the species. Whitish color of the stem is whitish in Poeciloca grandiflora, and then reddish in Poeciloca umbricicola. Both the texture of both the species is smooth. Leaf arrangement is alternate, and composition is simple in both the species. The shape of the leaf is needle in Poeciloca grandiflora and overweight in Poeciloca umbricicola. Margin and the bases are entire and round. Flower position is axillary in both the species. Calyx color is green in both the species. Calyx type is persistent and united at the base in Poeciloca grandiflora. Broad-based welted at the ovary in Poeciloca umbricicola. Corolla color is various color in Poeciloca grandiflora, yellow color in Poeciloca umbricicola. Poeciloca corolla shape is overweight with the entire margin in Poeciloca grandiflora, and overweight with bi or trilobed in Poeciloca umbricicola. Stamen is 8 to 9 in Poeciloca grandiflora and 6 to 12 in Poeciloca umbricicola. Stigma is 5 in number in Poeciloca grandiflora. Poeciloca umbricicola. Quantitative morphological measurements of studied shoot length, shoot width, space, leaf length, width, leaf area, calyx length, and corolla length are studied. In qualitative analysis, tannin, saponin, phenol, steroids are totally absent in both the species. Alkaloids were present in all the samples. Leaf sample of Poeciloca grandiflora contain flavonoid, glycosides, terpenoids, and quinones in both the aqueous and methanol extract. Leaf sample of Poeciloca umbricicola contain glycosides in aqueous extract. Anthraquinone is present in stem extract. Quantitative analysis of phytochemical from selected species of Poecilocaceae. Protein level is maximum in all the samples. Carbohydrates are less in all the samples. Antioxidant activities such as flavonoid, vitamin C, and vitamin E are analyzed. Flavonoids and vitamin C is higher in the Poeciloca umbricicola stem. Vitamin E is higher in Poeciloca umbricicola leaf. Antioxidant activity. Poeciloca grandiflora has Poeciloca grandiflora stem has more antioxidant activity, and then Poeciloca umbricicola stem has more antioxidant activity. On comparing both the plants, Poeciloca grandiflora has more antioxidant activity. FTI spectrum confirm the presence of alcohols, phenols, alkanes, alkynes, alkyl halides, aldehydes, carboxylic acids, aromatics, compounds, and amines, and different extracts. Summary and conclusion. Morphologically, they are similar. We can differentiate this plant only by the leaf and flower. Leaves are needle in Poeciloca grandiflora and overweight in Poeciloca umbricicola. Petals are numerous in grandiflora. Petals are 5 in Poeciloca umbricicola. The result of the preliminary phytochemical screening indicated that both the plants were free from steroids. They have rich source of protein and high antioxidant scavenging activity. Therapeutic value also rich. Therefore, further efficacy and safety studies are encouraged on this potential herb with the hope of replacing in clinical practice, especially for anti-diabetic and anti-cancer. Thank you, ma'am.
Now we invite Dr. Sandhana Mari to present her paper.
Hello, ma'am. Can I audible?
Yes, ma'am.
Good afternoon to all. I am Dr. Shantana Mari, this is scholar of St. Mary's Botany, Autonomous Thoothukudi. I am going to present my paper. Next slide, ma'am. Next one. nutritional value of coastal Cyperus bulbosus one. So this plant undergoing the family Cyperaceae. The Cyperus is a large genus, about 600 subspecies used as food, medicine, and ornamental uses. The Cyperus bulbosus, like that, some species of Cyperus esculentus and Cyperus repentans already exploited for food and medicine. Next one. This taxon selected for the study, present study, the Cyperus bulbosus. Its vernacular name of this plant is in Tamil, Silandiarisi. In Andhra Brigade, Bridama, in West Rajasthan, so many names and various names they called in various states. And this it's a herb, fibrous stolon, black-coated tubers and raw tubers. A sweet and nutty flavor. The spikelets are brown, compressed, and 3 stamens are present. Next one. For my study, the tubers with the husk and removed tubers are used for my study. For especially this used for nutrition studies. It is for distribution. It is distributed in Australia, Asia, and Africa. In India, Andhra Pradesh, Rajasthan, Ahmed, Bombay. Common in Deccan Peninsula, Bentic Plain, and throughout the coastal lines of Tamil Nadu. And especially, it is present in the coastal areas of Tamil Nadu in Thoothukudi district. The main uses of this tuber is the tubers are highly edible. These plants and also tubers are used in traditional system of medicine. Okay. Next one, please. For this nutritional analysis, the raw and boiled tubers are evaluated for the nutrient content and nutraceutical composition. For the nutrient analysis is based on proximate composition, mineral content, carbohydrate profile, amino acid composition, and fatty acid profile. Next one. This it's Cyperus bulbosus. Some major Indian cereals and tuber crops are compared with the nutrient composition of this Cyperus bulbosus tuber. It reveals the raw tubers are rich in carbohydrate, moderate protein, fat, ash, and good fiber content. This boiling process can decrease the content of these compounds. The gross energy of the boiled tuber is 380 kilocalories and compared with raw tuber 84.5 kilocalories per 100 gram. So the proximate composition of tubers of Cyperus bulbosus is compared with some South Indian cereals and tubers like potato, cassava, sweet potato, cassava and yam. Next one. This is the carbohydrate profile of round boiled tubers of Cyperus bulbosus. The round tubers are rich in starch, total dietary fiber, insoluble dietary fiber, and soluble dietary fiber. This carbohydrate content also can decrease when we boil the tubers. So boiling decrease the content of total dietary fiber, insoluble dietary fiber, and soluble dietary fiber. The amylose content, especially this amylose content is more in tubers than amylopectin. Then the total sugar content, especially the total sugar content is more in boiled tubers. Next one, please, ma'am. This is the mineral composition of raw and boiled tubers of Cyperus bulbosus. It reveals the raw and boiled tubers are rich in both the raw and boiled tubers, are rich in sodium, potassium, minerals like sodium, potassium, iron, zinc, and copper. It is also compared with some South Indian cereals and tubers. Next one, please. This is the amino acid composition of raw and boiled tubers of Cyperus bulbosus. The amino acid composition reveals that the aspartic acid and glutamic acid are the predominant amino acids. In the essential amino acids, except leucine and lysine, all the other amino acids are present in sufficient quantities to meet the nutraceutical needs of man. So the essential amino acid is presented by 35.07% and 34.76% in non-essential amino acid is represent 64.92% in the raw and boiled tubers. When compared to the ratio of essential and non-essential amino acid of Cyperus bulbosus is 0.54 and 0.53 for raw and boiled tubers. So it indicates the high raw tubers and boiled tubers when compared to the boiled tubers of high amino acid content is present in the raw boiled tubers. Next slide, please. Next slide, please. The essential amino acid, this nutritional quantity of protein for boiled tubers of Cyperus bulbosus. The essential amino acid index, this essential amino acid index predicted protein efficiency ratio, then predicted biological value and nutrition value index are high in raw tubers than boiled one. So raw tubers then boiled one, the essential amino acid index reveals that the amino acid index and predicted protein efficiency ratio is highly in raw tubers than boiled one. Next one, please. This is the fatty acid composition of around boiled tubers of Cyperus bulbosus. 21 saturated fatty acids and 4 unsaturated fatty acids are detected in tubers. The predominant fatty acids in the raw and boiled tubers are linoleic acid and oleic acid. These two linoleic acid and oleic acids are the predominant fatty acids present in raw and boiled tubers. The ratio of unsaturated to saturated fatty acids in raw and boiled tubers is 1.74 and 2.08 detected. Next slide, please. This is the vitamin contents. Vitamin contents of raw and boiled tubers of Cyperus bulbosus. There is a vitamin C content, especially the vitamin C content is 4 to 5 folds more than other vitamins. So in this raw and boiled tubers, for especially vitamin A, B1 and E are more in raw tubers, while vitamin B2 and C are more in boiled tubers. Vitamin C and B2 are the more essential amino acids in boiled tubers. Next slide, please. This is the anti-nutrient composition of raw and boiled tubers of Cyperus bulbosus. The present work, some anti-nutrients like alkalides, oxalates, phytates, tannins, and saponins are determined in the raw and also boiled tubers. The anti-nutrients detected are within adequate friends and may not give rise to any toxic effect. So simply it is present in the simple way, and it does not give any toxic effect to the consumers. So for my conclude my presentation, the tubers of Cyperus bulbosus provide a number of desirable nutritional as well as health benefits also. These tubers may serve as nutraceutical, nutritional as well as medicinal usages in these tubers. Especially we can consume these tubers, we can get some nutritional as well as medicinal benefits also there. So it is a to know communicable chronic diseases and to maintain wellness. Efforts can be taken to popularize this economically important plant. So steps should be taken to promote the cultivation of this underutilized plant in coastal habitats. Thank you. Thank you so much.
Chandramari. Hello,
Yeah.
Chandramari. One question. Now this cypress is cultivated for the tuber purpose. In early days, we used to get this the tubers from market. Now it's not getting.
Yes, ma'am. Yes.
What's the reason they are not cultivated, or even it is where is grown as weeds? But as people are not aware of this, they are not.
Yes, ma'am. Overexploited and also underutilized condition in this species, ma'am.
It's not in Tamil Nadu, as far as Tamil Nadu is concerned, it's not available. The tubers are not getting,
yes,
not able
now
to get from the market. In
yes,
early days,
coastal areas. Yes, ma'am.
Okay. Okay.
Okay.
Nice presentation.
Thank you, ma'am. Thank you so much, ma'am.
Jennifer?
Glory ma'am. Glory ma'am. Jennifer and ma'am posted one message on the chat box, ma'am. The ma'am should leave now. So please.
Okay, shall we conduct a valedictory address now, and we can proceed presentation after the valedictory address? Shall we invite Dr. Sherina? She's
okay,
ready.
Ma'am, please give thanks to Anne, ma'am.
Okay, over chat box. Is enough? They are in
Voice, ma'am. Voice. She's going to learn.
Sorry, ma'am. Give a voice message. Give a voice message.
Okay, Dr. Jennifer, and we are extremely thankful for giving your wonderful presentation and also chairing our chairing the session, and for your patient hearing and constructive suggestion for our presenters. Thank you so much, and ma'am.
Dear participants, due to the time constraints, we are now moving towards the valedictory function. The technical session will continue after the valedictory function. So we are now into the valedictory function of the two-day International E-Conference. The chief guest of this valedictory function is Dr. Serena Margaret, Associate Professor of English, St. Mary's College Autonomous, Thoothukudi. I invite Dr. Mary Shanti, Assistant Professor of Botany, to introduce Serena ma'am. Shanti ma'am.
Yes, ma'am. Am I audible, ma'am?
Yes, ma'am.
Am I audible?
Yes, ma'am. Yes, ma'am.
Okay, thank you, ma'am. Good evening to all connected here. It gives me immense pleasure in introducing the resource person for today's valedictory address on the International E-Conference on Recent Trends in Science and Technology. With great pleasure, I introduce Dr. Serena Margaret, Associate Professor of English and IQAC Coordinator, St. Mary's College Autonomous, Thoothukudi. She has pursued her UG degree from Fatima College, Madurai, and she received her PG degree from Sri Meenakshi Government College for Women, Madurai, and she has obtained her Master of Philosophy and doctoral degree from Madurai Kamaraj University, Madurai, and Manonmaniam Sundarnar University, Tirunelveli, respectively. She is holding a 21 years of experience in the field of teaching. So let's see program she has organized in this field. In addition to her, adding to her CAP, the further to the CAP, she has cleared her NET exam and SET exam. And also she has organized various programs. Let's see the current programs that she has organized. It's the orientation program. It's really 8 orientation program, 1 induction program, and then webinars 4, which includes national and international, and 2 seminars, 2 workshops, and FTP 3, which includes national and international. In addition to her credit, she has published 5 research papers in reputed journals. She has served as resource person in 5 programs, various events. And she has also edited 4 book chapters. That is, she is one of the board of the 4 editors. And currently, she is holding various positions. That is, NIRF coordinator, single point of contact, SWAYAM NPTEL local chapter, and member of board of studies for PG English in Manonmaniam Sundarnar University, Tirunelveli, and then students induction program coordinator, subject expert for board of studies in VV College for Women, Virudhunagar, and Saurashtra College for Women, Madurai. She has received the Elite Silver certificate for the online course in short fiction in Indian English literature from NPTEL in SWAYAM portal. So she has also held various programs previously. She has been. So I'm just adding a few alone. That is student council advisor, prepared course content, then trained PG students for NET exam, and she has also trained students for news reading in visual media. She is the chairman for UG evaluation. Such an eminent person is Amit says to deliver the validity address. Dear ma'am, welcome you. It's over to you, ma'am. Thank you. Ma'am, Serena, it's over to you.
Serena, good evening, Serena. Serena, good evening.
Good evening, ma'am. Good evening, ma'am. Is my screen visible, ma'am?
Yes, ma'am.
Yes, Serena, it's visible.
Good Good evening to one and all present here. Reverend Sister Flora Mary, Secretary, Dr. Sister Lucia Rose, Principal, Dr. Glory, Convener of this e-conference and Head of the Department of Botany, Dr. Sister Oroke Genesius Alphonse, Overall Coordinator and Member Secretary, DBT Star College Scheme, Departmental Coordinators, Organizing Committee Members, and Faculty of Botany, Advisory Committee Members, faculty, students, and research scholars from other esteemed institutions across the country and the globe. I deem it a privilege to deliver the valedictory address at the culmination of this two-day international e-conference on recent trends in science and technology. Is my voice clear, ma'am?
Clear.
Is my
But
voice
some
clear? Shall I
echo
continue?
is here. Ma'am,
No,
your voice is
it's-
echoing, ma'am.
But for us, it is not echo. It's very clear now.
Shall I continue?
It's clear.
Echo is there, ma'am.
Yes, ma'am.
A scientist who would know the laws of nature must sit passively before nature. He may not dictate to nature its laws, nor may he impose his own intelligence upon nature. Rather, the more passive he is before nature, the more nature will reveal its secrets. Most Reverend Fulton J. Sheen. Humankind is poised to make transformational scientific and technological strides in coming years. Ma'am, is my slide moving?
Ah, yes. Moving. Yes.
Although technological innovation can bring enormous benefits in material well-being, new technologies can also create social and economic disruptions, national security risks, and ethical dilemmas, all of which raise complex questions. The key and ever-increasing roles of science, technology, engineering, and mathematics, STEM, innovations are evident across the spectrum of security realms. STEM applications in weaponry include a broad range of advances in sensor technologies, material sciences, and artificial intelligence, to name just a few. In the broader arena of human security, fields such as satellite technology, energy harvesting and conversions, water treatment, and health and medicine continue to improve and innovate due to both greater understanding of the natural world and ever-growing capabilities to meld, merge, and apply diverse areas of scientific knowledge into integrated technological systems. Over the past few years, a major shift in the technological arena has had a direct impact on geographic citizen science. The combination of significant developments in open source software, do-it-yourself DIY, hardware proliferation, and the equipping of mobile devices with multiple sensors. This combination has enabled millions of citizens to be involved in geographic citizen science projects with minimum cost and indeed fueled its expansion to every domain. However, this combination is neither always straightforward nor hassle-free. Moreover, it is often a challenge to intertwine any of the possible technological options with the aims, goals, and missions of different geographic citizen science projects. It's difficult to find and implement the best possible technological solution given a project's characteristics and constraints, example, funds, time, resources, etc. And this can be true irrespective of how technologically savvy project managers and participants are. There are several factors that contribute to this challenge, but perhaps the most important one is the pace of change and innovation on the technological front, from hardware and software that might appear or become obsolete to prerequisites and requirements that might change to the introduction of disruptive technologies that completely change everything. Nevertheless, technological advances can be thought of both as a challenge and as an opportunity to combat existing problems, progress the aims, and broaden the reach of geographic citizen science projects. For example, hardware is getting smaller and more efficient. New hardware is becoming available, example drones. Now we are using drones for surveillance, for gaming, for even wedding photography. Such is its existence into our day-to-day life. No, its exploration into our day-to-day life. Free and open source softwares now exist. Multiple sophisticated sensors equip everyday devices, example, mobile devices, wristbands, and access is provided to what was until recently extremely expensive data that previously only governments or big corporations could afford to and had access to. Example, high resolution satellite imagery. For example, technologies for species monitoring have evolved from expensive radio collars to satellite imagery or unmanned aerial vehicles, UAVs, and drones. Through this constant evolution, technology offers a new and diverse set of opportunities in geographic citizen science by opening new channels for public involvement, providing means to engage new audiences and for collaborative work. However, a technological approach alone cannot solve all problems. Any technology adopted needs to be put to good use and be supported by effort and time, not least because technology itself can be a source of challenges and biases. Before adopting a specific approach, it is important to consider, among others, issues such as participant demographics, affordability, access, and fitness for purpose. A careful choice might boost the development of the project, while the adoption of a suboptimal technological approach can negatively affect the project in terms of both the financial support needed and functionality provided. Thus, any technological consideration and research for a solution should keep a broad view and examine the entire ecosystem in which a technology is developed. Technological innovation fuels economic growth and has long been the foundation of national power and global influence. If the coronavirus pandemic is to be halted, if global warming is to be slowed down, and if economic growth is to recover, technology will play a critical role. Technology offers the opportunity to protect and improve our world, but it also poses fundamental challenges. Technological leadership in the realm of national security, business competitiveness, and standard setting has become an increasingly important objective for Europe and the United States. Domestically, internationally and within the transatlantic relationship. But as leaders in the creation of cutting-edge technologies such as advanced communications, artificial intelligence, and synthetic biology, Europe and the United States are finding that the speed of innovation is outpacing the development of international rules for the use of these innovations. The nations that best nurture entrepreneurs invest in research and development, foster markets for advanced technologies, set new standards, and afford all their people access to new technologies will lead the technology-driven world of the future. Europe and the United States have long been technological rivals as well as partners. Competition has often limited cooperation. In the 1960s and 1970s, Europeans worried about US dominance of nascent computer technologies. More recently, Europeans have decried the rise of US digital platforms, even while many of their consumers and small businesses have used these platforms extensively. At the same time, Europeans hold their own cutting-edge technologies industries including life sciences, autos, nanotechnology, and telecommunications. And they have ambitions to create their own industrial digital platforms. But the competitive dynamics are shifting. China has become a major player in the global technological game and promises to be an even greater force in the future. Neither Americans nor Europeans have the talent or the resources to prevail against such competition on their own. China is already world's top producer, exporter, and user of wind turbines, solar panels, and batteries. It also accounts for 60% of global electric vehicle sales. Most prominently, in the recent transatlantic debate over technology, Beijing is rapidly deploying 5G telecommunications equipment, the backbone of the coming Internet of Things. It leads Europe and the United States in the size of its 5G home market, its technology, and the ease of domestic rollout. And largely through subsidies, it is also the lowest cost supplier. This poses a challenge for Europe and the United States. While Europe has two domestic producers of 5G technology, Ericsson and Nokia, the United States has none. Similarly, China, Europe, and the United States are now emerging as the main competitors for global leadership in artificial intelligence. In the race to extract information of economic, security, and national security value from the massive quantities of data generated by the modern economy, the United States currently leads, China is rapidly catching up, and the European Union lags behind. China's large market, its global lead in investment in AI, pervasive surveillance technology, and disregard for privacy promises to afford its access to more data than is currently available in either Europe or the United States. Meanwhile, Americans and Europeans differ over how to protect the privacy of personal data, and neither society has addressed how to equitably share the economic benefits created by the new digital economy. The terrain for all future technological competition is set through standard setting and subsequent adoption of these technologies by users and developers who then build other applications and services on top of these technologies or platforms. The foundational nature of standard setting cannot be underestimated. The European Union sees itself as a standard-setting superpower. The United States has relied on its past technological leadership to dictate standards. But China is using its market preeminence to establish new hardware and software norms while attempting to globalize those norms by being more active in the international standard setting bodies that were once the preserve of Europe and the United States. As global technological competition has intensified, some Europeans had advocated technological sovereignty as a means of keeping pace with American and Chinese rivals. But sovereignty implies an ability to compete on an equal footing with China and the United States, built on a commensurate market, financial resources, and scientific talent. In their technological rivalry with China, European and US ambitions for technological leadership belie China's current advantages. European organizations account for about a fifth of global research and development spending, and US organizations more than a quarter. But if current trends remain unchanged, China's spending on research and development, which already exceeds that of any individual European nation, is on track to outpace the United States within the next decade. Moreover, while transatlantic businesses do more R&D than government, and that spending has steadily risen, most of that increase has gone toward applied research rather than basic research, the seed corn of invention. The size and potential of China's market also poses a challenge for future US and European technological leadership. China has nearly twice the combined population of the United States and the European Union. Its share of the world economy based on purchasing power is already comparable to that of either the United States or the European Union. Scale matters for many emerging technologies such as AI and genomic biology that require huge quantities of data to realize their potential. Together, the combined US and European markets offer such scale. Alone, they do not, but China does. Collaboration is fundamental to successful scientific inquiry. Given the growing cost and complexity of technological innovation and the diffusion of scientific talent, even economies as large as the European Union and the United States cannot hope to be primus inter pares in all key technologies, but they can strive to be global leaders collectively through an allied technology strategy, drawing on the deep roots of existing collaboration. So this collaboration model is not only meant for European Union and the United States, but for that matter, any Asian countries. Collaboration is the key term today. Transatlantic technological sovereignty, grounded in Western values and interests, but open to the world, is the best hope for Europe and the United States to develop the technologies needed to combat climate change, to overcome future pandemics, to restart economic growth, to defend their people, and to compete with China. So there are some of the future trends, and if they are followed, there would be change. Jointly support emerging technology, R&D. Europe and the United States, or any country that wants to lead, should jointly provide greater financial and regulatory incentives for transatlantic science and technology partnerships, including pre-competitive collaboration on R&D in artificial intelligence and data science, advanced battery storage, advanced semiconductors, genomics and synthetic biology, autonomous vehicles, smart building technology, 5G and successor generations of telecommunications technology, quantum information systems, and robotics. Nations should reassert their leadership in international standard-setting bodies and mutually develop and recognize each other's standards as they relate to emerging technologies. Promote technology partnerships, recognizing that cutting-edge technologies tend to emerge as a product of regional technology ecosystems such as Silicon Valley and Dublin, made up of networks of technological firms, capital markets, and research universities, should develop targeted tax incentives and investment schemes to promote closer linkages between emerging US and European technological clusters, or for that matter, any cluster in the developing nations. Any nation, it should update the technology controls of the Wassenaar Arrangement, the multilateral export control regime for conventional arms and dual-use technologies with regard to trade with China, Russia, Iran, and others. The new arrangement would include items such as AI, robotics, 3D printing, quantum computing, semiconductor manufacturing equipment, surveillance equipment, and other emerging and foundational technologies with significant national security value. Build on existing efforts, should create a digital development fund to help countries in Africa, Asia, and Latin America to buy Nokia or Ericsson broadband technology so that Huawei does not become embedded in those telecommunications markets with all of the attendant technological and data collection benefits accruing to Beijing, and provide technical assistance to develop the legal framework to ensure transparency in ownership and protection of privacy. Develop ethical and legal standards on artificial intelligence, synthetic biology, and other new technologies that promise great advances in health, energy, and food production, but also raise questions about consumer safety, ecological stability, privacy, and weaponization. This collaboration should include a common approach to risk assessment and management. Such standard setting should involve multiple stakeholders, including government regulators, private business, and representatives of environmental, consumer, faith, and civil and human rights groups. I will conclude my address with, again, Most Reverend Fulton Sheen's quote on the scientist. How could science be any enemy of religion when God commanded man to be a scientist the day he told him to rule the earth and subject it? Thank you.
Thank you, Dr. Serena. A big thanks for your elaborative valedictory address accounting the status of technology over the world. It was very wonderful to hear the technological marketing and competitions between nations, the information about the need of the technological collaborations that can bring change to combat climate change related issues, mitigations. Thank you so much for your elaborate valedictory address once again. Thank you so much, Serena.
Thank you, ma'am.
Okay. Pauline, Jennifer, shall we continue the technical session?
Yes, ma'am.
Few more girls to present their papers now.
Yes, ma'am. Yes,
shall we continue? Okay. Okay.
Dear participants, we are resuming the technical sessions right now. Capital ma'am, to whom shall I call?
Is it Jeeva Satyapida? I request
Yes, ma'am.
Jeeva Satyapida to
Yes,
present her paper.
ma'am. Yes, ma'am. Okay, ma'am.
And the next presenter is Vincy Agnes.
My screen is visible, ma'am.
Jiva?
Ma'am?
Jiva, share your screen. No, your screen is not shared yet. Kindly share your screen.
Ma'am, நீங்க ஷேர் பண்ணுங்க ma'am. Good evening, everyone. I talk about a study of the NaCl stress on the growth parameter and the anatomy of selected economically important legumes. Next slide, ma'am.
Just a moment.
In introduction, the environmental stress is a major area of scientific concern because it constrains plant as well as crop productivity. Salt in plant include any factor that could lead to the death of the plant. Salt stress is a condition where excessive salt in the soil solution cause inhibition of plant growth. The genus Vigna include many wild and cultivated species with plant tropical distribution. Among the pulse crop, Vigna is for the most important. Next slide, ma'am. Ma'am. Objective.
Change the slide now.
Objective. In the study, an attempt was made to examine the effect of salinization on 3 species of Macrotyloma uniflorum, Vigna radiata and Vigna anguiculata. The objective are to grow the selected seed in environment, to measure the growth parameter, to identify the anatomical change through microscopic studies. Then materials and method. Ma'am. The seeds of Macrotyloma uniflorum, Vigna radiata and Vigna anguiculata were collected from the local shop in Thoothukudi market. Various concentration of sodium chloride solution 50 millimolar, 100 millimolar, 150 millimolar were prepared. The selected pot were filled with soil and organic manures. About 25 seeds were shown in each pot. The pots were watered with 100 ml of normal water in alternated days. Then salt treatment was started from the 15th day after sowing. Next slide, ma'am. The plants were treated with NaCl salt using the following concentration: 50 millimolar, 100 millimolar, 150 millimolar, once 3 days for 35 dates. The parameter. Physical parameter. The plants were collected at the stage of 15th, 25th, 35th dates for growth measurements such as shoot length, leaf area, number of leaves, dry weight, and fresh weight. Microscopic studies. Free-handed section were prepared with a razor blade. The section were stained with saffronin. After that section were mounted in a slide using glycerin and were photographed using trinocular microscope. Next slide, ma'am. Ma'am, result and discussion. Result and discussion. This picture was shoot length. Shoot length of Macrotyloma uniflorum, Vigna radiata and Vigna unguiculata was severely affected with increasing concentration of NaCl. The higher shoot length was observed in the control series. It gradually decreased with increasing concentration. The minimum shoot length was observed in 150 millimolar concentration. Among the 3 sheets, the growth of Macrotyloma uniflorum greatly affected by the increasing concentration of NaCl. Next slide, ma'am. Next slide. Then this picture is root length. Root length of Macrotyloma uniflorum and Vigna radiata and Vigna unguiculata was severely affected with increasing concentration of NaCl. The higher root length was observed in the control series. It gradually decreased with increasing concentration. The minimum root length was observed in 150 millimolar concentration. Among the 3 seeds, the growth of Vigna radiata greatly affected by the increasing concentration of NaCl. Next slide, ma'am. Leaf length. Leaf length of Macrotyloma uniflorum, Vigna radiata and Vigna unguiculata was severely affected with the increasing concentration of NaCl. The higher leaf length was observed in the control series. It gradually decreased with increasing concentration. The minimum leaf length was observed in 150 millimolar concentration. Among the 3 seeds, the growth of Vigna unguiculata greatly affected by the increasing concentration of NaCl. Next slide, ma'am. Fresh weight and dry weights. Fresh weight and dry weights. Fresh and dry weights of Macrotyloma uniflorum, Vigna radiata and Vigna unguiculata were decreased with increasing salt concentration. Next slide, ma'am. Ma'am, next slide. Leaf anatomy. Leaf anatomy. The leaf anatomy of NaCl treated macrotyloma. The treated plant showed great variation in epidermal cells, thickness of palisade parenchyma, and number of xylem cells. Maximum destruction was observed in leaves of macrotyloma treated with 150 millimolar concentration of NaCl. Next slide, ma'am. Summary and conclusion. The morphological characters such as root length, shoot length, leaf length, and petiole length, number of leaf, fresh weight and dry weight, leaf area decrease with increasing the salt concentration. The plants can tolerate low concentration of NaCl such as 50 millimolar and 100 millimolar. As the concentration increase, it shows adverse effect. As the concentration of the salt increased, the anatomy of selected plant also showed great variation. The epidermal thickness and number of the palisade parenchyma cells and other xylem cells varied in the pot of the selected plant. Then, as the scarcity of the fresh water gets increasing, the becoming the work done, sufficient formation in the raised model crop of the salt resistance, since the parameter analyzes the assured and negative impact on the growth parameter of the plant. A new saline resistant variety may be a best attempt the future. Ma'am, thank you. Thank you, ma'am. Any question? Ma'am?
Glory ma'am, is there any questions from you? Now I call upon Vinci Agnes to defend her paper. Vinci Agnes.
Vinci?
Vinci Agnes. Vinci Agnes, unmute your mic and share your screen. Jennifer ma'am, shall I call the next participant?
Yes, ma'am. Yes, ma'am. We shall call her at the end.
Then is it Chitra? Ms. Chitra?
Yes, ma'am.
Okay, Chitra, now you can share your screen.
Okay, ma'am. Is it visible, ma'am?
Ma'am, visible. Your screen is visible, ma'am. You can proceed.
Okay. Good evening to one and all. Now I'm going to share about my project on Sthala Vrikshas in temples of Thoothukudi district, Tamil Nadu. Introduction. The word Sthala Vriksham refers to Sthala means place and Vriksha means tree. It is the practice of growing and maintaining trees in the temples. The main idea behind the establishment of Sthala Vriksham is the planting, maintaining, protecting, and conserving plant species for posterity. This habit shows characteristically the importance of medicinal plants in Indian system of medicine. Medicinal parts of the sacred trees are practiced in different forms. Objectives. The objectives of this study are to document different Sthala Vriksha species and their associated deities in the temples, to study the biological description of Sthala Vriksham, to study the medicinal value of Sthala Vriksham, to know the conservation status of Sthala Vriksham. Materials and method. The survey of Sthala Vriksha was conducted in the temples of Thoothukudi district. Temples were frequently visited and surveyed for the Sthala Vrikshas from the month of December 2020 to March 2021. Sthala Vrikshas were photographed and characters were noted for the identification purpose. Taxonomic identification was done using Gamble's Flora of Presidency of Madras. Binomial of the plant with family, their local names, parts used, and medicinal uses were recorded from the available literature. The conservation status of the Sthala Vrikshas were recorded based on the IUCN Red Data List. Result and discussion. This investigation is the first attempt to survey the Sthala Vrikshas in Thoothukudi district, Tamil Nadu, India. We have surveyed 92 temples. Out of 92 temples, Sthala Vrikshas are present in only 73 temples. Among the 73 temples, 36 were Vinayagar temples, 24 were Amman temples, 7 were Lord Shiva temples, 4 were Perumal temples, 1 were Murugan, and 1 were Muniyasamy temple. 9 different plant species are identified. Belongs to 8 families. Among the 9 plant species, 8 from dicotyledonous dicotyledon and one from monocotyledon, and that is Poracus flabellifer. Ficus religiosa is the most occurring species that are recorded in 42 temples, followed by Azadirachta indica, that is recorded in 20 temples. These are the temples we have surveyed. Ficus religiosa is present in 42 temples. Azadirachta indica present in 20 temples. Eagle marbles present recorded in 3 temples. Ocimum tuniflorum recorded in 3 temples. Ficus bengalensis recorded in 2 temples. Ipomia bescaprae, Calophyllum inophyllum, Termaridness indica, Poracus flabellifer were recorded in 1 temple. These are the images of Salavriksham we have surveyed. Then distribution of Salavriksham in different classes of angiosperm. Totally 8 families are identified. 7 families are belongs to dicotyledons and 1 were monocotyledons. 7 different genera are identified and from dicotyledon and 1 from monocotyledon. 8 different species were identified from dicotyledon and 1 from monocotyledon. IUCN category, the IUCN category of Salavriksham were identified. The species Eagle marbles comes under near threatened category, and the Poracus flabellifer comes under endangered category. Others Azadirachta indica, Calophyllum inophyllum, Ficus bengalensis, Ipomia bescaprae, Termaridness indica comes under least concern category. Generic diversity, I have already told, 7 different genera were identified that belong to dicotyledons and 1 from monocotyledon, that is Aracaceae. Species diversity, 8 different species were 8 different species were identified. In Moraceae family, 2 different species were identified, that is Ficus religiosa and Ficus bengalensis. Habit form, after 9 plants, 7 were tree habit and Ipomia bescaprae climber habit, Ocimum tuniflorum herb habit. This table contains botanical name of the Salavriksham, useful part and medicinal properties. Medicinal property and medicinal uses. They are used to treat various diseases like diarrhea, fever, cough, cold, etc. Edible taxa, of the 9 plants, 7 plants were edible. The most edible part is the fruit. In Ipomia bescaprae and Termaridness indica, the leaves are edible. In Termaridness indica, the leaves are used in the form of raw or cooked. It gives a sour flavor to the dish. In Ipomia bescaprae, they are cooked and eaten as a vegetable. Summary and conclusion, Salavriksham are valued for their botanical, medicinal, environmental and religious importance. This study is the first survey of Salavrikshas of various temples in Thoothukudi district, Tamil Nadu. 73 Salavrikshas are present in 73 temples out of the 92 temples. 9 different plant species are identified. 8 belongs to 8 families. The plant species Poracus flabellifer comes under endangered category. Eagle marbles comes under near threatened category. So necessary measures have to be taken to preserve these plants. Propagation of Salavrikshas in temples contributes to the conservation of our floral diversity. Sacred plants are worshipped by the local people for getting the blessing of health and wealth by positive powers of nature. It is a duty to present generation to preserve and promote these aesthetic treasures to conserve biodiversity and nature, which will surely play a part in the progression of human beings. These sacred groves preserved through millennia by our ancestors as potential bioresources should be respected and conserved for the future generation. Thank you. Hello. Ma'am. Where are you?
I call upon Agnes. Give her paper. Agnes.
Yes, ma'am. Am I audible, ma'am? Ma'am, am I audible?
Yes, ma'am, you are audible.
My paper is an ethnobotanical survey of medicinal plants used in Thoothukudi village, Sayapuram town panchayat, Thoothukudi district, Tamil Nadu, India. Introduction. Ethno means the study of people. Botany means the study of plants. The ethnobotany is the interaction between the plants and the people. The study of medicinal plants used by the local people with old style.
Vinci. Vinci.
Ma'am, audible, ma'am?
Yes, yes, you are. Yes, you are.
Sorry, ma'am, sorry. Ethnobotany is the interaction between the plants and the people. The study of medicinal plants used by the local people with old style, tribal benefits and information. The traditional medicine is a sum of knowledge, skills, practices based on the theories of indigenous people that leads to improve the health and prevent the physical and the mental illness. The Indian people have adequate knowledge about the herbal plants to apply the disease cold to mortal diseases. The study focus on the diversity and the use of the domesticated medicinal plants to cure the disease of human and animals. Objective of this study is to find out the sustainability of medicinal plants to enhance the valuable medicinal plants to the future generation. To conduct detailed botanical survey for documenting the diversity of plants to explore the medicinal value of plant in that region, to assess the traditional usage of medicinal plants, to document the intellectual knowledge of ancestors through the ages. The aim is to analyze socio-economic survey in the area with a special emphasis on population structure and the proportion using medicinal plants for different purposes. The study area is the Thoothukudi village present near to the Sayapuram town panchayat. It is located 19 km distance from the Thoothukudi. The methodology. I used questionnaire to survey randomly. I visit the field and make questions from the people. Then the quantitative analysis. ICF values found by using the following formula. ICF values informant census factor. The informant's agreement on the medicinal plants, consumption species, and assess the variability in mode of use against the disease reported. Result: the socio-economic and demographic characteristics of Thoothukudi village shows the gender disparity. The male presenting higher female than the female. Male then the age group of people below 20 is low, and 31 to 40 people are present high percentage. There has no formal education in the region. Mostly the people studied in primary and secondary level. The employers are high amount of employers are wealthy employers. Most of the people are depending upon the farming. The landless people are daily wages. The religion is mostly present in the region is Christian and rather than Hindu. The caste is recorded highly in BC. The transport facility of the people most of them use bike. Rarely they use cycles. The result, the distribution of plant species, the totally 181 plant species were recorded in that region from 163 genera. From that, there are 63 families. From 63 families, they are 62 angels from one pteridophyte family. From the 62 angels, 51 them are dicotyledons, 11 them are monocotyledons. The 51 dicotyledons contain 32 polypeptides, 14 gamma-petal, the next source habitat vegetation. High amount is recorded in low amount climbers and base. The Amaranthus family has a large family with 6 genera and 10 species, followed by the Solanaceae family that has 5 genus, 9 species, Asteraceae family that has 8 genus, 9 species, and the Euphorbiaceae family that has 5 genus, 9 species. Only one pteridophyte plant is Nephrolepis bicyda. This is the picture of this plant. The medicinal plants. There are totally 83 medicinal plants from that region. From 83 medicinal plants recorded in the paper. From that, I mentioned 4 plants. First picture is on Acalypha indica, that is used, that the aerial parts of the Acalypha indica used in the cough bleeding from lungs. That then the juice of the leaf used to cure emetic and sprouts. Then Psittacardifolia. The next picture is Psittacardifolia. The leaf and the root is astringent. The infusion given in the urinary trouble. In hemiplegia like diseases, the root of Sida is mixed with Asafoetida and rock salt gives good results. The Cissus quadrangularis. Then the stem of the Cissus stem juice is used to cure scurvy, and the root powder is used to cure some of the toxins. The external grandis wood. The wood of the external grandis, the oil extracted from the external grandis wood that is applied for eczema, and the flower and seed used as a diuretic agent. The bark is used as astringent and used in ground. The 70% of plants stem and 70% of plants use aerial parts. 25% of underground parts is useful. Then the medicinal plants used to cure the human diseases. It was collected from the people, indigenous people present in that area. The Calatrava gigantea is the leaf was used in rheumatic pain. Then the Centella asiatica leaf was cooked and used that is stimulate the brain stimulator, that acts as the brain stimulator. Then the Euphorbia citta, the whole plant of Euphorbia citta decoction used to cure fever. Then the piper beetle, that the fruit of piper beetle decoction is used to cure cold and cough. Then the medicinal plants for animal diseases, to cure animal diseases, that is aloe vera. Aloe vera is a well-known plant that is used to cure the ulcer of cattle. It was mixed with feed, chopped and mixed with feed to cure the cattle disease, cattle ulcer. Then the leaf of aloe vera mixed with seed, that is for health, to cure diarrhea. Andrographic paniculata. This plant leaf, the leaf of the plant is used to cure the dysentery of cattle. It was made decoction to with the decoction of the andrographic paniculata leaf to provide for the cattle dysentery disease. Viral fever was cured by the andrographic paniculata. Then, asparagus cepaceus, the cattle, the root of asparagus cepaceus cure the multiple diseases in fish. Capsicum annum, the fruit is the fruit taste is mixed with the seed. It cure the cough and itching sensations. Then there are totally 18 categories that mentioned in this paper. There was common diseases like cold, cough, fever, snakebite, rheumatism, hair growth, eye problem, dandruff, etc. The hair growth has a high ICF value because water present in that region. The least disease category has dandruff that has low ICF value, that is 0.11. Then conclusion. The traditional medicinal knowledge of medicinal plant usage among the Nagapursi village residents was discovered in this report. The local population has rich indigenous knowledge but do not adequately documented. Some listed plants are suffering from sheer plantation. It leads to the disappearance of most vulnerable species. It will be essential to adopt a sustainable management strategy to avoid the degradation of biodiversity of the region. It is critical to gather this data and create a medicinal plant database for future research and the creation of new drugs and future phytochemical analysis. Thank you. Thank you.
Nice presentation.
Thank you.
Any question? Anybody wants to ask question? Who is the next person to do, Jenny?
Now I invite Ms. Vimala to present her paper. Ms. Vimala. And the next presenter is Soundarya.
My screen is visible, ma'am?
No. No.
Vimala, just share your screen.
It is visible, ma'am?
Yes, Vimala, you can go ahead.
Yes, ma'am. Good evening to all. Now I start my work, that is FTAR, GCMS, and antibacterial activity of Carcorus A strains from the family Tiliaceae. Every plant is a medicinal herb, so the plant kingdom is a treasure house of potential drug used for prevention and treatments of ailments. Phytochemicals are formed during the metabolic process for plants. Identification of functional group and phytocompounds from plants species is the first step towards realizing their medicinal application. Biologically, Carcorus species are used as a diuretic, gonorrhea, celiac disease, and anti-inflammatory and antibacterial activities. The seed of Carcorus aestuans is used for the treatment of gonorrhea and tonic. So whole plant is used for the treatment of stomachache and fever. Traditional use of Corchorus species from the traditional use of American peoples medicinally, the root extract and leaf extract of Corchorus aestuans are Corchorus species commonly used for gonorrhea. And in India, seeds are used for the treatment of stomachache and pneumonia. The leaves serves as against headache, and seeds in the form of powder in decoction as a tonic, carnative, and vermifuge. The scope of my work is based on the traditional uses to identify the phytochemical constitution present in the whole plant of Carchorus aestuans, to identify the functional group of Carchorus aestuans by FTIR analysis, to identify the bioactive compounds of Carchorus aestuans by GCMS analysis, to evaluate the antibacterial potential of acetone, methanol, ethanol, and aqueous extract of Carchorus aestuans. The systematic position, the plant Carchorus aestuans comes under the class Dicotyledon, subclass Tinidae, and the order Malvaceae, family Tiliaceae, and the subfamily Guidae. It's a herb. It's mostly used distributed in tropical areas. Then materials and methods, FTIR analysis by Carrero et al. 2008, and GCMS analysis by Hema et al. 2010, antibacterial activity by Kirby and Boyer et al. In 1986. Then I move on to my results and discussion. FTIR analysis, FTIR spectroscopy analysis of Carchorus aestuans. So that the week starts with 517.85 and ends with 3419.56. This table shows the stretching bonds and its functional group, some carboxylic acid group and amines, some and aromatic amino acids, amines, and nitro group and iodo groups are present in this Carchorus aestuan plant. Next, GCMS of chromatogram of plant extract, ethanol plant extract of Carchorus aestuans. This figures shows the peak value, retention time of such compounds. Chemical compounds identified from the ethanol extract of Carchorus aestuan through GCMS analysis. Totally, we found out 21 chemical compounds identified in Carchorus aestuans. The RT value, less RT value is start with 14.596, and the highest value of RT value is nothing but the retention time that has the solvent move on to the gas chromatography, and 18.520. Next, the list of the chemical compounds identified from ethanol extract of Carchorus aestuan through GCMS analysis. Some compounds have antibacterial, anti-inflammatory, anti-Parkinsonia activities, and some have some muscles relaxant stimulant activity, especially the actosiloxane is have a antibacterial activity. In 21 compounds, the major compounds are 6 major compounds, and 15 minor compounds are there. And the octosiloxane and silicic acid, diethyl bisester, 2-methyl-7-phenylindole, it acts as the antibacterial activity. And the antibacterial activity of Carchorus aestuan plants extract with the different solvents against a human pathogen. The different solvents were extracted in a different solvent, that is ethanol, methanol, acetone, and aqueous extracts of Carchorus aestuans exhibited the activity against different bacterial species, that is Escherichia coli, Vibrio cholerae, Staphylococcus, and Bacillus subtilis. The ethanolic extract of Carchorus aestuan possessed more or less same zone of inhibition compared to standard antibiotic, that is amoxicillin. In the study revealed the FTIR spectral data present so many aldehyde groups, aromatics, nitro groups, and sulfonic acid and carboxylic acid group. The carboxylic acid present in the medicinal plant serves as a main pharmaceutical product in curing ulcer, jaundice, headache, stomatitis, fever, pain, and etc. The presence of identified bioactive compounds through the GCMS analysis respond to antioxidant and antimicrobial effects also. The crude extract of Corporus acetone exhibit the antibacterial activity due to the presence of acrylic and acylic acid dimethyl-based ester 2-methyl-7-phenylindole. The antimicrobial activity of various solvents extract of Corporus acetones was tested against clinical isolations of gram-positive and gram-negative bacterial strains. Now I conclude my work. That's the findings of the present study suggest that Corporus acetones would be a great potential source of natural antibacterial agent that could have a great importance as therapeutic agent in preventing or slowing the oxidative stress-related degenerative disease. The phytocompounds identified might serve as a source of drug formulations in future. Thank you.
Vimala, your
Yes.
presentation is good, Vimala.
Thank you.
Then, this GCMS analysis
Yes,
based
ma'am.
on Padmavati, who is she has standardized the procedure. The citation is correct. I
Which
got
one?
doubt about it.
Which one, ma'am?
GCMS analysis. Who gave the procedure? You have cited GCMS analysis was done based on Padmavati.
No, ma'am. GCMS analysis by Hema et al. 2010.
Hema.
Yes, ma'am.
Citation is correct. References given.
Yes, ma'am. I give the reference.
Hema reference Kriya.
Yes, ma'am. I give.
Okay.
Yes, ma'am.
Now, any question? Students, participants, any question? Then you can invite the next person.
Next, I will invite Ms. Soundarya to defend her paper.
Can I share my screen, ma'am?
So you can share.
Yes,
your screen.
Soundarya.
And the next presenter is Kishania.
His screen is visible, ma'am.
Yes, Soundarya, it is visible.
Good evening, everyone. I will explain about extraction of fabric dyes from brown seaweeds and their properties. Myself, N. Soundarya. Introduction. Dyes are widely used in the various industries such as food, textile, cosmetics, paper, paint, etc. Dyes are a colorful organic compounds that absorb light in visible area that and can firmly bind to substrates. Dyes, especially natural dyes, have been of unspoken importance in our life for thousands of years, providing not only aesthetic satisfaction but also other useful application. Natural dyes are eco-friendly colorants that derived from biology source and minerals. There are so many plants and algae are have ability to give wide range of color dye due to the presence of categorized colorant compounds. Correspondingly, the photosynthetic synthetic pigments and secondary metabolites, the colors of natural dyes consists of pigments and bioactive compounds that can be enhance the environment and that do not have any harmful effect on other environmental factor. This study will give the some possibilities for using seaweeds as sources of natural dyes, and which are the conditions or process will improve by the efficiency of different solvents and mordant on the natural dyes extraction by selective 3 brown seaweeds. Scope and objectives nowadays, due to the excelling advantage of natural dyes, it become an enticing option over synthetic dye. They are biodegradable, non-toxic, eco-friendly, and easy extraction by boiling the plant material. By the by keep this in mind, the present work is concentrated on extraction of natural dyes from brown seaweeds. Objectives: collection of seaweeds from the local region, extraction of dyes with different solvent, application of dyes to the uncoated cotton threads which treated with different mordant to study the effects of different types of mordant on the dyeing process, observation of fastness properties of natural dyes. Next, materials and methods. Seaweed collection. The 3 brown seaweeds were collected from Hare Island of Gulf of Mannar, Thoothukudi district. Seaweeds were identified with the help of phycology of indica. These 3 seaweeds are I selected for the extraction of natural dye. They are Pedena tetrastomatica, Sargassum tenarimum, Turbinaria ornata. Selection of fibers for dyeing process, I select 100% cotton untreated threads with 3 different diameter. For mordant, for differentiated acetic, alkalic, and metallic mordant, I select acetic acid, sodium bicarbonate mordant, and ferrous sulfate mordant with 2% proportion. Brown seaweed dye extraction. It is obtained by dyes are obtained by succinate extract method in the ratio of 1:20, and that from that dyes concentration of dyes are estimated, and light estimation of light absorption capacity was done with the help of UV visible spectroscopy by the measuring the wavelength of 400 to 663 nanometer, and FTIR spectrometric analysis was done by instrumental center of Ayanada Janagiammal College, Sivagasi. Preliminary phytochemical analysis was done for secondary metabolites, and quantitative analysis was done for primary metabolites. Moderating and dyeing process. Moderating the fibers selectively before dyeing process, that also known as pre-moderating process. The pre-soaked fibers were dipped in required moderating solutions such as acetic acid, ferrous sulfate, and sodium bicarbonate for 20 to 30 minutes at 80 degrees Celsius. Dyeing was done with natural dyes at 85 degrees Celsius for 1 hour. After dyeing, the fibers are cold washed and dried under the shade. Color fastness analysis was done to identify the vast fastness of dyed threads that differentiated by cold water treatment, hot water treatment, and soap water treatment. CIE lab analysis to measuring the dominant color and shades of a dyed fiber. This analysis is helped for this complete this assessment. L means lightness of the color, A means red, and red to shade green shade colors, and B values indicates yellow to blue shades in the material. Result and discussion. In this picture, we can see the different colors obtained from the different solvents, except water extract. Other three extracts are give greenish yellow, yellowish green shades in color. In water extract of all three seaweeds shows the brown shades in it. Dye concentration in seaweed extract, according to the result, except acetone extract, other extract extract by ethanol, methanol, water has more dye in them. Light absorption capacity of seaweed dye extracts. In this result, we can see the aqueous extract of all three seaweeds observe the blue and orange region light, and ethanol extract of Pedana tetrastomatica and Ornata, and water extraction of extract of Sargassum tenarimum are observe the orange region light, and ethanol extraction of all three brown seaweeds are observed red light region. FTR spectrometry analysis. FTR spectral beaks are the indicates for the presence of compound functional groups in the specific observation wavelength. In the wavelength 1000 to 1500 centimeter power of -1 range, considerable isotropic properties have been seen in all three brown seaweeds with low bond groups such as CH2 and CH3 bonds. It was revealed that all samples with the same region demonstrated the isotropic behavior with high bonding groups CH2 and CH3 bonds. We can see all three seaweed analysis shows the region has a sharp beaks in it in the range of 1000 to 1500 wavelength. These are the uh, functional groups and beak values of three seaweeds. Preliminary phytochemical analysis. For this result, for this analysis, dyes were extracted by water had poor result in qualitative analysis, and overall results shows that the ethanol methanol result were more have more positive results. Among four different extract, ethanol extract terminaria shows the presence of maximum number of compounds. In quantitative analysis, sargassum tellurium shows a higher values amounts in carbohydrate, protein, lipid, and for crude fibers, terminaria ornata has a highest value due to their cellular complexity than other two brown seaweeds. Dyed fibers. We can see the the plate 1 to 4 shows the dyed uncoated cotton fibers with 12 different dyes extracted from 3 brown seaweeds. Shades of dyes fibers used by usage of different models can be comparable. In plate 2, acetone and Tabernaria ornata dye extract was not fixed on the on the dyed cotton fiber with or without application of mordant. In LIP values, L values indicate the lightness or darkness. If except ferrous sulfate moderated fibers, all are has lighter shades on it, and for value of A, except aqueous dye extracted dyed fibers and some ferrous sulfate moderated fibers shows the positive result that indicate the red color shade in it, while the B values are all for B values, the all extracts shows the positive values that indicates the yellow shaded dominant in it. In color fastness properties, wash fastness in what fastness property, water cold water wash and hot water wash shows the excellent to good properties in it. In the extraction of water and ethanol solvent, and the soap water wash shows the modern to poor values in the aqueous extraction. Durability of color fastness of dyed fibers. Stored dyed fibers were shown the color difference in storage period. Fibers which dyed with aqueous extract and ethanol extract has excellent durability. Other two dyes extracts does not have a durability fastness. It may be caused by the evaporation properties of solvent used for dye extraction. Summary and conclusion. In this work, the three brown seeds were used as a source for obtain the natural dyes. There are different type of solvents and different type of mordants for used for obtain different shades and excellent fastness properties in the uncoated cotton fibers with different diameters. After extraction of dyes by a toxylate extraction method, uncoated cotton fibers which underwent the pre-moderating process and then they were dyed. The dyed fabric serves different shades of colors based on the modern used and solvent which is used for dye extract. From color fastness assessment, the result shows that the aqueous and ethanol dye extracts has an excellent fastness properties than acetone and methanol dye extract, especially the species Sargassum tenarimum dyes have more excellent properties than other two seaweeds. Fastness properties were not depend on the moderns which used on cotton fibers. To know the phytochemicals which gave color on the fabric and by seaweeds, different experiments were done like preliminary phytochemical analysis, that is qualitative analysis, quantitative analysis of primary phytochemical and FTR analysis. It confirms that the secondary metabolites like flavonoid and tannins are reason for coloring the fabric. Light absorption capacity of the extract by UV spectroscopy was studied. The study confirmed that the presence of flavoride, chlorophyll, gamma carotene, phycocyanin, phycoerythrin, beta carotene, and chlorophyll B. Brown seaweeds were being used as a biological source of the specialized polysaccharides algin that have numerous commercial values like the thickener of paint, cosmetics, food, medicine, etc. There are some seaweeds processing industries present in India for the extraction of alginate form from brown seaweeds. If we commercialize this dye from brown seaweeds, alginate processing industries can extract the dyes before the processing the extraction of alginate. The cultivation of brown seaweeds will increase the income of the seashore living people. In conclusion, there is an urgent need for proper collection, documentation, evaluation, and characterization of dye producing plants and animals, and their dyes, as well as research to overcome the limitations of natural dyes. Thank you. Hello, ma'am.
Anybody wants to ask a question? Next, I call upon Ms. Kishania to present her paper. And the next presenter is Selvanandi.
Ma'am, my screen is visible.
Yes, Kishania, you can go ahead.
Good evening to all. I talk about preliminary phytochemical screening, antibacterial, anti-helminthic, and anti-cancerous activity of Andrographis paniculata extracts, leaf extracts. Introduction. Indian has an ancient heritage of traditional medicine. Andrographis paniculata belongs to the family of Acanthaceae. It comprises of about 250 genera and 2,500 species. It is known as Ilavembu or Siriyanangai in Tamil Nadu, India. As a result, the potential of Andrographis paniculata leaves was assessed in this study by screening its phytochemical, antibacterial, anti-helminthic, and anti-cancerous activities. Collection of plants. Fresh Andrographis paniculata leaves are collected from St. Mary's College in Thoothukudi, Tamil Nadu, India. Fresh Andrographis paniculata leaves were thoroughly washed to remove dust ahead before being shade dried. The dried sample was finally ground into a powder. The powdered sample was sealed in a polythene bag and stored in an airtight container until extraction. Preparation of plant extracts. Approximately 10 grams of Andrographis paniculata leaf powder was extracted with 200 ml of ethanol, acetone, chloroform, and petroleum ether extracts using the Soxhlate apparatus. The extracts were concentrated until they were fully dry, yielding crude residue. The residues were tested for preliminary phytochemical, antibacterial, anti-helminthic, and anti-cancerous activities. Phytochemical analysis. The preliminary phytochemical screening of chloroform, ethanol, acetone, and petroleum ether extracts were present in the table. The results showed that flavonoid and glycoside were found in all the extracts of Andrographis paniculata. And phenol and quinines were absent in all the extracts of Andrographis paniculata. Tannin was adequately present in acetone.
Shamia,
Yes, ma'am.
your screen is not visible.
Tannin was adequately present in acetone, ethanolic extract, but completely absent in the chloroform and petroleum ether. Saponins are present in chloroform and ethanolic extracts. Tannin are present in ethanol and acetone extracts, while alkaloid and flavonoid were absent in ethanol and acetone extracts respectively, but present in chloroform and petroleum ether extract. The medicinal plants are rich in secondary metabolites, which include alkaloid, flavonoid, saponin, and related activity metabolites, which are of great medicinal value and have been extensively used in the drug and pharmaceutical industry. These secondary metabolites are reported to have many biological and therapeutic properties. Recently, number of studies had been reported on the phytochemistry of medicinal plants, particularly on the vegetative parts like leaves. Antibacterial activity. The antibacterial activity of medicinal plant leaf extracts of Andrographis paniculata in 4 different solvents. The solvents are ethanol, acetone, chloroform, and petroleum ether. Was measured against 4 human pathogenic bacteria. The bacteria are E. coli, Escherichia coli, Staphylococcus aureus, Bacillus subtilis, and Vibrio cholerae. The inhibition zone against these species range in size from 3.40 plus or minus 0.76 to 9.90 plus or minus 0.989 mm in diameter. All of the extracts examined prevented the growth of all of the pathogen in the sample. The present study, chloroform and acetone extracts of Andrographis paniculata showed maximum antibacterial activity against E. coli and Staphylococcus aureus. The acetone and algal extracts of Andrographis paniculata with high inhibitory against Bacillus subtilis and Vibrio cholerae. The antibacterial activity of Andrographis paniculata may be due to the presence of active principle called andrographloid. The Andrographis paniculata extracts exhibited very degree of inhibitory activity against the growth of all microorganisms. So this result supports the plants as antimicrobial potential. Anthelmintic activity. The word helminthine comes from Greek word helminthine, which means worm. Helminth is general word that refers to a variety of parasitic worms that live with the body. According to the World Health Organization, over 2 billion people are infected with parasitic worms. Nature and anthelmintic can play an important role in the treatments of these parasitic infections. The present study deals with the anthelmintic properties of Andrographis paniculata, different leaf extract against Eisenia foetida with 50 mg by ml concentration. Observations were made for the time taken to paralyze and death of individual worms. Paralysis was said to occur when worms do not move even the normal saline. Death was concluded when a worm lost their motile, followed with fading away of their body color. The chloroform extracts of Andrographis paniculata was more potent than ethanol, acetone, and petroleum ether extracts. Phytochemical analysis of leaf extracts of Andrographis paniculata revealed the presence of tannin as one of the predominant phytoconstituents. Predominant phytoconstituents.
3 minutes தானே கிசானியா டைம் 20 minutes பண்ற
Tannins, polyphenolic compound that can bind to free proteins in the gastrointestinal tract of host animal or glycoprotein on the cuticle of the parasite and cause death. Anti-cancerous activity. Cancer has been a continuous battle around the world, and there has been a lot of progress in terms of treatments and preventative therapies. The disorder is characterized by the inability to regulate or stop cells in the human body from spreading indefinitely. As a result, there is an emphasis on using alternative cancer treatment and therapies. Medicinal plants have been used in folk medicine in Asian and African culture for thousands of years, and many plants are consumed for their health benefits in the developing countries. According to the World Health Organization, some countries continue to rely on plant-based treatments as their primary source of medication, while developing countries take advantages of naturally sourced components for medical purposes. In our present work, ethanolic leaf extracts of Andrographis paniculata were tested against MCF7 human breast adenocarcinoma cell line with different concentration. The table contains the results which increasing concentration of test compounds. The percentage of growth inhibition of Andrographis paniculata was found to increase. The CTC50 values observed in the leaf extracts of Andrographis paniculata was 13.99, 20.57 in 250 concentration, 4.9497 in 500 concentration, 57.81 in 750 concentration, 59.67 in 1000 concentration. The presence of flavonoid in Andrographis paniculata extracts reduce the risk of cancer. Terpenes have been showed to prevent the growth of cancerous cells, reduce tumor size, low cholesterol levels, and lower the concentration of microorganisms. Different concentration cell line picture.
Isania, what is CTC value, Nana?
Cytotoxic compounds.
Good.
The phytochemical constituents such as flavonoid and terpenoids are the main components that are responsible for the potential cytotoxic activity. The flavonoid have reported for their cytotoxic activity due to the presence of phenolic groups. The plant contains some diterpenoids. However, the major bitter constituent is andrographoloid, which is diterpene lactone. Diterpene and flavonoids are the main chemical constituents of Andrographis paniculata, where are believed to be
Shania?
responsible. Yes, ma'am.
Sorry to interrupt you, ma'am. Can you go for the conclusion part?
Okay, ma'am. Conclusion. The biggest advantages of using plants is that they never have the common associated negative side effects of most allopathic drugs. Based on the finding, we conclude that different extracts of Andrographis paniculata leaf showed secondary metabolites in phytochemical screening are responsible for antibacterial, anthelmintic, and anticancerous activities. Further experiments will extract the compound from leaf of Andrographis paniculata using biological activities. Thank you, ma'am.
Kisania, good. Good work, Kisania.
Thank you, ma'am.
Why can't you, all the students, why can't you show your gratitude towards your guides? Nobody has mentioned the name of your guides in spite of their hectic work.
The next presenter would be Selvanand.
Selvanandi Panna.
Good evening, everyone. Metabolic profiling, a way to guarantee the quality of mushroom cultivated on different agro waste, is my presentation topic. And next slide, please. Malnutrition and inefficient agricultural waste management are the major problems faced by most of the growing countries. Continuous increase in vegetable and meat price and less production leads to the malnutrition deficiency among the people. Mushroom is one of the cheapest great source of nutrition, and its cultivation is one of the best source for the agro waste management. Most of the commercial mushroom cultivars utilize paddy straw as a substrate. Other agro waste are utilized for the research demonstration only. They are not used for the commercial cultivation. This is maybe due to the lack of awareness and the doubt in the quality of mushrooms cultivated on different waste. So the present study was focused on the metabolic profile of mushrooms cultivated upon different agro waste. Materials and method. Two species of oyster mushrooms, namely Pleurotus florida and Pleurotus austriatus, was cultivated on paddy straw, sugarcane bagaces, and banana leaves, and mixture of these three substrates were used for the analysis and paddy straw, banana leaves, and mixture of substrate were considered as substrate A, B, C, and D respectively. Standard protocols were followed to study the moisture content, ash value, qualitative study, quantitative analysis of primary and secondary metabolites. Next slide, please. Please, next slide, please. Or next slide, results slide. And results and discussion. Results obtained from the analysis revealed the following details. In both the species, moisture and total ash content was found to be higher in treatment B. Qualitative analysis. Qualitative analysis revealed the presence of alkaloids, protein, carbohydrates, glycosides, saponins, phenols, tannins, flavonoids, terpenoids, and cardioglycosides in both the species. Steroids, phytosterols, quinone, and flavotannins were reported negative results in selected species. And next slide, please. Next slide. And in both the species, moisture and total ash content was found to be higher in treatment B, that is sugarcane baggage substrate, but there is not much difference was noticed. Next slide, please. And quantitative analysis, aqueous and ethanolic extracts reported highest carbohydrate content in substrate B, followed by substrate D, C, and A in both the species. Next slide. When comparing the two species, Pleurotus austriatus possesses higher protein content. And next slide. Maximum amount of amino acid was observed in Pleurotus austriatus cultivated on substrate B. That is the mixture of 3 substrates. And in next slide. In both the species, substrate B reported the highest lipid content, followed by substrate D, C, and A. And next slide. Secondary metabolites. Secondary metabolites are a group of biomolecules that possess a special role in the protection of human body from various life-threatening diseases and oxidative stresses. And antioxidants such as phenol, flavonoid, and tannins were found to be highest in mushrooms cultivated on substrate B. And other cultivated in substrate B reported the maximum amount of its antioxidants than other substrate. And as next slide, as like the bioconstituents, vitamin B2 and vitamin C also found to be higher in substrate B. Next slide, conclusion slide, please. And from the findings, it is concluded that utilization of different agro-waste materials as a substrate for mushroom cultivation will reduce the adverse environmental effect. Estimated biochemical constituents were found to be higher in other substrate than the paddy straw. And it confirms that the quality and quantity of nutrient contents of mushrooms increased while using different agro-waste. Using different substrate may boost the production rate, which directly leads to the price decrease and increase the availability of mushrooms. And moreover, it is the sustainable way to produce wealth and healthy quality food products to overcome malnutrition and inefficient agro-waste management issues faced by growing countries like India. Thank you all. I especially thank my guide and department staff members for supporting me to complete the project. Thank you all.
Silvanandi, in a very nice presentation, Silvanandi. Actually, the nutrition content or different was obvious in different type of substrate.
Yes, ma'am. I have found
so
that
which one supported best?
Sugarcane bag, yes, ma'am. All the substrate except paddy straw showed the highest value. But in general, we use paddy straw for commercial cultivation. So I encourage the cultivars to use other substrate also for the cultivation purpose.
Equally good. Oh, very well, very well. This paddy straw can be substituted by other waste products.
Yes, ma'am. Yes, ma'am. It can be substituted, and it will give a better yield and nutrition composition also.
But what about the packing process and all? But it's
all
very
the
difficult.
process are, no, ma'am. All the processes are similar like paddy straw cultivation. Paddy straw, we have to sterilize the substrate as like paddy straw, but the yield will be higher than the paddy straw. But the people are not aware of that. They are generally using the paddy straw
process. You sterilize it with the boiling process or treating them with some other chemicals?
No, ma'am. All the substrate was soaked for overnight, and then it was cooked with the help of pressure cooker.
There's some alternative, cheap and best that treating the substrate in formaldehyde.
Yes, ma'am. We can use yes, ma'am. We can use formaldehyde, but I have a doubt that whether formaldehyde cause any side effects to humans or not. I don't know. I'm not confident about that. That's why I didn't follow that formaldehyde
that will evaporate very soon. Just treating, no. Just
yes, ma'am. Yes, ma'am.
I mean, just sterilizing, no. We are not soaking so much of time. Just we are dipping and killing the fungal attack around the substrate. That's all. Nothing will happen. You try the next.
Okay, ma'am. Definitely, I will try.
Very good presentation. Okay.
Okay. Thank you so much, ma'am.
Okay. Okay.
Thank you, ma'am. Thank you all for the
Okay,
opportunity.
Selvanandi. Okay, thank you. Thank you, Jennifer. Over.
Yes, ma'am. Yes, ma'am. It got over.
You say a word of thanks.
Yeah,
and
sure.
bind.
Dear participants, with this, we are coming to the end of the technical session. I take this opportunity to thank the chairpersons for this technical session, our beloved HOD, Dr. Glory ma'am, and Professor Jennifer Ann ma'am for their patient listening and encouragement to the students. Thank you, ma'am. May I now call upon Dr. Soumya, Assistant Professor of Botany, to propose the official vote of thanks for this program.
Am I audible?
Yes,
Yes.
ma'am.
Thank you. Respected dignitaries, invitees, participants, and my dear students, I'm feeling honored to get this opportunity to say the last word of this international e-conference, the vote of thanks. We are living in an unbelievably fast-changing world. Look, once upon a time, a signature and a photograph were all you needed to prove your identity. But in anxious digital times, we need to be able to prove it beyond reasonable doubt in a variety of physical and virtual situations. Q biometrics, verbal signatures, body scanning, and even signatures based on your body smell. Here we have discussed such dramatic changes evolving around us. In this virtual platform, we have deliberated on a variety of topics on science and technology, especially renewable energy, liquid crystals, AI and automation, search for planets beyond the solar system, and applications of RNA technology. Moreover, a host of research papers were presented in this platform. We are grateful to the resource persons, paper presenters, participants, our patron and secretary to the college, Reverend Sister Flora Mary, and our beloved principal, Reverend Sister Dr. Lucia Rose, college management, HODs and faculty members from other departments, and those who directly or indirectly supported to make this international e-conference possible. I, on behalf of the Department of Botany, place and record our sincere gratitude for your efforts, presence, and support. Last but not the least, I place and record our sincere gratitude to Dr. Glory, Head of the Department of Botany, Reverend Sister Dr. Aroke Genesius Alphonse, and each and every faculty members of the Department of Botany and supportive staff for their invaluable support, stress, strain, and hard work. It's you made this magnificent event possible. With much sense of gratitude, signing off, Dr. Soumya. Thank you.
Thank you, Soumya, ma'am.
Bye. Thank you so much for all of you. Great success.
Ma'am, we shall have the college anthem, ma'am.
Yes.
Dear participants, kindly join us with the college anthem.